No. So for the first one, I don't do the introduction, I'll do it for the second one, okay? Welcome to the last day of No Time to Wait. It's Friday, quite a beautiful day outside, more beautiful day inside. So how have you been? Everyone good? Fine. Yeah, we've got the last day of No Time to Wait ahead of us. And for that reason, we've got Dave Rice talking about how No Time to Wait works, which is very important for all of us because we all love this conference. Dave, take it away.
Good morning, everyone. My name is Dave Rice. I'm here to offer a presentation about this very conference, No Time to Wait. As many of you watched the presentations, you might be asking yourself, who paid for this? How did this happen? So I'm going to get into these details here. Generally, I've offered this very concise presentation on the Friday morning of each of the last couple of No Time to Waits, just as an effort to be quite transparent about what it takes to get a gathering like this to be possible. So these are the primary components involved in the process. I reuse this slide every year because these contributions and the need for them are constant and true. Firstly is time. This includes all the time of the committees, like the organizing committee and our collaboration of the host committee. A ton of drafting email, curating the program, like social media work, fundraising, policy development, and other aspects that are happening sort of throughout the year that lead to us gathering here. But then to add to all the efforts that are happening before, during, and after the program, such as like the graphic design for the program and printing it, the volunteers that are helping coordinate our stage, our live stream, supporting our remote presenters. Like, you know, all this sort of time from like volunteers, and I guess essentially everybody's a volunteer. That's not like No Time to Wait has any like paid staff, but all this time is needed to create the space to welcome us all here. And then, you know, certainly the host organization is also dedicating a tremendous amount of time towards supporting this. It's kind of an ongoing collaboration where we're, you know, the host organization is making space, contributing to the program, and welcoming us. And the next major component is money. No Time to Wait is a free registration conference, and but we really need financial support to help bring us together. So we wish to thank a lot of our sponsors, like Being Media Area, the Digital Preservation Coalition, Memoria, CNA, AV Preservation by RetroCH, and ZKM itself for their financial support. I'll get more into the details of that support and our expenses in the subsequent slides. The last component is love. What a dull conference this would be if it was only run on money and time. Throughout the presentations, we find love in our service to communities through our shared discoveries, within generous skill sharing, and the passion for the objects in our collection. As someone working quite a bit in issue trackers and pull requests, I can say that often one of the most motivating bits of data is the kind comment of encouragement or gratitude. You know, so I'm always quite moved at this conference to see the sort of like collaboration, share, feedback that folks are giving one another to support their work. So I wanted to review a bit of the history. For No Time to Wait 5, we were able to gather sponsorship from these organizations. A lot of them I had already mentioned, and we're able to raise a total of 6,900 euros. For this year, this was the year, like our planned conference was quite adjusted at the last minute because of the Omicron spike in the pandemic. So the entire conference was moved to a very cute online venue called GatherTown, where if you were there, you had a little 8-bit character moving around like essentially a video game to socialize and give presentations. Because of this, we were able to the conference was quite a bit cheaper than $6,900. So for No Time to Wait 6, we didn't necessarily need to fundraise as much. We had these two funders essentially, and some individual contributions to Media Area coming to $2,700, and then we used $4,400 of the extra balance from the pandemic version of No Time to Wait. And this gave us the $7,100 we needed to run the No Time to Wait that occurred 2 years ago in The Hague. Last year we were in Prague. We had a slightly different list of funders. We were still carrying over some extra funding from No Time to Wait 5. I believe this was potentially like our highest budgeted No Time to Wait, and I remember we were quite proud to say that we had like the most amount of travel grants for any of our conferences thus far. And then with this one, we're out of this sort of extra money we had saved from the pandemic conference. So this particular conference, we raised €44.50 from these individuals, or these organizations and individuals. And then I wanted to get into the expenses. This year, we were not able to support as much travel grants because of the total amount of fundraising we had. So we just had €250 going out to travel grants. There were also some like additional programs from the DPC and DPOE that were like funding travel grants to participants directly rather than contributing money to the No Time to Wait organizers to dish out. The second major expense is that we support the travel and lodging of the organizing committee, which is 4 of us. I was able to reduce this a bit by getting a DPOE grant myself to attend here. So this was only $15.50. We spent about €150 on printing out the programs, and then the social dinner last night, I'm not sure if we have the final bill yet, but we expected it to be about €2,600 for everything that happened last night, which I don't think is too bad. So the difference between our expenses, $44.50, and our fundraising, $44.50, we're only off €100 at this point, so I feel like we're doing okay. And then there's a couple of acknowledgements I want to give. I definitely want to acknowledge that media area invests a tremendous amount of coordination, administrative support, and time in helping manage the finances and sort of being the sort of institutional core of a conference that moves around quite a bit. And then obviously, ZKM as our host is making such a substantial contribution by offering us this space, all the technical support, but then the staff members of the host organization, ZKM, that are participating on the host committee are jumping into all of our planning meetings, helping us with the program, designing the emails and stuff. And then not only are they letting into this space, but they're also giving us a tremendous amount of sandwiches when we're hungry and coffee. And then, it's important to acknowledge that it's not just the time of the hosts and the organizers, but also everyone presenting is contributing an enormous amount of time in preparing your presentations. So I want to thank the expertise of the volunteers, organizers, and presenters. And then, certainly for the attendees that are, for all of us, there's an additional layer of cost and time because we are all in conversations with our bosses or trying to figure out how to afford the travel. Even though it's a free registration conference, hotels and flights are quite expensive. All right, so this is my presentation. If anybody has any questions about how this conference runs, I can try to answer it. But that's the little financial report about No Time to Wait 8, and some of the organizers will be back at the end of the day to talk about No Time to Wait 9.
Are there any questions for Dave or for the No Time to Wait organizing committee?
Cool.
Okay.
I just wanted to say a huge thank you for doing this. And having put conferences together myself that cost $30,000 or $40,000, I know what a huge accomplishment it is that you offer a registration-free event that is so low threshold for all of us to attend, especially in times where we have to, fight for every bit of travel funding that we can get. So thank you for that, and happy birthday, Dave.
Thank you for your question, Joanna.
Okay, thank you very much. We're headed to our second presentation of the day. Marion and Jerome, they prepared a topic about checksums.
This one is
Would you like? Not really. Okay, they're gonna update the latest version.
this one?
How to
Thank you.
file integrity, but yeah, that's fine.
Okay, hi. I start off with the first part of our presentation. My name is Marin Jax. I work at the Austrian Mediathek. I just introduced myself. I worked in video digitization for over 10 years, and now I'm taking care of our digital archive. I want to start off to introduce my institution because I think we are very diverse institutions, and many things how we do depend on our institutional goals. So the Austrian Mediathek is Austria's audio and video archive. I think it's so small on my. Could I help? Okay, it's so small here that I can't read.
I can.
So now I can read, and this helps me as a non-native speaker. So our goal is to collect and preserve audiovisual cultural heritage, except for film and photographic material. We were founded in 1960 as the Austrian Phonothek. So the hugest part of our collection is audio. It's about 90% compared to video, which is about 10% of our collection. And since 2001, we are a branch of the Vienna Technical Museum. The contents that we collect are on topics like music, theater, literature, history, politics, and science. What is special about the Austrian Mediathek? We have no institutional link to production. We are active in building our collection, so we really have to approach other institutions who have collections and work on cooperations to expand our collection. We focus on preservation and not on presentation, and this has to do a lot with that for the larger part of our collections, we're legally not allowed to show it online or only in part when you visit us directly. The digital collection of the Austrian Mediathek. So our digital file handover started in the early 2000s, and since 2014 the handovers accelerated rather quickly. We get audio and video directly either from producers or for, I think it's the main part is initiators. The files that we get are mainly made for documentation purposes. I'm now going to talk about the digital collection, who is of external origin, which I think is very different because we digitize in-house and we make TV, radio recordings in-house. I'm not going to talk about that. So only the hand hours that are provided externally. It often comes from oral history interviews, from historians, scientific projects. Many times it's theater recordings from other institutions. We have recordings of discussions, speeches, literature readings, sometimes filmmakers, musicians or collectors. And we have recordings from the Austrian Parliament, which also come in digital form. One thing is that the files come as they are. They are often handed over years after the production of the files, and the history of the files is in most cases totally unknown. The files were not created with having an initial archiving purpose. They were often created as a copy to work with it. For example, a theater documentation to know how to create this thing when someone has to step in, for example, or the providing of checksums is mostly impossible. So we tried this over many years to talk with the people who hand over files to get checksums, and it's so time-consuming, and it's really giving IT support that we don't have the time to get into that. The files often come as mixed media. We often get duplicates, copies, clips, and whatsoever. So it's really often a kind of a file dump of whatever they have. The producers don't have, most of the times have no or little knowledge of AV or IT. And we as the Austrian Mediathek, we have no control over the composition or the condition of the files. This is a screenshot of the tool that we use to manage our digital collection. So it's just quickly, I've given lots of other presentations on that. It's basically a search engine who uses crawlers to get all the information about the data. And as a next step for our institution, we want to get more and deeper into the analysis of our files. So at the moment, on a file base, I have to get quicker. We only extract the file extension, and we want to go on to use MediaInfo to filter more of our files. So you can do a filter of all the codecs in your archive or all the resolutions that you have and so on. So working together with MediaInfo was planned. This is just how files get into our archive over different sources or internet transfers and so on. And now I go on to the story. It's shortly before last No Time to Wait, I came across a file that was handed over from someone else. And for every file that we import to our digital archive, we do stream hashes. So for the video stream and for the audio stream. This is just in preparation if we do a lossless conversation that we can, conversion, that we can verify that. So in this case of the file, we could not create the stream hashes because the file was broken. And that's what kept me thinking about, even if the checksum chain in our institution is fully controlled from the handover on, the files might be defect and you might not know. And that's why I talked to Jerome in Prague. What about checking file corruption with MediaInfo? Yeah. I added this picture because I think they always wanted to know about corruption. I think you have to be brave to face that, because every time you look closer, you get more work in your archive and you don't get more people. But actually our job is to look closer and even closer, so we do that anyways. So this is just an example of a conformance error that we now have as an output in MediaInfo. And what we did is that we wanted to do checks mostly on a container level to keep it really quickly. And we implemented, or Jerome implemented, the most common file formats in our archive. We went deeper with MP4, AVC, and AAC because we expected at the Austrian Mediathek that most errors would occur there. And yeah, now we'll hand over to Jerome and this.
While Jerome prepares his presentation, I wanted to say that everyone, of course, knows Jerome. He's an open source developer, and he's the main person behind Media Area. So, Jerome, take it away.
So we get a lot of tools already ready. For example, MediaInfo supports the analyzing of several file formats, but MediaInfo at the beginning was more for just a report about what is the file format, what is the video stream format, and so on. And above that, there was some sponsorship for creating a conformance checker. And beyond just having a reporting about what is the content of the file, we created a conformance checker thanks to a sponsoring, but only on Matroska, FFV1, and FLAC and PCM, because it was the main focus from the initial sponsor. Then we got other fundings for adding more checks on specific file format or specific audio format like ADM, and it was USAC. USAC is like AAC, but the new version of AAC. And the sponsor wanted a full conformance checker, and they were ready to pay for that, so we did that. We were able also to add more format for analyzing, but just a quick analyzing, because there is a difference about implementing a full conformance checker and just a quick analyzing at the beginning. When I talked with Marianne, she said at the beginning, I want everything. I want to be sure that there is no issue in my files. Yeah, okay, but do you have the money for that? And okay, a full conformance checker is very expensive, but you actually don't always need a full conformance checker, and we can find a good balance between what you need and what we can develop at a low cost. So we need to discuss always for knowing what is the limit between what you want and the cost. And we find something, a compromise, something in between, trying to check the header of each frame. So checking that is the file coherent? Do you have, if for example, the file at the beginning in the file header says I am 1 gigabyte big, and your file is only 1 kilobyte, maybe there is an issue, and we can automatically detect that, and it is not complicated. So let's do that at the beginning. An example. Marianne had a couple of WAV files, and it was when you play it in VLC, it is 2 seconds. Okay, but the file is big. It is 20 megabytes, and it is 2 seconds. It is not normal. And if you do just a raw copy with FFmpeg, for example, there is no error message, and it is totally legitimate. The file header says that the content is not so big, only 250 kilobytes. We do that. The result is a lot smaller. It is just a raw copy, so it should be exactly the same. But FFmpeg truncate because the file header says it is a short file. And you see no error. When you play it in your player, actually no error. In FFmpeg, no error. But the content is still there. So now in MediaConch and MediaInfo, we implement a check saying, we check if the file has an integrity. And now we have a report. The report is very technical. It is based on the specifications. So it just try to see, is there a coherency in the file? So it is a bit cryptic, but at least you have an error message. With FFmpeg, with your player, you have no error. And then we can know that there is an issue, you have a flag. If you check all your repository with all your files, you have a list of files with errors, and you can check deeper. This is the first implementation currently, and Marianne provided me some example of the results, and I did some analyzing, and sometimes it is, oh, okay, the MP3 file, for example, the end of the MP3 file is weird, but it is only null bytes. So it is not valid, but it is not a loss of content. So we need to tweak a bit now the tool, because there are some check with a low priority, so it is bad, but you don't lose content. For the WAV file, it is very bad. So we need to ponderate what is the priority and so on. And we need to decide what we do with that. Will we curate the content or not? So now we will filter. So we will do this kind of update of a tool saying there is a priority, what is very important and what is not. That's all, and you, for me, again for you. It was,
Yeah, we still have about 9 minutes.
Beginning again.
Oh, yeah,
Sorry.
sorry about that.
sorry.
we are continuing.
Yeah, Marion, still talk.
Sorry. At the moment we're still getting results. So every day I look what's waiting for me, and if I get new conformance errors, that's the last day, like 2 days ago. I have checked 4,771 files. It's important to say that it's non-curated material, so we have duplicates, clips, and whatsoever. So not everything of them will eventually be taken over to our collection. But 409 files had a conformance error, which I did not expect at all. This is such a high rate. Most of it get the error message, file size is less than expected. Okay, so this is just the results of the check that I've done. I said initially that we expected to have most errors in MP4, AVC, AEC, because that's what we saw. We did not expect that we have the highest rate in the WAV files that we got. So it's a 10% rate of errors in WAV, and we have a 13% rate of errors in MP3. We are currently getting more results, and we want to go deeper into analysis, but the quick analysis that Jerome did is that it's actually not that bad, because most of the cases do not really corrupt the content, but still it's not conform, and I think that's an important thing to know. I think that this output is important information for artists. It might be that you also have a lot of errors in your collections that you don't know about and that you feel safe with your WAV files. So I will end off with, wanted to end with a conclusion, but I decided to talk about consequences about this. First of all, in preservation strategy. I think that this is a really strong case to keep the born digital original and not only normalized files. Because even if you normalize lossless, you could lose some content. So this is one consequence. Another consequence is for our workflow. We need to do immediate feedback after file handover, and this is what I said earlier. You don't get more people when you have to do more work. So we will have to adapt our workflow that for every handover we will run those kinds of checks. This only makes sense if you might be able to change something. So the only chance that we will have is get back to the institution who handed us these files over and ask them if they have another copy maybe, or maybe they can run checksums. But I think for many, many cases, since the handovers take place years after their production and the history is unknown, that the corruption might be somewhere in the past, so irreversible. Yeah, checksum checks are not enough. So the next steps, we are going to run these checks over the whole digital archive. We are going to collect more error cases and analysis, and we want to refine the error messages to separate minor from major issues. One idea that I really think is interesting was from Jerome of maybe thinking about an automatic repair of WAV containers. So I think that could be an interesting thing for many institutions in our field. Next steps might also be up to you. So maybe you want more checks, other formats, and you're invited to join the funding. I want to end this talk with a quote from Jerome. Don't trust the file. Thank you.
Thank you, Marion and Jerome. Now we have some 4 minutes for questions. Okay, I'll start over here.
That was so interesting. Did you check the corrupted files against the method of file delivery? Because I saw that you also, you have you accept via hard drive, you accept via online transfer. Were you able to link the high quotas with the online transfer, for example?
No, we were not able to link that. No.
But you checked, and it's regardless.
It's
of the
regardless.
method of
Most of the content that we get is still on hard disk drives. Yeah.
Thank you.
Okay, we've got another question.
Hello, it's a bit related. I think some of the errors that you see might come from the actual program that created the
Yes.
file. For example, in WAV file, it's easy to make a mistake at the beginning when you calculate the whole size. So, and for example, there was also MPEG-TS, depending on where it's coming from, if it's from capture from, I don't know, terrestrial emission or something like that, or satellite, then usually there's errors that's what the format is designed for. So it's not actually a damaging error because it's part of the where it's coming from. So maybe do you have an analysis of when an error is actually the file was damaged or it was actually like that in the source?
So unfortunately, we don't have the name of the encoder in the WAV files, in the buggy WAV files. So we don't know. For the WAV files, we are sure it is the encoder. So it is so stupid file header. It is a bad encoder. But for other files like MPEG-TS or the MP4, it is a bad transfer because 99% of the frames are good, but a couple of frames are bad. So it is during the transfer. Sometimes it happens during the transfer, sometimes it is due to the encoder. We can know for each file what it is, but yeah, it can happen from everywhere.
Have time for another question? Yes.
You spoke about considering automatic repair of the corrupted WAV containers, and you also mentioned about retaining the original file. So if you do that, would you keep a copy of both files? So the version that's corrupt and then the repaired version?
I would definitely do that.
But we can also optimize the storage by storing the list of the changed byte. For example, in the WAV file, 99% of the content will not be changed. We will change only the file header. So we will discuss about, do we keep a copy of both files, of the original file and the modified file, or do we just log the changes? There is a discussion about how we do that in the workflow. So both are possible, to keep both files or just the log.
So at the Mediatek, we want to play it safe. So we store the original as original. So I don't know what happens in the future, and there always might be a reason to go back to the original file.
Thank you. Any other questions in the audience? Thank you very much, Marion and Jerome.
There is a question. Oh, there is a question.
So I understand this already in the public or published version of MediaInfo?
Some checks are already in the public version, and some other checks are in the development version. So we have snapshots. We can send the link. So it is public, but not directly on the main web page of MediaInfo.
Okay.
So just drop me an email and send you the link to the snapshot repository.
Thank you.
Okay, I'll give it more time. Do we have
One more.
questions?
Hi, so my question is Actually, twofold. The one is are those tracks only added to Media Info at the moment, or are those also going to be part of Media Conch, for example?
So it is in both Media Info and Media Conch. So Media Info, you have just a text or XML output, and in Media Conch you can have more advanced features about having a list of files and with a graphical view of the files which are good or not good. So at the beginning, we started 2 different projects. MediaConch was based on Media Info, but all the error output was only in MediaConch. But the sponsor and the users said, yeah, but MediaConch is one thing, but Media Info is installed everywhere, so please put something in Media Info for also saying that there is an error, so everyone can see it. So in Media Info, it is a small binary. We want to keep it small, so you just have the text output. So in the basic interface, you have a warning, oh, you have X conformance errors. And in the text output, you have a list of errors, but just in text. And in MediaConch, after that, if you want, you can have more automation about a list of files and so on. But it is in both.
And the related question to the errors themselves, are those usually just going to be text-based, or do you also have error codes that could be standardized to?
Currently, it is mostly text-based, and if there is a sponsorship for more structured data, we will do that. But for the moment, we try to keep low cost, so we stay in the Media Info report thing, so it is a text output. But yeah, again, it depends on, we need to find a good balance between the cost and what you want. So currently it is a text output, but we would like to have a more advanced output in the future, depending on the sponsorship.
Okay, thank you. That was a great presentation, Marion and Jerome. Okay, thanks. Now we will welcome Sarah Gentile from MoMA presenting.
Should be on today's. Oh, there we go. And that's the PowerPoint. Let me do the.
We do have LibreOffice.
This one?
Do this one, yeah. Hello. Thank you, Jerome and Marianne. I definitely am going to be following the Media Info output of errors. I think that's something we all need. But today I'm going to talk to you about working with vendors with open source tools. My name is Sarah Gentile. I'm coming to you from MoMA. This is a picture of MoMA, located in New York. And the reason why I chose this photograph is because if you look very carefully, on the 3rd floor there, you can see the film department. And I'm going to focus a lot on my work with the film department, although I work with all the departments in MoMA, coming from the media conservation department. A lot of the footprint of our storage is generated from preservation projects, because the film department was created not long after the founding of MoMA in the 1930s, in 1935. So it's one of the largest film archives film collections in the United States, and has a lot of preservation projects going on. So the media conservation team is responsible for a lot of that content, and I'll talk to you about the challenges that presents. So I wanted to talk to you about why I'm here and what this whole talk is about, which is really about films like this. I borrowed heavily because my talk is not very visual and I don't have a lot of beautiful media art to show you, but I do have these stills from an incredible film that was an early hand-colored film, The Serpentine Dance, which is was currently showed in an exhibition at MoMA focusing on color in film before Technicolor. So it's films like this that are the bedrock of the film preservation program, and I just think that they're super beautiful. You used to see this in your vaudeville, and then it was like early transfers to film, so I'll be borrowing heavily from the two films that document this dance, although it was done by many performers. So, as I was saying, MoMA has a lot of film. This is a small section of the film department's reels that you'll find in Hamlin, Pennsylvania. I have a picture of that later, so hold on. Just wanted to give you a sense of where I'm coming from. I'm in the media conservation department at MoMA. I work with 2 full-time media conservators. I am not a media conservator, but I am a digital preservation specialist. The film department itself is quite large, but the people that I work with directly in the film department are the film conservation manager, collections manager, and quite something I wanted to point out is that we have no film cataloger at the moment. And this is the I wanted to talk to you about the Film Preservation Center, which is state-of-the-art, super beautiful in a very rural part of Pennsylvania called Hamlin. It's incredible if you get a chance to go see it, the work that's done there. It's an enormous storage facility for us, and it's a place where we can store our nitrates safely. So an incredible institution, kind of part of our institution, but also almost an institution in and of itself. There's a small staff running that as well, but we work separately from them, of course. And when we got to the film cataloging, which was taking quite a bit of our time and taking up all the ability to actually work with these materials, we needed to streamline the process. And I think it was Andreas and Caroline that talked about using Ferber in their work. Our film department follows FIAF and really focuses on using Ferber. I always feel like the manifestation level gets skipped, but Ferber is super useful for describing your related works. It's an incredible tool for describing and cataloging. So the only problem is the rest of MoMA's collection is not based in Ferber. So there's problems within TMS, and anyone loves a beautiful screenshot of TMS can see that when we had to catalog all these materials on the item level, it was taking a lot of our time. Just a lot of our time, because a lot of materials were coming back. So we were innovative and we decided, let's just catalog this on the shuttle level, because our current storage allows us to take these materials down and repackage them when we get to that point. I'm not sure it will ever happen, but it allows for safe storage. It allows us to fully describe these materials. And I don't know if you can see right there, but the element type tells you what materials are there. So there's a DCP, there's DPX, there's an H.264, there's a ProRes. So you know what you have in that shuttle and you can retrieve it. So doing this in a kind of a way of bundling everything together allowed us to streamline this process. However, it didn't solve the problem, because in order to put things into our digital repository for museum collections, the DRMC, which is based on an OAIS model, we have to do a lot to separate the materials from that go into our cloud tier, that go into our local tier. We have analog backups of those files that are being preserved so they can stay locally, because we have more copies. Everything's following locks. We're good. It's not a problem. But we still have to, in order to get things into Archivematica and to package them properly and get all that robust metadata, we have to individually bag elements. And that can take a lot of time, even with batch bagging scripts. So preservation, safe preservation means transferring things off drives, cataloging them and bagging and processing them through Archivematica with our software partners, Artifactual. This is just so much time, so much material and so much time. So just to give you a sense of stats, because everyone likes looking at stats, we have about 50 preservation projects a year. That's like based on title. There are about 5 preservation vendors in play in the New York area that we tend to work with. We have about north of a petabyte of material just in the film department. Only a little less than half is safely stored at this point, and it's been my focus and work based on a lot of the great and groundbreaking work of Flaminia Fortunato and Caroline Gill, who were here at MoMA, or not here, but at MoMA, and had researched using raw cooked. We were able to work on ways to ingest and get rid of this material or get it off of drive and into safe storage. But since we can't do it all ourselves, we realized we need to task these vendors with doing some of the work, the prep work for us. So first we asked them to process the image sequence. So again, raw cooking, that has been our hero. Thank you, Jerome. And sometimes because these files are unique or these films are unique and the asks from curators are unique, they don't have every key. We encourage them to buy keys when they can. But a lot of the time we just have them tar if they're having trouble with the raw cooked, but we try to walk them through it. We also just do the really basic work of like, hey, name the files right, name the folders right, and oh, thanks. And Peter, I'm sorry, they haven't figured out a way to use your file and folder naming tool. So we asked for that. I'm going to burn through these slides pretty quickly. And we've asked them to package it for delivery using Bagot. And so the results, I should have put a drum roll, but that would have been cheesy. Okay, so everyone needed a little bit of guidance when we asked them to do this work. There were long email chains, different levels of technical knowledge, lots of technical knowledge coming from a PC base that frankly I wasn't the best to help with. But a lot of times they also delivered the DPX files along with the raw cooked materials. However, taking that drive and transferring the files off of the drive into our preservation system pretty quickly felt incredible. One rsync command and everything was going where it needed to go. So there's challenges in communication, avoiding jargon, talking to people in a way that they can understand what's going on. Also the fact that we're dealing with different computing environments. There's people dealing with the processing speeds of their only available computers. These are tight labs that don't have a ton of extra resources to devote to just letting a machine whir in the background and churn on these files. And it's a different community. These people work in film preservation, but they're not archivists in the way that or focused on the kind of archival work that we are focused on. So there's not a ton of overlap. This is not exactly a Venn diagram. That's why you see this going on. So I wanted to talk about the fact that also there's open source tools that they're using, but they're used to enterprise software, a lot of it coming from the film industry, which is a little more hand-holding. So that has also been a challenge. And just because, I thought maybe I took out this slide. I'm ending soon, so I'll just say that one of the advantages of this method is it's allowed us to occasionally use things like Media Shuttle, which can deliver like really large content pretty quickly, and once we have the checksums provided, we can feel pretty confident that we received what we thought we wanted to receive. However, there are challenges here that you can see, so I'm not going to call out, but hard drives are expensive and have a lot of rare earth minerals. It's kind of nice to avoid that. And so I'm just, my last two slides, I'm just saying that really I came here to ask all of you if you have tips to help us to talk with these vendors. If you're working in your organization and have ways of communicating these tools a little bit better to people outside of this room and people who don't have these this knowledge and the joy of meeting Jerome, and if you have tips for us and want to work with us, let us know, reach out to me. And I want to thank these people, and that's it. I'll cede my time.
Thank you very much, Sarah. That was impressive. Unfortunately, we have no time for questions, so please go back to Sarah on the coffee break. And now, do we have Nastasia and Lode coming up for presenting their presentation?
Okay. There's a folder. Let's just close it. Yes, and then Friday, Thursday, Friday before lunch, and then you find yourself. All right. F5 maybe, that we also see. Shift F5. Yeah. Yes, that's it. Okay.
All right.
You fine with the view like this? That's right.
No, it's fine.
I can some notes off already.
Oh, we got some notes. Okay, there. Nice. Hi, everyone. My name is Lode, and we're going to start with a video to get you all in the right mood. A little bit of nostalgia of old data carriers. So now if you push next one to play, then if it doesn't play, I'm sorry, it's an old video from the Zip commercial, which is basically saying that you can store everything on a 100 megabyte zip drive. I will send the link from YouTube in the WhatsApp group, because apparently it doesn't really work from YouTube. So I'll start with just introducing ourselves and our organization. This is all our colleagues at Memo, and those two arrows. Oh, excuse me. The little arrows is me, and then on the right side is Nastasia. And our colleagues at Memo, we provide advice and practical support to cultural media and government organizations which take care for their archives. And we aim to make archival materials accessible and usable, and we also preserve it for the future. So that was our complete team, but Nastasia and I are part of the expertise team. And all the people in the circles on these pictures are also part of our expertise team. So we share our acquired expertise on digital heritage processes with other organizations, for example, by responding to requests for advice, organizing training sessions, setting up projects, and providing information through presentations like this one and our knowledge base. So the service we're going to talk about today is called the IDA Capture Lab. It was previously known as the Digital Repair Cafe. And it's a service we provide at Memo to retrieve information from outdated data carriers. We call them outdated data carriers because they're not able to be read anymore by modern computers readily available. For example, the reading equipment is no longer available in stores, or because modern computers are not longer available, have the ability to read the equipment. This is an overview of the data carriers we can capture at the moment. So from old to semi-recent, 2005. The old one is 1976. So we start with the mini floppy, micro floppy,
We go to the DDS tape, the zip disk, the jazz disks, and then to the micro SD card, and also like the hard drives and stuff.
So IDA Capture Lab is a service of IDA, and IDA is a collaboration between 7 organizations, of which are 5 archive institutions. We decided to work together to improve the care of the digital archives. And IDA Capture Lab is a result of a project called Digital Repair Cafe, and which had the aim to set up a service for reading data of obsolete carriers. So why did we start this project? Because every heritage institutions, from large museums to little small local history societies, are confronted with this type of material, and it's impossible for all of them to set up a service like this. So it requires specific knowledge about the drives and the disks, and also the devices we use are rare, so it's not easy for all these organizations to find the devices themselves. It requires also money, because the devices are sometimes rare and thus expensive. So it was a better idea to work together, to combine all our budgets, and to buy these together. The service is operated by MEMO, our organization, because we already had expertise on this topic. We experimented with these materials since 2017, so that's why we do the service. So our goal is to save the entire content of an obsolete disk and save it on modern media. So the goal is that the captured content of the disk is identical to the original disk, and it's fun. It's nice if the content could also be consulted. It's not always possible, because sometimes disks are damaged and then they can be mounted and you can't consult the files, or sometimes the media is obsolete and you don't have computers that can open them, and then emulation is required. So we do this by creating disk images. Disk image is an identical copy in a digital file that is identical to the disk. We chose this method for several reasons. Because it's not always possible to mount the disks with the computer, because it's obsolete, but also it gives us more guarantees that the transfer went correctly. And also there isn't a risk of a lot of metadata, because sometimes there's also metadata in the file system that is necessary, like, for example, the last modified date, the owner of the file, but also old Macintosh disks, they didn't have a file extension. So this information was kept in the file system, and if you lose this information, it's difficult to know what files you have in the copy. We have 4 setups to create a disk image, and I'm going to go over them now. So this is the general one. We call them the general because it's the setup that's suited for most of our devices. You can use them for devices from the mid-90s until now. It consists of 4 components. So the first one is the original drive. So this is on the slide you see a zip and a jazz disk, and that's an original jazz drive. The second component is the cable, or an adapter cable. So jazz disk had SCSI interfaces, and our modern computer has USB interface. So we need to look for a cable that could, a SCSI to USB cable. So what you see on this slide is a very expensive cable. Then the third component is a write blocker. A write blocker takes care that the computer doesn't write on the original disk, so it stops the write command of the computer. So this is the write blocker more in detail. It's one of Tableau we use. There are other brands. And the fourth component is our workstation with forensic software. We use this software to create a disk image, but also to get the files of the disk image. And as forensic software, we use the BitCurator environment. It's a specialized Linux version. It's free and open source, and it's created by universities and other organizations that preserve digital archives. So this is the software you use for creating disk images. It's called Keymager. It's a Linux software, open source. It takes care. It makes checksum to make sure that the copy is identical to the original disk. Then the second workflow is our workflow for floppies. It's a different setup because the data is stored differently on floppies. It are magnetic signals, like radio signals, and you need an interpreter that translates these magnetic signals to computer data. And there are simply no USB devices for all diskettes or floppies, so you always need something between the floppy disk and your computer. We use CryoFlux to do that. So this is a device that can control the floppy drive to get the data from the floppy. This is the CryoFlux software, and this is the interpreter. So it translates these magnetic signals and it creates a disk image of the magnetic data. And this is our third setup. It's a setup for tapes, because also on tapes, files are stored differently. They are stored sequentially, like on an audio tape or an audio CD. So files are written as tracks. So you have an archive file per track. And we use Tape Imager to create images of tapes. Tape Imager is also open source software. It's created by Johan van der Knijf. He works at the Dutch Royal Library. And it creates an image per track. So you have different images of each track. When it has viewed the last track, it rewinds the tape and then it ejects the tape. So the tape workflow is a bit different because you have different images per track, and it's not a complete copy of the disk, of the carrier. So you then have to find out what the software was that created the track. So if you're lucky, it's a TAR file. It's a file that we still use, that you still can open. But if you're unlucky, it could be created with old backup software from the 90s that no longer exists. And then it becomes a challenge to get the files out of the image. And we use Siegfried for file identification. So, and this is a fourth setup. Loda?
So the hard disk is quite easy, so we can read them individually or at a time. In some cases, the visitors for the IDA Capture Lab don't need a whole disk, including the empty space. So there is no need to create a disk image. We prefer it, but we can do it with AirSync to keep the original modified date, and then we prevent the larger disk image. For exporting the files from the disk image, there's again some solutions on the Bit Curator system. In this case, I think it's the HiveS Explorer. And we haven't really worked out manuals for exporting data from disk images yet, but it's certainly possible and we can do it. This is an example of a disk image that was not able to be exported with the provided software, and so we opted for the emulation instead. In this case, this is the emulation for Apple System 1 and the first Apple Macintosh system released in 1984. The files on the disks turned out to be made with Aldus PageMaker 3, the predecessor of Adobe PageMaker and now InDesign. We know this from metadata of the disk image. So what happens when a new carrier comes at IDA Capture Lab? We go through a very simple steps. So can we identify the driver, the carrier? Nice, we have a little handy guide for that. It's called Identifying Obsolete Carriers. If we can't really identify the carrier, we just Google, we go to obsoletemedia.org and Wikipedia. Do we have a reader for it? Nice. And if we don't, then we keep it a little aside, and then we wait for a little budget, and we go on eBay and search, and we hunt for the reader. Then the cables, it's a bit difficult sometimes. You saw our Adaptec cable from SCSI to USB. That was a nice find. The carrier, if it's damaged, then it's basically useless. If it's not, then we can continue down the road. Does the media work with the write blocker? So you saw in the examples, the write blocker is between the reader and the computer. Sometimes some drives don't really like the write blocker, and then we take it out of the equation, and we are very careful, and then we don't use the write blocker, and we continue. Can we make a disk image? Really nice, that's what we prefer. And if it's not possible, then we troubleshoot or give up, but that rarely happens. Can we read the files on the disk? All right. If not, we do some troubleshooting and we try some emulation, maybe that's an option. So talking about those challenges, coming from the late 90s, I was really overwhelmed by the amount of SCSI that was out there, and pins, and terminators, and gender changers. So I was a bit overwhelmed to see, but apparently it works really fast. We had like a nice image and we could continue from that. Counting the pins, I cannot remember how many times we counted pins on connectors to know what kind of SCSI it was. I'm glad we are at a USB. The other challenges are finding the right drives. For sure, to order them online, sometimes they come from America, and then we pray that it arrives we hope that it arrives in one piece. The test material sometimes is difficult because you don't want to test your setup with a precious archive object, and sometimes blank versions are included, for instance with the MO drives, so we can test with those, but we always look for test materials from other archives. The damage carriers is also quite challenging. It's hard to give up and say, okay, we can't read it, we tried. There's some old issues that come back, namely the click of death. This is a particularly dangerous one for the zip drives from iOmega, in which a damaged carrier could damage the drive, and that drive could continuously damage new carriers. They're also very susceptible, vulnerable to magnetic radiation and dust because of the design. The software updates are quite nerve-wracking sometimes because our bit curator system is really nice as it is, and we installed some extra software on it that required a lot of time to get working with the specific dependencies. It's also based on Ubuntu, so we have to get some extra dependencies sometimes. In the case of the floppies, the obsolete software is a little bit of a challenge in the sense that you have to know beforehand how the floppy was written. In the case of Apple DOS, you have to know it and then to tell the system how to interpret the data. And to solve the problems with outdated file formats, we try to make the data accessible. If anybody can help us with any of these 8-inch floppy drives, compact floppy, Travan, and SideQuest, contact us, please, especially the 8-inch floppy. And if you want to know more, you can go there. Thank you.
Thank you very much, Nastasia and Lode. Do we have questions from the audience? We do.
Hi, that was fantastic. I have a question about the CryoFlux, because we were looking into buying one recently, and it's quite cheap, but found that the Pro software, once they realize you're an institution, is like €5,000. And I'm wondering, has that always been the case? Have they just skyrocketed their prices recently? Or has everyone run into this where the hardware's fine and the software is like practically impossible?
We use it already a long time, but for us it was just having the hardware and then we could download the software for free, actually.
We will send you a copy.
It was in the past. It was different. You could get the Cryoflux, the hardware. You could get cheaper if you were a particular person, and it was more expensive if you're an organization. But the software was free then.
Yeah.
But we speak about 2017.
Yeah, I have a comment on this. So there existing an open source version. It's called Pauline from MO5. It was developed for game preservation, and it's like the same as Cryoflux, but all is open source.
Okay, thank you.
And it works for all, for 8-inch, 525, and 3.5-inch floppies. So I use it, and it works perfectly.
Okay, then we'll see you in the break.
Yeah, it's called Pauline, also Pauline.
Okay,
Yeah.
thank you.
Okay, thank
And
you.
I have a question according to the using of the Tableau forensic bridges. And there are existing a lot of different bridges, also from other vendors with different adapters and cables. And I saw that you're using, for example, the SATA to USB devices and then connecting it to via USB with the USB Tableau forensic bridge. But there is also there was also a picture where you connect it directly with the SATA
Yeah, it's true.
adapter. Did you recognize the difference if you're using an adapter or not?
No, not really. We only opt. Yeah, no, not really. Sorry.
Okay, thank you.
We've got another question.
Thank you. I was just wondering about if you had any sense of when you're not using the write blocker on some of these transfers, if you noticed a big time change, like if the write blocker was adding a lot of time for transferring the files and which formats that related to.
So we don't really work with hard drives larger than a couple terabytes, and even then we don't really use the white blocker a lot. So luckily the old data carriers are quite like small capacity, so we don't really notice any speed difference. Anything else?
But we also didn't measure it, so it could be that there's a time lag.
I'm afraid that you having the big budget do like that.
Excuse me, we had 1,700 euros 1 year, so it's not a big budget.
Because what we do is keeping the old device, including old computers, and what you show is quite new. We're dealing with the Apple II diskette, which is 5-inch, and as well the big one from, I don't know how it's named in the West, 8-inch diskettes, you know. And this is yet not so hard to keep them, because a lot of people made based on mostly Arduino and Raspberry Pi readers from the diskettes drive that is still you can find in the market. I talk about old diskette drive, which is 5-inch. And they convert, and you can get from the or from card from the storage, or directly from the network. And this is best way. It means that we have a cross network of Apple II, Commodore, and things like that. That still can read from the diskettes or drives and transfer to the more current computers. As well, I think that DD command on Linux is very good. You can get older version of Linux that support DDS and JAS and zip and optical. You know, there was optical magnetical, if you remember, drive. And this is just a kind of comment and kind of suggestion that you may find another way to deal with that, which is more, I don't know how to say, cheaper and more less trouble and less working. So where you get money, by the way, for this project?
Do you want to?
It was funded by the Flemish government. Thank you.
Thank you for the question. It was enriching for everybody.
No. Oh, no punch cards. That's a
Okay, thank you, Nastasia and Lode. We've got not much time left. So thank you very much for your presentation. Now we have. Can you change to your computer? You didn't send the presentation? Okay, I don't know how to do this. Yeah. What do we?
No, I don't understand. How can you see my presentation? We can see it like this.
Yeah, and the sound.
1 second. I don't have any sound. I don't have any sound. Sorry, no sound. But I just need a little more cable, if possible. Sorry. Yeah. Here, exactly. And oh ja, bitte. And it takes a time. Okay. Oh, okay. Doesn't work. Right. One second.
Hello. While we wait for the presentation, some information for the coffee break. So in 20 minutes, if someone is allergic to pecan nuts and so on, please contact us. There is some allergy things, so pecan nuts and so on. So be careful if you are allergic to that. So see you at the coffee break.
Es wurde keine erkannt. Oh je, Glitch, ne? Der hat das nicht erkannt. Scheiße. Also Hilfe aus dem Web, das ist wieder diese Webhilfe, die braucht er gar nicht.
Wie könnte man es auf den anderen Laptop ziehen?
Can you?
Ja.
Can you maybe try to still send it? Or
so large.
USB?
This is my problem. It's so large. I have a USB stick, but it weil dann die Videos nicht eingebunden sind, das ist wieder diese Oberscheiße, darum hasse ich das so. Es geht um das Einbinden der Videos. Ja, also das Einbinden der Videos, das hasse ich. Ich habe schon so viele Sachen erlebt, so blöde.
It's gonna be okay, no worries.
Warum funktioniert das nicht? Warum kann er das nicht erkennen?
Yeah, I would try to turn it off and on again, but it's kind of like
If I have not much time to this. Ja. Wer scheißt sie dem jetzt an? Speichern unter diesen PC. Sekunde. Ach Gott, na auf das, wo ist das jetzt dann? Auf den. Speichern und ich bin mir sicher, dass diese Videos wieder nicht. Es geht um die Videos, die sind dann wieder nicht drinnen. Kopieren. Nach. Einfügen und Downloads. Sekunde. I am it. So. That's it. My videos will not work because they will not be included. So where is this device? Oh God, no. Oh yeah. PowerPoint. I did it. The videos will not be. Ist der Dingeansicht, Referenzspeaker? Ja.
5, right?
Ah ja, perfekt.
Yeah, if you want to read more, you can close this. So you can close it.
Jetzt passt wieder alles nicht. Ja,
Yeah,
okay,
you
that's
can
better.
close- yeah.
Oh, so sorry.
Hello everyone, we are back. And I present Nadia.
Hello, sorry, it's the usual technical challenges that make life a little bit more interesting than just a lazy and nice, well-going everything's. Okay, I would like to talk a little bit about experiences recently discovered in very special climatic regions such as Southeast Asia and also Middle East regions. My world still looks like that. Yeah, I'm one of the dinosaurs working with analog holdings, and I know that I will extinct soon, but I'm not sure who will extinct earlier, those media or myself. This is what I would not like call a ideal storage situation. Neither this. Both situations I found in some archives in Southeast Asia while walking on a living carpet. The carpet was living because there were insects inside. So in this exactly this room, what you can see here is termites eating the paper and eating everything around, and their digestion results end up on the media. So what have you been doing in Southeast Asia? I have been cleaning termite shit. So, but what are our most important problems in storing and keeping our media physically alive? So one of them is the well-known vinegar syndrome, which occurs with the base material and cellulose acetate. All video archivists can be happy because fortunately there is no video on cellulose acetate, but certainly enough of our film holdings. The vinegar syndrome is a quite complex complex situation of interaction, and I don't explain it too much due to the copy process. This has changed now. Don't ask me why. Usually the presentation was well, so now we cannot read the lower part. Just ignore it. You can read hundreds of literature about the vinegar syndrome and the chain scission, and it's usually a two-tier or the reaction is at least divided in two parts. One is the chain scission of the material, which is autocatalytic, which is driven by the acetic acid that is evaporated by the material. And the other one, this can be the result, then the final result, but the other reaction, the more the chains break, the more volatile substances, like for example plasticizers, can evaporate. And this makes the material even more brittle. You have the breaking of the chains, and additionally, this opens the way for evaporation of plasticizers. This is a reaction which is very well understood in the 1960s. So 1967, there is a basic literature which I would recommend to everybody from Mr. Voigt and Mr. Höchst, Physikalisch-chemische Ursachen der Alterung von weichgemachten Kunststoffen. In this publication, they explain in detail how the evaporation goes on. Nevertheless, it is mostly underrated with cultural heritage materials. But the results, all of us, we know them, are looking like this, or like this, or eventually like this. It's getting worse and worse, and sometimes also like this, yeah? So, what is the diffusion of a plasticizer depending on? It's depending on the size of the surface exposed to the atmosphere. The more exposure to the atmosphere, the more ventilation you have, the more volatile substances can evaporate. So there is the question, ventilated can, yes or no? For me, it's a big discussion and a big issue. Yeah? Certainly, we want to have ventilated cans, but we have to know that with a ventilated can, plasticizer and acetic acid, as bad as it is a plasticizer, as well as humidity. Anyway, the thickness of the diffusion zone, for example, the diffusion coefficient rises with the plasticizer concentration, so it depends a little bit on the production of the material, the saturation concentration and vapor pressure of the plasticizer inside the molecular system, the plasticizer concentration and vapor pressure of the atmosphere outside, which means high temperature, high humidity, high vapor pressure, high evaporation. Temperature and atmospheric pressure, which means that vacuum accelerates this process. So vacuumating your items is not the best thing. Or you have to decide what you want. You have to die one death. The question is, which one? The bigger, the higher this factor, the faster they proceed. So a very tiny look on the production and on the use of external plasticizers. Cellulose acetate has been externally plasticized, which means that this is a mixture. The plasticizer interacts physically, not chemically, reacted with the polymer. It's basically a polymer mixture, and you see this tiny molecules, the round parts here, they help the chains or the comparatively harsh material to get a little bit more flexible. And this is the reason why it can evaporate, because it's not chemically reacted. It's only the bonding, the molecular bonding inside the material that holds it or not. So evaporation depends on various parameters. I have already outlined some of them, but the red ones are very interesting. The smaller, the lower the molecular weight, the smaller the plasticizer molecules are, the cheaper and easier they are in production, but they are very highly volatile, which means that early plasticizers or smaller plasticizer molecules have the tendency to earlier evaporate than later produced tapes. Here you see it. If the molecule is a little bit bigger, so you have a longer chain, then it does not evaporate so easily. There is lots of literature you can find about these processes. So how does, for example, a magnetic tape shrink? Let's have a look at the composition. We have the substrate, which contains solvents, cellulose acetate, and plasticizers, like, for example, 3-phenyl phosphate, with up to 20% of weight. 15 to 20% of the substrate is plasticizer, while the magnetic coating usually consists of magnetic particles, of metal, of corroded iron particles. They don't shrink. You have a much lower percentage of lubricants and plasticizers, only about 3%. So what happens if the plasticizers evaporate from the substrate? The result is brittleness, deformation, shrinking, loss of elasticity, loss of tensile strength, and in the worst case, the tape becomes unplayable, and the shrinkage is always towards the layer which has where the most part of plasticizer can evaporate. So the magnetic coating shrinks to a lower degree and stays inherently stable, and this is the reason why it keeps the wire away while the substrate is shrinking and the material is deforming. This looks, in the end, it looks like that. This is a magnetic tape, which is very brittle. You see it is already broken on one part. The upper side is the substrate, and on the lower side, the longer way, is the magnetic layer. Here are some more examples of shrinkage, and here the next one. And here, a wonderful example for diffusion of plasticizer depending on the size of the surface exposed to the atmosphere. Here we say that the inner part maybe never has been played and never has been exposed to the atmosphere because it was tightly packed, so there is no shrinkage. But in the outer layers, you have the shrinkage, which is a physical factor. The list of plasticizers of polymers containing plasticizers is very, very long and can be seen in the Handbook of Plasticizers from George Wipch. I think it's a Polish name. So, examples for affected materials, we all know them, from instantaneous or wax cylinders to shellac discs to photographic, cinematographic film materials on nitrocellulose as well as on cellulose acetate, instantaneous discs, and so on. But recently, in one of my nice little destinations, I found early polyester tapes stored under irregular climatic conditions, which showed signs of loss of plasticizer, embrittlement, and spoking effect. And this is something which concerns me because PET usually does not have a mixture of plasticizer, but is internally plasticized, which means that the part of the plasticizer is a part of the polymer structure. It's incorporated, the flexibilizing groups are incorporated into the polymer chains by copolymerization, or so-called side chain grafting, and therefore they are linked with the material and there is nothing to evaporate. Not so with this tape. This tape shows the first signs of spoking of embrittlement, and it is BASF LGR 30P, which is a well-known polyester tape, and an early one, comparatively early, 1968 to 1958 to 61, it was produced. No, 68 to 81. And it's definitely polyester. So even with such mixtures, you can have shrinkage, although you don't expect it. So facing future climatic change, all of us should be aware that this might happen even with the most stable materials. Yeah, just let the climate become worse and worse, and and forget about good climatization in your rooms. Yeah. What is the next huge problem? All of us know this is binder breakdown. Pigment binder instability, we all know it. Sticky shed, soft binder syndrome, oxide shedding. We all are aware that this is a huge problem, and we think classically this is a hydrolysis process and it's reversible by baking a tape. Looks like if everything was good, but so there are three theories, and honestly I believe
its whole effect is a combination of everything. Three main theories. The classical theory is the classical hydrolysis reaction. A pigment binder instability is a reaction of humidity in combination with high temperature. So water, which is omnipresent in form of humidity in the air, causes a chemical reaction, which is called hydrolysis. The polymers, which bind magnetic particles and the backcoat in a homogeneous coating, break down. The binder loses essential physical properties, and the tape starts squealing, sticking, head clogging, oxide shedding. Here is a schema of this reaction. So binders and the binders react with so in the binder, in the polyester polyurethane binder, which consists of a hard and a soft segment, esters and carboxylic acids decompose to water and alcohol, and the crosslinks break, and in the worst case, for example, metal particle tapes can also corrode. But you have the leakage of the scission of the chain scission, and the result looks, as we all know, like this, or in a worst case, like this. In this case, the process of delamination, so information on the left side here, where you can look through the tape, is lost because it's sticking on the reel. So this should never ever be the case. You should never ever spool a tape so far. So if you have a tape which looks, or which you know from the tape brand that it might be sticky, then you never ever might lose magnetic layers. So I always have a special light situation where I can control on the long, low winding speed if some particles come off or not. This is the classical theory. I know. And in theory, it's reversible by tape baking, and Ampex has patented this already in 1993. You can read how to do it, it's not a big problem. But then we have another theory, and this is the theory of Mr. Charles Richardson. He tells us that this is only the case with back-coated tapes, and non-back-coated tapes are not sticky. He has a patent where he is removing the back coating from the tape, and then everything is okay. But I can tell you this is not the case. And if the video was playing, I could show you that this is a non-back coated acetate tape, non-back coated, which is sticky, definitely sticky. This leads us to the third and last theory, the manufacturing process and the physics. A recent study from the Library of Congress, Andrew Davis and Fenella Franz and the colleagues have found out they wanted to artificially age samples, and they found out that they cannot, in the laboratory, provoke the chain scission. They cannot provoke binder breakdown. It's not possible. They aged it for a year under the whatever conditions, and the tape became not sticky. Why? Because the production process has such a high influence. Here you see the view of a tape manufacturing plant, and you see all these large, huge rollers. And these rollers, in the end, give the tape a certain pressure. It's the calendering roller, which presses together the substrate plus the magnetic coating. But the problem is that between the substrate and the magnetic coating, you have a primer, a thin layer of primer, which is polyester polyurethane. And now, if the calendering pressure is a little bit too high, then it presses together these layers, and migration starts from the primer towards the direction of the magnetic layer. This might not be harmful, this is just a production process and helps to bind. But if you store your tape under high humidity, under elevated temperatures, and with high pressure on a tight pack, because you are in a radio archive, and the last thing the operator did before putting the tape into the archive was high-speed rewinding and get rid of it and put on the next one. Yeah? Then you have such a high pressure. Then you have all the thermodynamic factors which open the pores, let water come into the material, and the pressure gets higher and higher. And then it happens that the primer migrates through the coat to the next back coating, where you also have polyester polyurethane. And then they bind together, and the lamination takes place. Yeah? So factors influencing this process is the relationship between thickness of the primer layer and the calendaring pressure and also the production speed. They wanted to make it faster and faster and faster, and therefore this alignment was not done so correctly as it could have been done. And then you have two effects. One is stickiness, and the other is the contrary. Yeah, you lose the information completely because it is not pressed hard enough together, or due to your storage situation you have these problems. So winding tension, winding speed before ending in the archive, diameter of the spool, weight and pressure of the material, storage conditions, temperature, humidity, the vapor pressure inside the material, the higher, the more material expansion. So all these thermodynamics factors lead to migration. And finally, some more challenges. One is this nice little termite residues, which you will find with the ongoing climate change more and more. Then certainly mold growing. Yeah. Then maybe some insects coming into our countries from regions, or combinations of all of these factors together. Yeah. Loss of plasticizer, brittleness, termites, and mold. But fortunately, in our study course, we are able to restore such tapes. This is winding, and unfortunately, the videos are not linked because it's not on my stick. So thank you for your attention. This is my final slide.
Thank you, Nadia, for a fascinating presentation. I wonder if there is one question. We don't have so much time anymore.
Thank you. It can be very difficult to identify in a particular film what kind of plasticizer was used. Of course, for acetates, it's mostly TPP. For nitrates, it's often camphor, but not always. I wonder if you have any technology for identifying this, if you routinely try to identify plasticizers, and also if you collect any data on which particular film manufacturer was using what types of plasticizers in which period, because that would be extremely useful.
So we have a very good knowledge about which plasticizers have been used, because we have been doing lots of studies with ATR, with gas chromatography, but also non-destructive tests with solid phase microextraction, which is a technology where you have a small glass fiber inside the box, and you can measure what is outgassing from, for example, from a film roll under different conditions. You can, for example, heat it a little bit up and then measure what is outgassing. The fiber is taking on all these gases, and then it's heated in the gas chromatograph, and then you can have an analysis. And usually the older the material, the more the longer chains you find. Phosphate, D-phenyl phosphide, 3-phenyl phosphide, DOP, and so on.
You don't use Raman spectroscopy?
Okay, thank you very much,
It's
Nadia.
destructive. That's the reason.
Thank you very much.
You're welcome.
A little applause. Thank you. So the first part of our morning program just finished. We're heading to get some refreshments for the break, and we're back in 20 minutes. Is it? Yeah.
do you feel?
Yeah, I feel
So, Dave, you're ready?
Yeah, I'm very ready. Yeah, ready.
Yeah, thank you.
Thank you, Adela. All right, I'm going to talk a lot about this format, the DAT audio tape. I think it's about my 20th anniversary of like struggling to preserve this particular format. So I'm going to talk about a little bit about my personal history, my relationship with this format, and then like an active research and development project that I'm working on currently. Initially, I went to the Selznick School of Film Preservation, and when I graduated from that, I ended up being an archivist at Democracy Now!, an organization with no film at all, but a lot of early digital formats, such as DAT and DV. So, sorry, I might hunch in a little bit because my notes are so small. Okay, oh, sorry, Command plus helps me out. Okay, so just as an introduction to this particular format, a significant amount of humanity-related content was recorded onto these tapes. This was a format developed by Sony, introduced in 1987, and it was used about up until 2005, and then started getting replaced by file-based recordings and CDs. Tragically, DAT has been proven to be one of the least stable magnetic tape carriers for audio content, and there's now a lot of risk of losing this content. Some of the earliest DATs that survive are now close to 40 years old. This is a tape that's really meant to be very small, compact, and cheap, and doesn't have a lot of like robustness for a long shelf life, even under quite good storage conditions. There were a few like bands in the punk scene that were releasing their content on DAT. I think if you go into Discogs, you can see a couple hundred releases. But generally, DAT tapes were used for like field recordings, for mastering. So generally, like if you find a stray DAT tape in the wild, the chances are quite high that it's a unique recording as compared to like an audio cassette, which was used for mass distribution. So the content is often a copy. So this is an example of a DAT player used in professional environments. It has the basic transport controls, some editing control support, and some metadata functions, like you can set the recording date and time and record that into the tape. This is sort of the format that the organization I was working with was using more. This is a DAT Walkman, so this was quite easy to go out and do like field recordings, to do interviews. You know, this format was really meant to be small and portable and more convenient compared to the bulky, more expensive audio recording formats of the day. So let's see, I'm gonna go over here. So as I was mentioning, DATs are kind of made to be small and cheap, and the format is very sort of vulnerable and fragile on the shelf. Really, just as like all tape-based formats, we have to make a lot of effort to transfer the content from the tape to new sustainable formats. So when I first began to address this challenge at my first archival job, I worked with a collection of several thousand DATs and started digging into what the best practices of the day were for preserving this. From what I could find amongst the recommendations, a lot of these were quite similar to the procedures used for digitizing analog audio tape. In that, I would put the tape into a player, and I would do this sort of dance of hitting play on the DAT player and hitting record in recording software on a computer. And I'd have a little bit of a cabling and an audio card in between. I was trying to do the best job I could, and as I dug more and more into best practices, I'd learn things like I need to make a checksum, I need to be very strategic about my file name, and was learning more and more about like the specifics of making a broadcast wave versus a wave. But as I was getting more and more into putting this into practice, there was just a lot that didn't feel right. The DAT tape itself contains a stream of interleaved audio and metadata that's mixed into frames. It's already in a digital form. It doesn't need to be digitized. The data just needs to be moved from an incredibly fragile carrier to something more sustainable. And the practices I was putting in place that I could find from the community at the time weren't just moving data. It was essentially making a performance or playback of that tape and then recording what it sounded like. So there was quite a lot of differences between the recording I ended up with and the recording I started from. In archives and on the shelves, often our media is long separated from their original recording devices. And I was realizing I was working with a lot of media without even really understanding what it felt like to record on these pieces of media to begin with. And I realized that there was kind of a lot of risk and naivete of not like learning the process of using this particular media object in its original recording device. When I put the DAT tape back into its DAT Walkman or its the Marantz audio recorder, I could see I had like on here there's like previous and next buttons. So if I put in a recording, I could like hit next and it would go to the recordings, the journalist's next recording. So if they were going out and recording 14 interviews, I could just jump through them all. And if I changed the display, I could see the recording date and time of each one because it was recording the clock setting as into the DAT stream as it was recording. For the WAV files I was recording, there was none of this navigation ability. It was just a recording of audio. All this sort of navigation, this like chapter data was lost, as well as the recording date and time. And I realized this made cataloging incredibly hard because if I'm just listening to a continuous audio recording that represents a DAT tape playback, I don't know how many recordings are on it. If one person stops speaking and the next starts speaking, I don't know if I'm listening to a new recording or if this is somebody who's just answering the first person. Whereas if I put it into the original Walkman, I could see, oh, from this second to the next, I'm moving from a recording that happened on Friday to one that happened next Monday. I could really like organize things along a timeline. So in the sort of DAT preservation project I was working on, I think at one point I had a tape that, like on these tapes, you could switch it from 48 kilohertz to 32 kilohertz and record additional audio. So a lot of journalists would change this setting in order to get a greater duration capacity on the tape. So when I was transferring one of these tapes, in the recording software, it sounded fine, but once it got to the sample rate transition, it just sounds like very bad, misinterpreted audio, so you get like all that static and randomness. And I emailed a audio preservation community asking like how to best use this sort of hit play, hit record workflow if I'm dealing with frequency changes. And I got two responses that were essentially that I should use the analog outputs of the deck, like to convert the digital tape back into an analog signal and then digitize that. And at that point, I just kind of had enough of like applying this workflow to DAT. I stopped the DAT preservation project and was like, we really just need to start from scratch because this is not effective digital preservation work at all. So this device ended up being my hero. This is the Sony STT-9000. Often there are some media formats that we work with where they'll be used as two different media recording formats. Like for instance, like a DV tape might record DV, or it might have an HDV recording on it. In a similar way, the DAT tape might be an audio recording, or it could be just like a data archive. These drives were called DDS drives. There were 4 generations of them, and they were kind of like an LTO of the 90s. You could use a DAT tape to back up a whole 1.4 gigabytes onto a DAT tape. You know, the interface on the hardware is a lot more simple. There's just a couple status lights. There's no play or rewind. You can just eject the tape. When you put it in, it automatically rewinds it to the beginning and like kind of skims it to figure out if it's a DAT tape or a data tape. I found a couple advertisings of the DDS format. I really like that the phone number for this company is 1-800-exabyte, and then I did the math and it would take 83 million DAT tapes to actually store an exabyte. But you know, this was like shipped more and more as a backup solution for folks. So then I finally felt like I had a choice. I didn't necessarily have to use a DAT player to interpret the tape into an audio stream that I would record. I could potentially use the DDS drive and try to get the data off that. In the job I had at the time at Democracy Now!, I had access to like a volunteer that had a lot of expertise in refurbishing like old computer systems. So he hooked me up with all the SCSI gear I needed, and I was able eventually to get this software up and running called DAT Extract. And I was quite thrilled because I was able to get access to all the metadata. This essentially like reads the data off the tape and writes out an audio file in one direction and then logs out all the metadata of the tape in another. So I get all the timestamps for when the stop and start markers are, the recording date and time. And then up in the red where the errors are, I was realizing that every audio frame on the tape has error correction code and a checksum on it. So when the tape is being read, the reader is able to understand if it's reading it correctly or if the tape is so damaged that it can't read that frame correctly. So I'd be able to accumulate that data too. In the preferences of DAT Extract, I also realized I could make one file per recording. So if a journalist is going out and doing 14 interviews, I could have them all separated into individual files and know the recording time of each one. So I was really thrilled. This was like a huge improvement from the workflow that I was dealing with initially. I had this system set up in 2004, and I used this Mac G3, which I've never thrown away because it was like the only system where I could get this up and running. So right before the pandemic, I was now working at City University of New York. Had an intern, Veronica Smith, delving into a research project because we wanted to document practices for using data drives to transfer the DAT stream off of tape. So this is the setup we had working. We had this working like a month before the pandemic, and then we all had to go home and we couldn't keep working on it anymore. But essentially, this is a Mac G3, a Centronics 50 cable plugged into a DDS drive enclosure. The enclosure didn't quite work correctly, so the DDS drive is like stacked on top of that. It was a big, messy contraption, but it worked. And then we really got into Mac OS 10.3 Panther. We had to get the installation CDs. For some reason, 10.2 and 10.4 do not have the drivers for the SCSI hardware. We had to very specifically stay in this, I think it was like a 2007 era, or no, I think it was earlier than that, but like this one specific version of Panther, the brushed stainless binder windows is where we had to end up. So Veronica's paper is amazing that we published. Like it's the bit.ly CUNY-DAT-paper. But in the appendixes, we were trying to document all the instances of people using DDS drives to transfer DAT tapes, and we were only able to find 5 examples of this, including the Fugazi project, there was a project at Radio New Zealand, and a few others. These were the DAT transfer projects happening in archives, and then we found some instances of them being used by individuals. But we could tell there were not that many people doing this. It was incredibly inconvenient. It was difficult to source any of the material because it relies on a pile of obsolete hardware where a simple cable or adapter might be going for like a few $100s for no reason at all on eBay, and none of this is available to get new. So ended up starting a project with NEDCC. We wrote a grant to make a simpler version of doing this. And what we ended up deciding is to completely throw out the computer from the process and rely on a Blue SCSI card. Blue SCSI is an open hardware project made by the vintage computing community collectively. This is an instance of a SD card is plugged into the Blue SCSI with a little monitor on it and then SCSI'd into this very portable Macintosh computer. One of the challenges of running vintage computing is that it's difficult to source a working SCSI drive because they're almost all dead or thrown away. So Blue SCSI is creating a way where you can plug in a little SD card and do the transfer. So this is another example of the setup where, like, right above the mouse is the Blue SCSI device connected to the computer. So it's sort of like just swapping out your old SCSI hard drive for a SD card. This project started a mode called initiator mode, where the Blue SCSI itself would act as a computer. So I was fascinated by this YouTube video put up earlier this year where somebody was testing using the Blue SCSI to transfer data off zip drives, because I was like, this is very similar to the DDS process with a DAT tape. So then I eventually got this up and running. I would love to make a 3D printed enclosure for it, but this is the DDS drive of a DAT tape, transferring it. And then I really want to acknowledge my son, Andrew Rice. Over the summer, he was back from college, and he did the pull request to support the audio mode of the transfers in this software, and was like, very thrilled that he was able to sort of accomplish all these goals. The issue to deal with now is that once you transfer the data off a DAT tape, it's in a format that's not really supported anywhere. It's an interleaved audio metadata format. I'm going to skip a couple slides, but this is basically an index of the metadata header. Jean Martinez added support for this data stream in Media Info. Most importantly, kind of right in the middle, we have IPF interpolation flags, and that is telling us if the data was transferred accurately or not. And then we have the other metadata around it. There is a huge amount of failure of this transfer rate. And the failure is really inconvenient to listen to. This is the same transfer moved from a DAT player and a DDS drive. Transferring it as a data drive, we know that the frames fail, but we get just frames of random bits, so it ends up it's not pleasant to listen to. Whether the DAT player is set up to minimize these by dropping out the audio or adding swishy sounds, so the pleasantness of these two is very distinct. But we also notice when we transfer the same tape multiple times, we'll get the errors in different places. There's a lot of opportunity here to merge, selectively transfer a tape in multiple places and merge them together to Frankenstein one better copy out of multiple bad copies. And truthfully, when we look back at a lot of the archival processes to use data tapes to transfer DAT tapes, use data drives to transfer DAT tapes, a lot of them abandon the process because of these errors. So right now this project is looking into how to merge together multiple transfers to overcome the errors, or how to add other corrections to try to improve the process. So we're still developing software, the pieces are coming into place, FFmpeg pull requests, Media Info pull requests, but the 4 parts of the project are to capture the tape, so we'll be able to connect the blue SCSI to a computer to monitor the transfer, to analyze and visualize the results, so you can get a little graph of your transfer and how good or bad it is, to potentially merge together multiple transfers to make one better copy from multiple worse, and then ultimately to package it into a WAV file that contains the timecode, the recording metadata, and the chapter information, so that you can recreate the same navigation that would be possible in a Walkman. That's it.
Thank you, Dave. I wonder, are there any questions? We have probably time for one. Okay, you were first.
Thank you for the talk. I would like to know what's the availability on eBay and used market for these DDS drives nowadays.
Oh man, I should be worried after this because the prices are all going to go way up. Generally, whenever I search, maybe there's 10. The prices are a bit inconsistent. I don't know, occasionally you see a rare thing of somebody with a lot of 20 of them, all selling them in a group, but the other components of the project are open hardware or easily available things like the 50-pin ribbon cables. The one part that's kind of irreplaceable is the DDS drive itself, and those, so we've sort of narrowed down the recipe of obsolete materials down to 1, which is about as low as we can go here.
I'm more interested in the data format that you extract, and you mentioned some FFmpeg merge requests. Is it to read the raw data that you extract from the files, and if so, what's the status of that? Because I would really like to be able to play them in VLC.
I'd be happy to talk more to you about this. And yeah, but the pull request that Paul wrote was just written, I think, yesterday or the day before. So I'm he sent it to me privately. I'm not sure if it's even on the mailing list at the moment. But yes, this is a conversation to continue. And hopefully I can give a follow-up on this soon. Yeah, Blake.
Okay, thanks for all the questions. Now we are skipping over to Peter Wupser, who is presenting online, but with a video, right? So just a quick introduction. Peter is, since the mid-70s, a sound designer and dubbing editor, born in Berlin, but living in the US. He started with Arena Synchron, Wenzel Lüdecke, and then went to radio and film. on. And we can start now to play his video.
Oh no.
And this is my presentation for the No Time to Wait 8 conference, and it's called Non-Contact Format Agnostic Audio Retrieval from Magnetic Carriers, which is based on a paper that I've written and follows on from a previous presentation that I gave at some point at the university where I work, at the University of Central Lancashire here in Preston in the north of England. I want to start with an imagined scene from a sci-fi movie. A person finds an old tape in the attic and takes it to a local library, puts it into a machine that looks a bit like a modern version of the one that I'm going to show in the slide, puts it in and presses the scan button, and then some 10 seconds later, the resulting audio is deposited in a mobile phone, so it goes ping, and there is the audio that whatever that tape was, and for the first time, the person can listen to the granddad's voice. The reason I put that little imagined scene out there is that when I started researching into that, I also became aware of the magnetic tape alert project from EASA and the Save Our Sounds initiative from the British Library Sound Archive. And I apologize if many of you are already familiar with this, but I'm just going to go over this ground as quickly as I can. It's necessary to make the point that I'm trying to make. So just a quick rebrief, I guess, as it were, right? Anyway, so the one of the startling facts is that more audio heritage resides on magnetic tape across the world than there are resources and time to digitize and archive it. Roughly speaking, that's the gist. This is made even more urgent by the fact that the magnetic carriers, the tape itself, is deteriorating, is flaking, is whatever, breaking up, and it's doing so rather quickly. And the older it is, the more urgent it becomes, quite naturally. And there is those two things put together that we will not have, or we currently do not have, enough resources across the world to archive all the material that resides on magnetic tape, plus that the tape is deteriorating, leads to the fact that eventually we will run out, and all the threat that audio heritage may simply vanish, literally disappear, is actually very, very real. So the question then is, will we just stop archiving audio from tape once we reach the critical point whereby all devices are irreparable, the engineers are all dead, and whatever, and there's no spare parts left anywhere in the world, and the tape, carries on sitting there and rotting? Are we suggesting that at that point we just say, okay, that's it, folks, we're gonna stop archiving? It seems that question nobody is answering or even posing that question. All efforts are in upping the amount of digitization, the speed of digitization, the maintenance of the machines, buying all the machines, and so on and so on. There's no effort to future-proof in the sense of what I'm trying to make a case for here. So if we think about what the current system is, so we know we're running out of playback devices and all this, and there have been many speculations as to when the deadline is. Mike Casey in an EASA article, and Dietrich Schiller and Adam Toll, they all put different end dates when they're speculated in previous years and previous presentations. I think that is more or less by the by. It will slowly ebb out, but at the moment, the current process is that of playback, analog to digital conversion, and then the archival process. If you would turn up with a tape of this kind of type, or any type, a cassette or whatever it may be, to a library, then a playback device that can play that particular type of tape will have to be found. Some information will have to be deducted from the tape, the physicality of it, in this case the leader dictating what speed it runs at and what track format it is. A playback device has to be found. If a playback device cannot be found, the contents on that tape will be lost. It doesn't mean the tape is lost. It means that the content residing on the tape will be lost if we don't find the appropriate playback device. But the main point I'm trying to make here, which is where the non-contact and the format agnostic part of this case is coming from, is that we do not find the appropriate device, or we think the tape is too damaged, or cannot be wound properly without being damaged, then the content on the tape is lost. That is kind of quite tragic and happens in many, many cases. We have to understand that when I say non-contact, that the format agnostic part of the thing I'm proposing here almost comes off the back of the non-contact, by which I mean that if I photograph something without the playback device, then there is nothing that needs to be calibrated. And a lot of limitations of the recording device and subsequently the playback device, those two will always add, the limitations and the distortions and the noises and whatever disturbances there may be will simply fall away if we take it that the current process is destructive as in it's physical and pretty harsh in terms of reel-to-reel forces on tape and tape heads, and is absolutely format dependent, as in if we don't have the right format, we will lose the audio, plus the fact that eventually we will no longer have the devices to play things back. So we need something. Now, I am not purely speculating. In 2008, Terry Ferret from West Virginia University did his master's dissertation on retrieving audio from a cassette tape using a magnetic force microscope. Okay, pure sine waves, and his aim was to see, understand, and prove that he could retrieve erased audio data from tapes. So he was recording pure sine waves onto cassette tape, scanning those with a magnetic force microscope, then erasing it in the cassette recorder, putting it back in and rescanning it, and retrieved the erased waveforms and could restore them back almost to the quality of the original scan. Now, it's pure sine waves, not complex audio. Cassette tape, limited scope in terms of frequency response and so on. All the same, the research is there. This is 2008, only 2 years after Vadileev started with the research on and publishes what is now the ARINE project. There is a system out there that is already working right now. Sometimes in 95, 93 or something like that, there was a guy called Pappas for forensic analysis of tape, and he used an electron microscope to do something similar. He was trying to show and prove authenticity of a tape recording. Is this a copy of a copy, and so on. This was for forensic purposes. I have not found other than the one paper on that. So my feeling is that research got locked somewhere. In fact, I think the researcher itself, Pappas, went to be some tech head at the FBI or something. Anyway, so the research has been out there in little pockets that are not necessarily for archiving or conservation purposes, but all the same, hitting in the right direction. So what I'm proposing here is not just blue sky thinking. I understand the challenges, and I can see the two sides that rub a little. One is ethical, so those are how to conserve the historical context and the cultural context of whatever is on those tapes, and how important that is, and how little we should interfere with how it is on the artifact, which is the actual tape, and the desire at the same time to, like with Irene, remove hiss as we digitizing, remove limitations as we digitizing, remove timing differences as we digitizing. Then the next step is, hey, couldn't we generate some overtones to make it sound a bit more modern? Where is that line? So those technical, ethical discussions, need to be had, and the standard needs to be open. So my conviction is that wherever this may go, it cannot be a locked system or algorithm. It cannot be a commercial system. It has to be something that is community-based, open source, so that it is available cheaply and freely and easily to the community at large. It's quite difficult right now to get any analog audio digitized professionally without either paying a huge amount of money, waiting for a very, very long time, or if you already have a large collection like the BBC going to the British Library, say, if you don't sit on a big collection which takes priority in the big institutions, if you're a private owner like me that happens to have a couple of hundred reels of stuff that may or may not be culturally relevant depending on what you think, to my mind all of it is relevant. And all of it needs to be preserved, or as much of it as possible needs to be preserved. There's also a little bit of this social kind of divide in there. So if you take, for example, the TC03 guidelines and then look at a presentation at the AES conference in 2023, where a researcher from Paraguay, he was actually researching into noise reduction of analog tape, which is what he was presenting, but he used it on audio historical audio tapes, and he used home equipment, a small little everyday interface, a small little tape recorder, so nothing that would pass strict TC03 guidelines, say. As an it has to be a Studer 807 with an azimuth control and an oscilloscope attached to it and a bank of engineers kind of servicing and doing the job. So that was a researcher sitting in his university office doing it on a small desk like this. And I think rightly so. He said, well, preserve it professionally or don't preserve it. I rather preserve it with what I've got. I'd rather save it than wait for becoming rich and doing it. And he was quite, when I spoke to him, he was quite determined about that quality as such, even with home equipment these days, is becoming better and better and is well adequate enough for digitizing old, limited quality footage from audio from magnetic tapes. Some transfer function, my hunch is it will be based on magnetic force microscopy, but it could be some other imprinting function that we have not yet explored. Will have to come to the fore. And I would like to plant the seed in people's heads and perhaps at some point in a larger forum have more detailed and technical discussions about the ins and outs of such systems and the requirements of it. And maybe even start putting that down in some sort of document that can be a seeding point. In conclusion, I hope that I could make the case somewhat that a non-contact, format-agnostic retrieval system of magnetic tape that incorporates some algorithmic processing for the reconstruction of the audio that sits on the tape is a necessity and not just wishful thinking. Now, I'm fully aware that development cost, research time, the engineering challenges, all these things exist. And on top of it, even more so, the ethical and philosophical challenges of preservation, archiving, and restoration. And I'm aware of all that. I'm trying to figure out that one central question, which is, what are we going to do once we run out of the engineers, we run out of the machines, and we still have over half of the world's audio heritage sitting on tapes? And I think now is the time to think ahead, to develop those kind of things. And I hope I was able to point out that there are some developments in the making that point in that direction, ever so gently and slowly perhaps at this time. And I'm not claiming to be the engineer that would put the system together. It has to be a collaboration. But in the paper that is associated with this presentation, I do go a little deeper into some of the more ethical aspects and questions. And I hope that once this is published and followed on by further papers that will dig more into the technology aspects of it, maybe it will stimulate enough discussion for at some point to have some sort of forum in which people can discuss this without the baggage of guidelines or the over enthusiastic approach of some software engineers or whatever. That we can just take the facts as they are, look at what the challenges are, what the current things are, and what is a future-proof way of looking at archiving audio from magnetic sources. I hope that's it. And I hope you have questions so that I don't have to do this talking to the camera thing here, because it's kind of awkward. Thank you.
Now we have Peter online for your questions and comments. So please go ahead, have a question, have a comment. All right.
Is there anything? No?
Hello, I haven't understood. Did you have already practical results? Because right now I know at least 3 institutions and people that working on non-contact format. Last year also I presented some technology like that. So do you have already some touchable practical results? Thank you.
I'm sorry, Peter, were you able to hear the question, or you need it restated?
Not quite clearly.
The question was there a practical result already in your studying of this problematic? Or?
The only practical result was from West Virginia, which was Terry Farrett's research, but they were only limited to sine waves for now, and there are some very clear images that are very similar to the output from Fadeyev on the IRENE system in the Library of Congress. So it's a proven principle, which is why I'm quite hopeful that it might work. In terms of the thing is, it works on, so far, it's the system is essentially so if this is the tape, it's a cantilever with a tiny, tiny probe that can scan a small segment at atomic level, essentially, seeing the magnetic patterns on the whatever it is it 20 microns or so of magnetic layer on the tape. So it takes a lot of time, and at the moment it has only been done with pure sine waves that have been deliberately put onto new tape. How that would translate into tapes, say, that Nadia showed before the break, that are already warped and all this kind of stuff. That remains to be seen. But then again, recently, I don't know if you're aware of the Pompeii scrolls that have been scanned. Even though they were burned and they're scanned through the late 500-year-old shopping list or whatever it was. So there is science and there are results out there. And this is 2008, so I guess people will be working in pockets on similar systems.
I have a question.
That's a question.
I'll go over to the audience side for my question. I guess I was curious, because you were talking about just the degradescence issue, that it's soon, because of all the obsolescence, going to be no longer possible to transfer, but you're also making the case that there are a lot of technological improvements that make it easier to capture. So I'm curious, if you had a precious tape you had to transfer in a time machine, would you go back to the past to do the transfer, or risk it and go into the future?
The thing is, at the moment, we will always say, ideally, you want to have the machine that recorded the tape in the first place to play it back. That would be the one-to-one thing. Although, with current knowledge, I would say every analog system, playback system, would put stress on the tape, will add another system inherent layer of noise at the time of playback, much as a layer of system noise has been added at the point of recording. And arguably at the point of analog to digital conversion, which is another point that you guys have been discussing here. But improvement is a really tricky one. I had a discussion with Dietrich Schüller, and it was so fascinating because on one hand, the Irene process eliminates a lot of the vagaries from the grooves and the clicks and the cracks, and that seems to be perfectly acceptable, generally speaking, in archiving, from what I read. Whilst talking to Dietrich about tape noise, for example, that seems to be a total no-no. You know, as a no-no, that is a thing, it comes with it, and therefore it has to stay where it is. Now, I can see both sides. One is the cultural context in which the sound, the music, the whatever it is, lives in, as it were. But then at the other hand, I can see me as an engineer, as a musician in the 80s or whatever, putting stuff onto tape. I didn't want that history. It just came with it because that's all there was. What I wanted was the music to be preserved. Recording sound is in itself preservation. You wouldn't be recording something if you wouldn't want to keep it and have other people listen to it. So in some way, the whole process of recording audio is documenting cultural significance in some way, you know. So I'm personally, I think I'm more on the, yes, improve in the process. Why not? You know, because the aim of what we were trying to begin with at the point of recording was not to introduce artifacts to the sound, the music, the spoken word, whatever it may be. Does that answer that?
So, I believe so. All right. Thank you very much, Peter.
Okay, thank you.
Yeah. And now we're gonna welcome Anna Mladensteva from the UCL, and she's gonna introduce herself when she's ready.
Yes. Let's see, I think should be fine. Mm-hmm. Maybe I'll do it again. Amazing. Okay. Hi, everyone. My name is Anna Ladyantseva. I am an embedded doctoral researcher at Victoria and Albert Museum and also software conservator. My home institution is University College London. And today I'll be speaking on behalf of myself and Natalie Kane, who is curator of digital design at the Victoria and Albert Museum, on the project that I've been working on together with Natalie on conserving a mobile app using emulation. And the parts of this project forms part of my doctoral research. I did want to provide a content warning ahead of my presentation. Due to the nature of the app that I'll be talking about, there will be references to abortion and women's reproductive rights. So to summarize this presentation, firstly, I'll introduce the acquisition and outline the chosen method for emulating mobile hardware, summarizing the possibilities and limitations of emulation as a conservation technique. And then I'll look at this method in the context of the larger institutional and knowledge infrastructures to illustrate the sorts of challenges this work presents. And by work, I mean not only the mobile application, but also this type of conservation work. So some of you may not be familiar with the Victoria and Albert Museum. Some of you may be familiar with the Victoria and Albert Museum and may know it in terms of some of the other objects that we have in the collection, such as fashion. But actually, digital art and design has formed part of the collection since the 1960s. Now, if we're talking about complex digital design, such as mobile applications, these types of objects were established in the collection with the formation of the Design, Architecture and Digital Department in 2015. Following some restructuring, this is now called the Design and Digital section that goes under the larger umbrella of art, architecture, photography, and design, with a focus to collect design and society. The application that I'll be talking about is not the first mobile app that the museum has collected, and there have been previous app-based acquisitions in the museum, including the mobile game Flappy Bird in 2014, and collected as an Android application, WeChat in 2017, and there's also one iOS application as well. So before this project, the care for the apps has mainly consisted of depositing and preserving the application files on the museum's digital asset management system and partially on various carriers and stores, depending on the project. There have also been some efforts to revisit some of the past acquisitions, including WeChat, where, for example, the video documentation walkthrough of the app was elevated to the status of a collections object. So the actual video documentation of WeChat, the application, has the same status as the APK file of WeChat. And recently, we've developed a more formal approach to our acquisitions, digital acquisitions, including standardized technical questionnaires and interviews. And the museum's interest in kind of rethinking some of its care really comes from a very key moment in the museum's time and an interest to participate in research and knowledge exchange. Perhaps some of you may have heard of this quite large project that the museum was involved recently called Preserving and Sharing Born Digital Objects, which goes from more experimental approaches to the acquisition of complex digital objects and the move towards collecting auxiliary objects that accounts for process and documentation. So this is just to say that it's a really exciting time for the museum at the moment, as the internal infrastructure and knowledge is rapidly changing, in part due to these projects. So moving on to the case study. So today I'll be talking about a mobile app called Yuki. It is a period tracking and sexual/reproductive health app collected by the museum in 2023 as part of the Rapid Response Collecting Initiative. This initiative collects objects that respond to current affairs. So in this case, the app was developed by the Women Helping Women charity and IBIS Reproductive Health because they wanted to develop an app that promises to safeguard users' data and is privacy first. Now we're talking about a time where when Roe versus Wade was overturned in the US and accurate and accessible information about abortion was under threat and women's rights were also under threat. So there was an interest within the museum to collect an application, the design of which speaks to this historical moment in time. To illustrate some of the motivations behind my research, the application was collected as an Android application, as an APK file, which is the Android package format for mobile applications. And at the moment, museum stakeholders within the infrastructure that exists in the museum can only access the APK file through dedicated stockpiled mobile hardware, so several Google Pixel smartphones. The obvious downsides to that is that mobile hardware is incredibly difficult to repair. And if we're thinking about access and scaling that access to various museum stakeholders, such as curators, registrars, conservators, and even members of the public or interested research, it's quite difficult to scale this access to several people when you're relying on a finite amount of hardware that you have in the museum. And in turn, if you rely on this hardware for access, you are nonetheless contributing to the wear and tear of those of that hardware, which is why, and this is where I come in. I've been exploring whether the application Yuki can function as intended on non-mobile hardware as part of my practice-led PhD research. And the non-mobile hardware platform of choice is Intel x86, the dominant instruction set for now in most desktop computers, except Apple, of course, that have moved towards ARM-based M1, M2 processors. So the way that we can make this happen is through emulation. And some of you will be very familiar with emulation. Maybe some of you are not as familiar with it. But generally, when we talk about emulation, we use it as a catch-all term to describe the simulation of a computer system on a different computer system. Practically speaking, there are varying degrees of emulation. So a given virtual machine can either fully emulate hardware components or access some of the host machine's hardware via an implemented software layer. This is called power virtualization. And the latter option of power virtualization is a more computationally efficient solution, and sometimes it's as efficient as running things natively on the hardware that you're trying to emulate. So when it comes to emulating something like a mobile computer system, there are two options. You can either fully emulate mobile hardware, the majority of which contains CPUs with the ARM64 instruction set, or you can access some of the host machine's hardware. In this case, we're talking about Intel x86-based hardware through power virtualization. But then how can we go for option number 2, which would be the more computationally efficient option if the Android mobile operating system and the Yuki application have been developed for CPUs of the ARM64 instruction set and not for x86? Well, from my research, I've found the Android x86 project, which is an open source project to support the Android operating system to Intel x86 platforms, which essentially allows us to install Android on a power virtualized virtual machine through something like VirtualBox that has access to the host hardware and, most crucially, the processor's native instruction sets. Now, regarding the application, this includes the Native Bridge, which is a solution from Google that is able to run applications with ARM native libraries on x86 platforms, essentially translating them on the fly. I found through doing this emulation exercise and synthesizing the disk image that emulating mobile hardware using the Android x86 project has promising results, at least in terms of accessing the application in a reading room type of environment or behind the scenes for staff. But I must admit that the level of fidelity is perhaps not good enough yet to replace the original mobile hardware for exhibition and display display purposes. Now, this is something that I'm kind of working on, so maybe in the future it will be good enough. Disk image that this static disk image that I'm producing and the overall software package will be good enough to replace to be used for exhibition and display. But at the moment, further work needs to be needed for a display setup that is able to map touchscreen inputs with cursor input. As part of this project, we have also noticed that the app has already suffered loss despite being collected last year. So the application contains a number of hyperlinks leading to web resources, some of which no longer exist. This is particularly the case in a section in the app dedicated to personal stories on abortion. The app has a snippet of a story that you can continue reading by clicking on the link. And as you can see in those screen grabs, not all of these links are live. After doing some investigation, I found that some of these links are the result of link rot, and there is an equivalent updated web link available online. But in other cases, the stories have been removed from the web completely, and I could only find traces of these web pages on the Internet Archive. Of course, this raises questions on the ethics of potentially restoring access to these web resources that have been removed completely from the web, from the live web, given their sensitive nature and potentially lack of consent from these individuals who may not know that their stories remain as part of a mobile application that is preserved in a national collection. Despite them, for example, asking for the story to be removed from the internet. And this brings me to discussing some of the challenges that this type of work presents, which is based on the fact that we are unable to preserve something forever, like a mobile application, using one single method, which means that the boundaries of care around the objects are going to continuously shift. And this is something that some institutions are not prepared for. As I mentioned, this method of emulating mobile hardware using the Android x86 project has promising results, at least in terms of providing access. Although because computing architecture is likely to change and is already in fact changing, it is unclear how long this method and the resulting software package that I've been working on will be able to last and remain useful to the museum. So the museum therefore needs to be equipped to adapt to changing technologies, developments in emulation research, and emerging community-led initiatives such as the Android x86 project, which emerges primarily outside from a gaming interest, people who are interested in playing mobile apps, for example, on their PCs, and they've been contributing to this project. To be able to reproduce at least parts of the method or find equivalent alternatives. And this is not to mention that as time passes, engaging with infrastructure such as those listed in the previous slide becomes increasingly challenging, if not impossible. And this is especially the case if technologies lose their relevance and generally have less resources allocated to them. And it doesn't help that besides the community-led Android x86 project, my chosen emulation method makes use of various external tools, normally provided and maintained for Android software developers, such as the Android Debug Bridge and various command line tools. An example of such command line tool is APK Analyzer, which is a Java program that comes in the Android software development kit. And this can be used to extract and decompile the binary XML manifest file of an APK. And this manifest file contains a lot of useful information, such as the minimum and target versions of the operating system the APK was developed for, which makes setting up an emulation environment for this application much easier. And another example of a tool is the Android Debug Bridge, which is another tool that comes with the Android SDK, which can be used for communication between the host and the virtual machine. And in this case, I used it to onboard the APK file into my virtual machine environment. So it seems like the role of the institution therefore becomes enmeshed with essentially working with communities of practice. And there's two primary communities of practice that Natalie and I have identified. The first one being the communities of practice that Natalie works with primarily, which are object originators. So in this case, it would be not only the organizations that created the app, but also the individuals whose stories are represented and the role that curators have to represent these communities through their objects. And on the conservation side of things, we have open source communities such as the Android x86 project and industry actors that directly benefit the object's conservation. And as we have seen, these are not straightforward relationships and they do not provide straightforward answers. As in the case of defunct web links, we have the question of whether we can accept this loss given the sensitive nature of the content. And in working with open source and industry actors, should the museum be elevating, like in the case of that WeChat documentation, parts of the access package for Yuki? Would that not be incredibly challenging, given that institutional policies operate, at least in the V&A, on a custodianship model that assumes beneficial ownership? And without ownership as part of that equation, as in the case of open source projects, should institutions be looking to change their policies to engage with these communities in a more meaningful way? And of course, it's difficult for an institution like the V&A to be too radical in its policies because we are bound by much larger governmental bodies, like, for example, even just the National Audit Office. So this concludes our talk. Thank you for listening, and I'll try to answer any questions that you might have.
Thank you, Anna. Would you like to mention maybe your colleague who's not here? You were mentioning we did, so.
Yeah, so as I mentioned in the beginning of my presentation, yes, as I mentioned in the beginning of my presentation, this work has been done with Natalie, who collected the application that I've been working on, and she's curator of digital design at the V&A.
Okay.
Did you also consider evaluating the emulator that comes with the Android Studio, which also runs on the same platform, and from my experience, which is running much faster than the X? Yeah.
It does work much better, but I don't really see how this could be, for example, used in the museum's context, especially given that the Android Studio, I'm not sure whether it's an open source application and whether, for example, we can use the emulator separately. So it just makes sense to create a package that can be understood and almost controlled better, rather than relying on something like Android Studio. But I agree that the emulation there runs much better, but I'm planning in the future of exploring some forked versions of the Android x86 project. I think there's one project called BlissROM, so it's something that I'm hoping to explore in the next few months. Yeah, maybe that'll look and run better. Yeah.
Hey, thank you very much. So sorry if I missed this, but I was wondering if you could explain a little more about the data privacy features of the app, and if you noticed any compromises during the emulation of that, and if the link route had anything to do with that.
So the data privacy issues are basically the reason why the app was this. The way that they're doing this is by basically not storing any information on servers, and the information is simply stored on your local device. Plus, in terms of the design of the object, there are additional features, such as you can have you can basically password protect your application, and the way that in the application you have several information tiles that you can work with, and you can, for example, hide some information tiles, and then, you know, basically, so someone is looking into your phone, they can't see that you're accessing this sort of information. So the privacy first approach comes less from it comes more from the design aspects. Yeah, hopefully that answers your question. Yeah.
Hi, Anna. Thank you for the wonderful presentation. I'm Gina Chang from the National Museum of Norway. I have a question regarding the acquisition process about this mobile app. So what actually acquire as a museum when you say mobile application? So what does specified in the contract, you know, what do they can actually come into museum? Because especially it has kind of linked account if there's some apps running this kind of user board or whatever, does it involved in the specified in the contract or those kind of things?
Yes, so it's just the APK file that is being acquired. There is no, you know, it's a empty APK file. There is no user data. And I mean, this was actually something that I was thinking about earlier, whether there's a need to almost simulate, based on this APK file, some kind of dummy user data. But in this case, it doesn't make sense because the whole point of the app is that it's privacy first, and you wouldn't want the app to be populated with anything. So it's just the kind of the executable application that is being acquired, no user data. And as I mentioned in my previous answer, when a user uses the app, all the information that they enter on it is stored locally on their device. So on a different device, you know, that information kind of doesn't transfer over. Yeah.
Thanks for your presentation. Have you developed any criteria to inform what's an acceptable amount of loss when it comes to these apps or other complex works you're collecting?
Yeah, no, that's a good question, and that's something that I guess I pointed to in the last slides in my presentation, that it's quite difficult to gather what acceptable loss is, and it's always going to be different depending on the context of the app, because in a different app, these expired web links wouldn't have been accepted, right? And we would have had to preserve them. But in the context of this app, maybe it makes sense to actually let these links expire and think about how we can communicate this as an acceptable kind of loss. But there isn't like a set criteria that we have in the museum for approaching this yet.
I have a question. So regarding your kind of like call for the institution to maybe kind of open a little more to the community and stuff, would you have any, say, fantasy about like how this could happen, what the institutions could do?
I mean, yeah, I've been thinking about this a lot, and I think it makes sense, for example, for the institution to start from just even simply collecting these tools, not collecting them as collections object, but storing the binaries for the Android debug bridge or the command line tools or the software development kits. If that's legally possible, I feel like it should be. But I don't know whether that's actually enough to just simply kind of store these things within the institution, store this knowledge within the institution, which is why I've kind of hinted towards what happened with WeChat, with the documentation being elevated to the status of the collections object. I'm thinking, could maybe, you know, an emulation package become a collections object, but perhaps not, because that would make it very difficult to then redo this type of work, because when something becomes collections objects, you can't get rid of it. There's very specific rules that you need to follow when you're trying to deaccession an object. So I think that maybe there needs to be something in between simply storing these things within like DAMs or like an alternative system, and in between making something a collections object. But I don't know yet, and that's kind of part of my broader PhD thinking. Yeah.
Wonderful. Thank you very much, Anna, for your presentation. And now we're gonna welcome Nastasia and Lode for the second time today, which is also wonderful. We couldn't have more.
You were here? Yes.
Back to the right to go here. Or you could just use presenter mode. Ah.
Hello.
The Zoom is on.
This is in this one, you close that one.
This one?
Or actually, if you just go into slideshow present.
Yes. Hello everyone, so we're again Lode and Anastasia. We're still working for Memo at Team Expertise. In our earlier presentation, we brought you back to the 80s and 90s, and now we're back at present time. So we're going to tell you about the things we learned while doing a project about social media archiving. So in 2020, we started together with some other projects, a project called Best Practices for Social Media in Flanders and Brussels. It was a 3-phase project. As the name of the project says, it has a goal to develop best practices for capturing, archiving social media in Flanders and Brussels, and also to make them accessible. It was also a project funded by the Flemish government, and there were 14 project partners, mainly archive institutions. So why did we start this project? The situation in 2020 was that we saw that social media played an important role in communicating about social topics. You could notice it in the COVID pandemic that there was a lot of noise about the pandemic on social media. We at Memo, we had limited experience with archiving social media. We had experiences with archiving just websites, and there was also limited knowledge about this in the archive institutions. So we hadn't archived it a lot. But we had also other questions. It were more legal questions, like is there a legal framework? Are we allowed to archive social media? And can we make these archives accessible? So maybe you have also a lot of questions, legal questions, but that's not covered in this presentation. If you do have questions about this, we can contact you. We can bring you in contact with our colleague who did a lot of research about this topic. So the scope of the project, it were private archives, so archives that weren't public information, so no government archives. So, for example, social media accounts of artists, politicians, activists, architects, etc. We focused on public accounts, so accounts you can access that we can access, so that are private. Also hashtags, that was in the second phase. And we focused us on the most used network services that were Facebook, Twitter, Instagram, and YouTube. So everything we did was tested by the project partners in pilot projects, and like I already said, the goal was to develop workflows and a legal framework. So phase 1 was about looking for open source tools, free open source tools, for the capture of social media accounts. We tested these tools. We also developed specifications for the ingest and preservation of these social media archives. So we made SIP specifications and AIP specifications, and we did also research for phase 2. So we explored the market for commercial tools. In phase 2, we used commercial tools, and we also tested this. And we developed a workflow that could consist of commercial or open source tools for archiving social media. And we also did a lot of legal research, our colleague did a lot of legal research. Phase 3 was more about opening up these archives, so exploring the possibilities on what you can do with social media archives. Can we use it in a classroom? Can we use it for researchers? Also a lot of legal research about making it accessible. And we also did user research, so we wanted to know how researchers or consumers want to access these social media archives. And we were also not very involved in this phase, so little knowledge about this. So our role was to search for the open source tools and test them. It was in the COVID pandemic, so we had a lot of time to test all kinds of tools. We wrote manuals for archivists because the partners in the project didn't have a technical background, and we tried to make manuals that were as easy to use as possible. So archiving social media for dummies, we call it. We also did a lot of technical support during the pilot projects, and we also tested the commercial tools. So the requirements for the tools that were defined by archivists were that they had to be easy to use and install because they had no technical background. But on the contrary, there was also a need to have automated tools that didn't ask too much time to archive a social media account. They also wanted that the archive contains all posts or tweets, images, videos, comments, likes, reactions, etc., and that it contained the original look and feel. This was not an easy quest, so we advised them to use a combination of tools. And finally, we developed 4 strategies, which I will explain now. The first one is the self-archiving strategy. This is that you can, as an account owner, so as a user of social media, you can download the content of your account. So there's some kind of hidden in the settings. You have a button to archive all your content. This is the most user-friendly method, but can only be done by the producer. It's also the most reliable method, a safe method, because it's allowed by the social media platforms. But it only contains your own content, so it doesn't contain comments of other people, it doesn't contain likes, reactions, and it has a different layout. And I heard it's only possible in the European Union because of the European legislation. So I think in the US you can't download all your content. So this is an example of my Twitter archive. It's accessible. You can filter through your content, etc. The second workflow is scrolling. It's like a bot that goes over the page and downloads everything that's on the page. This is mostly an automated workflow. It contains comments, likes, but there's also content missing because Facebook, for example, defines for you what you think is interesting. So all the comments that Facebook thinks you don't find interesting is hidden. The easy-to-use tools are time-consuming, and the others require technical skills. And there are also a lot of bugs. Sometimes it just stops, then it stops working. So this is not the most reliable option, but it's a good option if you want to preserve look and feel. And this is an example of the Instagram of the Flemish Parliament. I think it was archived with archive.page, one of the easy-to-use tools. Then the third strategy was data scraping. That is a bot that goes over the text and extracts all text of a page. Some tools use the official API, and then it's a bit limited. Some tools don't, and then you have the danger of getting blocked. So this gives more complete archives. It's fast, it's also automated, but it contains only text, and it also has limitations. And the most downside of this workflow is that all these tools that we tested doesn't work anymore because they are all blocked by the social media platforms. This is an example of a CSV. It's a Facebook scraper that extracts text from a Facebook account. It contains reactions, comments, your description, also links to the images. The fourth strategy is the media download. That is the strategy we use for services that depend highly on media, like YouTube or Instagram. So this strategy downloads all the images and the videos, and you can also download captions and comments in a text, in a structured text format. So this is also a strategy that is complete, it's automated, it's fast, but it also requires technical background because these are mostly command line tools. And you also have the danger of getting blocked. So Instaloader, for example, for Instagram, several of our partners were getting blocked from Instagram. Then we also tested the commercial tools. More in general, maybe they mostly had a dashboard that was easy to use. We used Page Freezer and Web Preserver. They are actually two tools of the same company. But we noticed that they didn't export well the content, so we wanted always a WARC file, but there was always content missing, or there was something wrong with it. It was empty. They were mostly good in exporting in PDF, but that's not really interesting for us. We also tested Archive.it, which is a service of the Internet Archive. It consists of open source tools they develop, but we noticed that they also couldn't archive the services of Meta, so Instagram and Facebook. It was always stuck at a login page, and we only got the login page in the archive file. So the conclusion was that commercial tools are not better than open source tools, which wasn't really a surprise to us, but it was to our project partners a surprise. And so it was not all rainbows and unicorns, and Lode will tell you all about the issues we encountered.
So the first technical, well, it wasn't really a technical issue, it was we underestimated the expertise of our users, and we noticed that we had to make the guides as low level as possible. Installing software on users' computer was difficult in some cases when there was like in a very strict IT environment. There's the tools that didn't make it through the project. So like Nastasia already said, the Facebook scraper stopped. SNScrape was a really good tool, but was blocked on all platforms, so rest in peace. Twark was a really good tool, command line tool to archive tweets. But then Elon Musk came along and made the API access paid, so commercial. And until now, we can't really access the Twitter API anymore. Browsertrix got archived midway during the project and changed into Browsertrix crawler. The web recorder stopped activity and changed to archive web.page, and there's still difficulties with keeping up with the code changes of the platforms and a lot of unresolved issues. The unexpected issues were the illegitimate DMCA takedown by the Recording Industry Association of America on October 23 of the YouTube DL GitHub repository, claiming it had like material that they had rights on and stuff like that. So thank you EFF for helping YouTube DL reinstate its GitHub repository. Then the rate limiting, which is already what Nastasia kind of hinted on. It's a way of websites to prevent automated requests and to check if you're a bot or not. But of course, we're archivists, at least my colleagues. So it's a lot of hearsay and a lot of checking. How can we prevent and do random pauses at some time and stuff like that. A lot of tools already have built-in ways to circumvent rate limiting, but it's not an exact science. And if you do too much, you'll get blocked or limited anyway, and there's like timeouts. The blocking, which is already mentioned, do not use an organization account or a personal account that you don't want to get blocked, or it might get banned. If you think I will just use a VPN, it's not very ideal because they use the same IP addresses and they will just block the IP address. And then Instagram is particularly nasty because it will mark your account and it'll think that you're hacked, and then I think Nastasia had the experience of her account being marked as hacked, and then she had to reinstate the password and stuff like that. So for the solutions part, we keep the guides as simple as possible because every user's might be the first time when the interaction with the terminal. So every time we mention the terminal, we get a piece, we copy paste the piece, how to use it, how to install Python. The guides need to be kept up to date because platforms change and open source tools also change. There's a colleague network that we participate in to keep each other up to date, and the combined strategies of the one tool to get the data, like YouTube comments, YouTube comment downloader, for example, and then another tool to get layout of the YouTube website. For instance, this is only an example. And see that my little European flag got misplaced, but the self-archiving tool is, by our knowledge, only available in the EU. So for the lessons learned, the requirements of our partners were a little bit unrealistic for one tool to fit. So it doesn't really exist, the perfect tool to do everything you need. And it's, remember to make a dedicated archive account and then make sure it doesn't get blocked, or try to make it as human as possible so that it doesn't get blocked again. So you make a dedicated archive account or more. For privacy reasons, like the screenshot from Nastasia here, if you archive on your personal account, you will get messages and likes and connections to your friends in the archive. So that's why it's better to make a dedicated account. So for archivists, we try to accept incomplete accounts. I know it's difficult, but it's realistic. We noticed that there is, we realized that there is a high dependency on the open source tools, which is difficult, but it's realistic. Yeah, so we wrote a guide and the tool gets changed and we need to rewrite the guide again. Update the guides. We have posted our guides on MediaWiki, so it's a Project Zest website. We can collaborate with our partners to update the guides together and testing the workflow, see if the archive web.page manages to get farther or whatever. Sometimes it stops and then different tools also stop on different parts and check if it's still working. I think Nastasia already mentioned that the commercial tools are very expensive and they're absolutely not better. This also might be that the goal of the commercial tools is different than the open source tools. Yeah, we noticed that social media changed their code a lot. Really a lot, so it's really hard for developers to keep up with all the changes. We understand and we just adapt. And in the best case, the tools stop working for a little bit and then the developer finds time and we're very grateful and they update the tool and they continue to work. The cookie policy was in particularly difficult. It meant that a lot of the tools needed to be updated to circumvent the cookie policy pop-up, at least in the EU. The archive size can be quite big depending if you want to look and feel, but also if you're downloading YouTube videos with the description and the subtitles, everything put together. Still a question on how to ingest it into the digital asset management system, how to consult it. We noticed that a lot of archive systems are not ready to ingest web archives. It also takes a lot of time to make a complete archive. That's also why I said accept incomplete archives, because it takes a long time, especially if you're considering rate limiting, preventing your account to be blocked and stuff like that. The other lesson we learned is to move tools to a new version. Like for instance, YouTubeDL is quite slower in updates. There is a new one, there is a fork of YouTubeDL, so we moved on to YouTube YT-DLP. And then special mention for Facebook. Facebook is a particularly challenging one. Instead, it changed its code a lot. And the fake or archive account detection is very good, extremely good. So it meant that we had to start over again. The rate limiting is also, they are very good at rate limiting. It's a bit of a problem to get around it. And especially for archive.page, Facebook archives are difficult to consult, since there are so many dynamic elements on the page that are going on, so it's difficult for archive.page to load them all and to get them to look nice. And that's the end. Questions?
Amazing. Thank you for this presentation. May I steal the first question? So, is there any like example how do the data look like when they're extracted?
Well, in the best case,
I think you can see it. You mean the files itself, or how you replay it?
Yeah, probably. I would be interested how to read it as a human after it's downloaded and stuff.
It's not mentioned in the presentation, but we archive it in a work file, and there is a website. It's called replayweb.page, and there you can just open and access it. This one is like the viewer. So it just looks like you're on the social media platform.
Perfect, thank you. Some more questions?
Hello. You mentioned that in the EU there's different laws that allows users to download their things. Did you consider contacting the companies and tell them we are archiving public information? Would you help us doing it? And if not, we'll ask the EU to help us force you to do it. And you could, so doing that, you could contact other people doing the same thing in different countries in the EU to have more power to push for that.
We didn't do it personally because we were more on the side of the tools, but maybe our colleagues did. We have a network in the Netherlands and in Flanders, and it would be nice indeed to have a bigger network to contact the social media services. Yes.
This is really cool. Thanks for sharing this and some of the challenges. Have you? So Mastodon's obviously getting big based on the ActivityPub standard. Have you done anything with Mastodon? And while the protocol is still growing, is there anything missing in it that would help your efforts in future?
As for now, I haven't looked at the ActivityPub related websites like Lemmy and Mastodon. We focused only on the bigger ones. Because we are working with other partners, they basically set the line and tell us, these are platforms that are important for us to archive. And so, yeah, that's the question. Thank you.
Thank you for a great presentation. It might be, so I don't know if I've missed something, but you had like 4 strategies, and it's maybe a silly idea, but normally the way you can very quickly kind of, archive something, it's just by doing a screen grab or screenshots. So have you been thinking that potentially some hardware accelerated and script running kind of tool could be screen grabbing or screenshotting your entire Instagram feed? Right. It would be like, I don't know, meters long.
So for most platforms that work with endless feed, they stop feeding you content if you scroll too long. Then they'll just be like, you seem to be scrolling here for a long time. And then again, it's like the rate limiting and the bot detection. So, and I think a lot of commercial tools also use the screenshot technique. Yeah. But for the open source tool and to automate it, you run into the bot detection after a while.
Yeah, and our partners also find it important that it's possible to like go through the websites and
searchable
and make it searchable and open posts. So for them, the screenshots aren't usable.
Have you both done any experiments with recording Facebook groups? And had any success? Because I'd love to hear about that, because I have a group that I feel obligated to.
Yeah, so during the pandemic in Belgium, there was a guy who went a little crazy and wanted to attack one of the proponents of the vaccine, and they made groups in secret on Facebook, and I went into the groups and started archiving them. They were very like right-winged, and I just used archive-web.page to collect everything as much as possible, and those are now, the archives I made are now in an archive in Antwerp. So yeah, it works with archive.page.
Isn't it possible to trick the bot detection by randomizing the bot behavior a little bit?
We tried. A long time. And most of the time you can set randomizers, timeouts, different versions, timeout in a set interval, and then stuff like that. Yeah, we tried. But eventually you run into some bot detection, and if it's not the rate limiting, then they'll detect that you don't have any connections on the platform, you're not really a real human and stuff like that. And unfortunately, if you want to be a real human account, then you risk your own human access to the platform as well.
A question from the live stream here. When data scraping with tools that create a CSV, such as like Twitter accounts, can it harvest images as well?
You have to, so it gives you an URL, and you can use Wget or other tools to download the images. Yeah.
Okay.
Any more questions?
Yeah, they're in the. My second question.
So I know there's a whole network of alternative front-end projects that some privacy-conscious people use. So there are like Nita for Twitter, for example. Have you had a look at those too? Because I know they don't retain the styling of the website, but at least they are very good at solving those kinds of access problems and fetching the content.
I know the platforms that you're talking about, but once again, the partners, they are not users of those kind of platforms, so they just didn't list up those versions. But the platform you mentioned for Twitter could be a potential useful alternative to capture the look and feel without being detected or detected less frequently. Yeah, but for Twitter we mostly tested Spark when we had access to the API. Not anymore. Okay, no more.
Okay, if there are no more questions, thank you very much for your presentation. It was really working. Yeah, thanks to all the speakers of the first part of today. We're headed to lunch, which is at the usual place, and we'll see you around 2 here.
lovely lunch. Maybe we're about to get started. Maybe a note about the afternoon schedule today. At 17 hours, 20 minutes, we had scheduled a closing roundtable, and we're gonna try something maybe a little bit experimental with an open Q&A. Stay tuned for that, I guess. So we can get started with Simon Rep. He'll be presenting on independent, accessible, and sustainable audiovisual publishing on the web. This is a pre-recorded, but Simon will be joining us on Zoom.
Hello. Time to wait. It's great to be here, even if just remotely. There are two projects which I very briefly want to present to you. One is about audio publishing, and the other one is about video publishing. Both of them are built around three key ideas. One is the idea of independence, so they're both developed outside of any proprietary, out of any company setting, and but more importantly, to site operators, to people who use these tools to generate publications. These publications allow full autonomy, full self-control over these publications. So it's yours and yours only, and cannot be taken away from you. The second key point is accessibility. They require both an absolute minimum of technical knowledge, at least in the context of sort of what they try to achieve. That means the barrier for access is a little bit higher than with the traditional, I don't know, software as a service offerings, hosted offerings that we have on the market. But I think this is a crucial and necessary small trade-off to make in order to gain the first point, independence, and also the third point, which is now sustainability. So these tools are, on the one hand, when they run and also the things they generate, they are very light on resources, in the sense of emissions and so on, but more importantly, they function as an artifact that requires no ongoing technical effort to keep it running. So you can long-term archive these artifacts without any cost, and you can keep it online with almost no cost. So basically just you have to keep the server running, which can be virtually any web host, just any web host that delivers static sites. This will run just in the current context of our technology, in the context of standard web technology forever, from a current perspective, of course. I would like to keep the presentations themselves really short, each of them, because I think otherwise in this remote setting it would get a little boring. And afterwards there will be just a few minutes of questions and answers still. I think there's a very exciting mix of people at the conference, so I'd be very curious to hear your takes, your questions, your comments, maybe even have some ideas where future development of FairCamp and Hyper8, which I'm both going to present, could head. So let's get started. FairCamp started out as an alternative to a platform called Bandcamp, which, in contrast to Spotify, very much centers itself around offering a streaming front end, which is more to sort of get a teaser of the material, and then in terms of actually consuming the material, it centers more around the idea of really making singular digital purchases or even physical purchases also, which is financially very favorable to artists and labels, because this way they can really earn a livelihood also, which is not really the case with the current streaming venues. The basic functioning of FairCamp is that you basically have a folder structure. This holds audio files, which are ideally already tagged. You put also image, or you can put image files alongside these audio files. They are used as cover files then. And all of this is grouped then into folders. So to basically mark what constitutes a release, which bundle of audio files and image files. And basically you point FairCamp to this folder, and FairCamp is really just an app that you can install on your computer. And FairCamp then on its own scans this folder, reads out the text, transcodes all the audio files, transcodes all the image files, and generates a fully functional finished website, basically with one command. And this outcome is just a folder. You can open this locally on your browser. You can also do this at any future point, right? It does not technically degrade or anything like that. And you can also just deploy this on a server. You just move it to a static file host, and then it basically runs out of the box without any further technical knowledge or maintenance that is needed to keep it running. This is, of course, a very simple take. So to get started, this makes it very easy to get into it. If you want to build on top of that, there's also a concept called the manifests. So you basically place simple text files in a structured data language called Eno alongside these audio files and image files. And with that, you can enable different features. The list is still growing, but for now, what you can do is, for instance, you can configure what downloads you have. You can enable and disable downloads. You can define whether they are just free there or whether you have to supply an unlock code to do a download. You can enable an RSS feed, an embed widget. You can, of course, adjust the visuals, so the theme, dark light, different colors, and so on and so forth. And about the state of FairCamp, so right now this is used by over 100 artists and labels online to present their music and audio productions in general. And right now I'm intensely working on FairCamp in the course of an NLNet grant. So this is backed by the European Commission's Next Generation Internet Initiative. And yeah, this will be as a target FairCamp 1.0. Beyond FairCamp 1.0, I'm also very interested in improving the accessibility of FairCamp itself. So to provide, for instance, a graphical user interface to make it even easier to get into using FairCamp. And then beyond that, I'm also very much looking into possibly extending the use cases of FairCamp, so to broaden this a bit, so to make it appealing also for people who produce podcasts, ebooks, or in general just long format audio productions. Yeah, and I think that about wraps it up for FairCamp. At this point, maybe I also want to say that FairCamp wouldn't be where it is without really hundreds of great contributors who provided bug reports, tutorials, radio shows, even newspaper articles, and all that stuff. Just thank you so much. FairCamp wouldn't be where it is without that. Let's look at Hyper 8. This was conceptualized as an alternative to the dominant players on the market, such as Vimeo, such as YouTube, and also as an alternative to already great alternatives that we have, like PeerTube, for instance, which is a great free software and federated video publishing system. The aspect that Hyper 8 also wants to add here, though, is that often these systems really rely on either you having the capacity and technical expertise to keep it running, or you sort of relying on community infrastructure, which might not be funded that well, which might involve people that are slowly burning out, which might include, I don't know, social problems. It's just a reality that often these alternatives that we build, they also sort of have these breaking points, and to sort of in an environment where this is important for you, that sort of you're not dependent on these things working out, and where you want to have really a long-term stability perspective, Hyper 8 is basically the idea to tackle that. It works in general by offering a modular building block system. So a Hyper 8 site can be just a video, it can be a playlist of videos, and it can be a so-called collection. And a collection is really a free hierarchical organization where you can have any number of videos, any number of playlists, and again, any number of sub-collections. So this allows you to model any sort of hierarchy that you envision. What is also notable about Hyper 8, also in contrast to FairCamp for now, is that it works with a GUI. You can run Hyper 8 in a browser. There's just one small gotcha that right now, due to just development state, you still have to do one terminal invocation to get the interface running. This will be changed in the future, of course. Yeah, and from there on, you can basically, in this interface, just load your videos, encode them to different resolutions. So you also have full control, sort of what fidelity you offer for videos, which is, I think, crucial if you do like self-hosting, because you don't want to just by default throw out, I don't know, 60 frames per second 4K videos for, I don't know, lo-fi talk recordings or something like that. And in this interface, you also provide descriptions for your videos, for your collections, for your playlists. You can change the sorting and all that. And again, you can do most of the grouping in this modular building block system from the interface. And what is also interesting, I think, is that you don't actually have to use this graphical user interface, but it's a hybrid model. So everything you do in the graphical user interface is also reflected in the folder and file structure. And you can basically edit it also there or just build it directly from there. You can, so in your file explorer, you can really just move around video files. You can put them into folders and annotate them again with simple structured text data. And this way you can also build a site without any dependence on the interface. And then with a single command line invocation, again, you can create this static website asset, which can be deployed and long-term archived at zero cost, basically. At the state currently in terms of adoption, so we have a few early adopters, and most notably we have the video archive for the Derive magazine, which was the project partner with which we kickstarted this project, also with some great support from the Austrian Ministry BMKUS. Thanks a lot for that. We really couldn't have got it off the ground without that, sorry. And yeah, what is the perspective then? If the funding pans out, which I don't know yet, but will soon, in 2025, there will be extensive work to get the app fully integrated as a desktop app so that this step of having to require the terminal briefly to get into the interface falls away. And I want to do a lot of work on subtitles, which are already slightly integrated, but it's really just a makeshift prototype thing. And so that should be fully integrated, also with support for transcripts, also searchable transcripts ideally, so maybe even offering some functionality that we don't see in current platforms even. And yeah, I think there's also some work on the playlists that is waiting to be done. And yeah, this is pretty much Hyper 8 video system in a nutshell.
Thank you, Simon.
Can you already hear me?
Do we have any questions?
Hi, Simon, you're on screen now.
Hey there. Hi again in real time.
Any questions for Simon?
Hi, Simon. It's less a question, more than a. These things look very amazing. So, as someone who's in a band myself and does video stuff, cool. Thank you very much. I'm totally looking forward to looking into it, and then I'll have questions.
I think your question was just more of a compliment, and that this is fascinating. If you have any resources you want to share about how to learn more, we would take them.
Question from the live stream. What are the most requested features not implemented yet for FairCamp?
Okay, I think one thing that was requested a lot was actually integration of ActivityPub, so to connect FairCamp into the Fediverse. The catch there, though, is that I'm not entirely sure if and in which way this would happen. But sort of off the top of my head, this is like the most requested feature, I think.
Thank you so much, Simon. Unfortunately, this is all the time we have. Coming up next is Ross Spencer with, thank you, oh, sorry, my bad. It was really great, Simon, truly. Sorry, my bad. I mean, it's first time doing this. Up next, Ross Spencer, Declarative Programming for Digital Preservationists. Take it away.
Hey everyone, thanks for having me back. As you all know who I am, I'm an open source software developer. I've spent a lot of time in digital preservation thinking about how to democratize the process of like working with different tools. I know a lot of people want to be programmers, but it's not necessarily that everyone has to be a programmer. Also, I should just say there's a full paper around this, so if anything feels a little less fleshed out in this presentation, you can have a look at the full paper. It was written for iPres, but they didn't accept it this year, so I really appreciate having a forum that I can actually share some of this. So how interactive is everyone feeling? Not everyone can be a programmer, or let's see if this works. I don't usually use transitions. Here we go. Who here considers themselves a programmer? Can we have hands up and keep them up? All right, thank you. Until the end of the slide. Thank you. Who's contributed a policy to MediaConch? Okay, one more. Who has contributed a signature to You got to keep your hands up, people. Who has contributed a signature? There's a hand here missing. Thank you. Who has contributed a signature to Pronom? Okay, well, one more. All right. Who has written a regular expression? Oh, a few more. Who has written HTML? A lot more. And who has contributed something to FFmprovisa? All right. So not everyone can be a programmer, but I think there's a lot more of you who are programmers in here than maybe previously thought they were. You can put your hands down now, people. Thank you. So declarative programming is a high-level program that describes what a program should do. In the most basic example, it describes the what and not the how. In the most basic example I could think of, I say, good morning to Dave at dawn. And maybe this is like something you've programmed into an Alexa or something, and at dawn, someone called Dave is gonna be greeted, good morning. If you're gonna do this in imperative programming, which talks about the how, which is kind of like the more traditional view of programming, where you have to like figure out exactly how something is gonna happen, you might write something like this. At 6 o'clock in the morning, while true, and this is just a loop that'll keep on going, if time.now equals dawn, which is 6 o'clock in the morning, print good morning, Dave. But there's at least two things wrong with this. It assumes I'm in the same time zone as Dave, and it doesn't have any awareness of the seasons. So 6 o'clock is not always going to be dawn. So a really simple piece of code, but by the time you start thinking about how this is actually going to work, you're going to start adding a lot of new functions. 10% of software is writing code and 91% is debugging. If you go down the street there, you'll see the sign over there. And yeah, the idea, we got side effects on this slide. So yeah, this is not printed as nice as it should have. But yeah, so imperative programming basically has two layers, which are difficult to see here. But between layer one and the computer, so the how that you've written and the computer are side effects. So it's all the bugs that you're gonna have to figure out. If you have a declarative layer on there, you have something called network effects. So there's potentially lots of people writing in a declarative style on top of a layer 2 imperative that, yes, someone has to program. But if that layer 2 is, very solid, the declarative approach on the top becomes even more solid. And the outputs of that can be shared to many more people. And we have, and so the benefit flow, you get some benefits from someone maintaining the layer 2, but you have a lot more benefits for people who maintain the layer 3. And these mysterious emojis were meant to be people. And I was going to make a joke that the benefits flow up to the members of Queen in Bohemian Rhapsody, but I can't make that joke right now. We have examples. So we have examples that we know very well in the field of digital preservation. Schematron is one I really wanted to remind like the digital preservation community about. Like, it's from 2012. I don't necessarily hear a lot about it anymore. It is very much an XML-based approach, but it looks for patterns within an XML document that people can make assertions about. So, and Johan van der Neef, who developed JPlyzer, used Schematron to like say, okay, well, I've got this capability to extract all the information I have about a JPEG 2000. How do I then create a validation tool for it? So I use the output from JPlyzer, put Schematron over the top of it, and say, you know, reason about it. So a really basic Schematron example is test when JPlyzer says, is it a valid JPEG 2, and it appears in the report, it either passes or fails this test. And of course, I can't not mention MediaConch. I think it's about 2015, but it's very specific to digital preservation workflow, more specific to digital preservation workflows, and accommodates more tools. But it's the same. This is another example of declarative programming where you declare the what you want. So you want a TIFF that is that's got zero compression. And if it has these two things, it passes, and if it doesn't, it will fail. And so it might fail one of your workflows. In plain language, that looks like that. I just wanted to, another example we have is Pronom. I think what's really interesting about, so if you don't know Pronom is a format identification tool. It contains these regular expressions, and these, this is another form of declarative programming. In this instance here, you ask, does the start of the file have the byte sequence bad food 1? Then look 23 bytes later, does it have the sequence ACDC 1, 2, 3, 4? And then at some point in this file stream, I'm going to find cafe food. So look for that. And 72 institutions have contributed to Pronom in 2023, this was. And so that's 72 had contributed, and like everyone across the globe benefits from that. Because like as soon as it gets into the Pronom database, it gets to everyone. I really like this example. This is from Richard Lehane. I don't think he like continues to maintain it or like had any plans to maintain it. But what I like is it's a specification that describes rules about a digital repository. We see the same pattern in Premise and Premise rights. But yeah, so it describes access rules for file. And if you write, so that's the declarative bit, and people can write different tooling underneath that support this standard, and you'll have a consistent behavior across every implementation. And we see that a lot in standards and protocol development. What I like is it really felt like an Nginx for archives. So sometimes that that layer between your computer and the outside world that's running a web server is often just a text file that describes some rules that says someone can see this, but they can't see this. It's like a very powerful mechanism, but it's kind of scary when you think about how it is just a text file. So the importance of declarative that I wanted to bring to the group was about where work is done and how it's done most simply and efficiently to achieve what you need to achieve. It can be very easy to start designing software. And as a developer, and if you have a developer or access to a developer, or you are a developer, you can really just start writing. And before you know it, you've got 100 functions doing a lot of stuff. But I think it's really important. I think one of the messages of this is to think about different abstractions, different ways of planning your work, where there is another way of doing it that doesn't involve that can maybe allow other people to access what you're doing, like perhaps building a declarative layer on top of what you're doing. And yeah, you scientists were so preoccupied with whatever they could, they didn't stop to think if they should. And you see this a lot in software development. A piece of software does A, and someone, probably a higher up manager, says, Can I do B and C? And it's like, well, it doesn't really need to. Like, well, let's plan this and like figure out the right place, the right abstraction, and everything else. And yeah, and so that's Maslow's hammer. Yeah, what I wanted to do is like point out that other tools exist similar to media info and you know, and MediaConch sits on top of media info. FQ is a tool for it's JQ for binary formats. I'm sure it's probably already been presented here in the past, and it's definitely one to look up. You know, can we take the output of something like FQ and build a community around it in a sort of declarative way, like maybe something very MediaConch looking that takes the outputs of FQ and then like allows us to integrate sort of a declarative layer of using it into our digital repositories, like for validation and more identification. So yeah, and you know, that if we're thinking about the next binary format that we're going to interrogate, or with an imperative language, maybe we look at FQ first and figure out, you know, what abstraction we can build on top of it. So I think if you are able to architect a declarative language for something that a lot of people do, it can lower barriers. It can make it easier to access network effect and provide opportunities for more people to engage. Like Pronom is just such a good example. Yeah, and I don't use MediaConch right now, but I assume there's a strong community of people contributing recipes to that. Theoretically, there are fewer lone coders, and it does make it easier to collaborate. And the more people engaging in a project or something like this, you can start to explore what the bigger implications of this are. So I was interested in, I wrote a paper about converting premise events to an actual event-driven based system. And when you look at the projections that you can build on top of event-based systems, they start to look a little bit declarative in what they're doing. And so you can maybe start reason about much more longer running processes and their outputs. And that could be quite a cool thing to think about. But yeah, I think you always need to think about design patterns. And I think one of the things that really caught me off guard was when I started to think about this, like I had all the different links, like I was like, but I didn't know what it was I was looking at. I didn't actually, from my experience in the industry, I didn't know this was declarative programming. So what I wanted to share with folks was like, maybe if you don't know it's declarative programming, maybe that's helpful for you too. And so if you can name it, you can tame it. And there are other paradigms out there that we, you know, instead of like starting to just like, let me just write a Python script for this, maybe there are other ways of doing, you know, writing the code, other paradigms we can consider. Functional is another paradigm where it theoretically has no side effects, but it's a difficult paradigm to understand. But maybe, you know, with some of the integrity and the sort of precision we need in what we're doing in archives and digital preservation, maybe something like functional programming is a way of approaching like some of the sort of back end stuff that we're doing, where we generate fewer bugs and we get more consistent outputs. Requirements and use cases are always important. I think, yeah, it's another thing I wanted to come back to is just the idea of like just resurfacing some of this, like especially the schematron stuff, looking at prior art and what exists and whether they can be harnessed for something else. And also the idea of building interfaces and standards like the meta package that Richard started working on. And so if you want to go fast, go alone. If you want to go far, go together. And if you want to go further, document your use cases, design a standard, validate it with a team of your peers, and then go together, which I think is something this community knows especially well. And I know it's hard work to maybe sit down and think like really long-term and strategically about a piece of software and where you're going to take it instead of just like, again, it's really satisfying to like just start writing code, but maybe you know, we do start with standards and then we look like, oh, this standard might benefit from like a domain-specific language or like writing a declarative layer on top of it, and I think that could be really satisfying for people too. And it might seem a stretch. I hope it doesn't. But it's the network effect of this stuff, like the way that people contributed to the Proton database or MediaConch, and potentially could have done more with the schematron stuff as well. Like the network effect is massively important, and I think it is one of those design decisions that you put into your architecture. It's like, can I build this in a way that other people can use? And if other people are going to use it, what does that need to look like? And again, I know it's difficult. I know we don't have like all of the resources. We have to really think about ourselves a lot of the time. But you know, open source is a thing, and network effect is kind of rigged to like benefit from network effect. And that's kind of the sort of the one takeaway I wanted people to take from this is like, I think everyone who engages with an open source project, whether writing documentation, logging issues, they're all programmers at heart anyway. And like they don't have to like write a line of Python to really bolster a project. Take the last presentation as an example of that. And I only just saw this, the Wikipedia motto of just be bold. Like if you have you know, and I know there are people in the room that like will jump into a GitHub and just like log issues. Just do it. Don't be scared. People will always be responsive to people who are engaging with your projects. This talk was inspired by a project that Bernhard and I tried to get off the ground. It was like, how can we get a group of people together to like share and like build a piece of software from scratch, satisfying a new demand? How do we make a didactic opportunity for people to get like experience building software, coming up with requirements, answering the questions about, you know, how do we resolve, like, how do we have this feature and not this feature and so on. It didn't get off the ground, but after we took some time to think about alternatives and sort of and then we we didn't chat for a while, but like the seed of it helped me think about like this as a presentation that I thought might be useful for people. And if people are interested, there's a link to the paper and other resources. And I'm happy to take questions if there's still time. Thank you.
Thank you. Sounds awesome. I get it, and I totally don't get it. In terms of like, I would not know, maybe it's so obvious, like, so I would declare something, and then how would that happen to become code that actually runs? I'm like missing that part.
I'm sorry, can you rephrase the question?
So I would declare something, like I'm thinking schematron now as an example. I probably would not do that by hand, because if I could do that, then I would consider myself more of a coder. How do you jump from that to actual running code?
Yeah.
So you're like, and then you declare stuff, and then code's happening, but I was missing how.
Right. It is kind of, it's what's it called? It's the problems at both ends anyway. Like you either have to design so that you build the declarative layer on top, so that people are able to engage with it in that way. So like the example of Meta was, you had the standard first and you could build the implementations on top. But the people who would use that standard would be doing the declaring, and people would be building the implementations that took away the work of programming. And then the other way around is, do tools exist that already have outputs that could be harnessed? Like JPLyzer existed. So now you can write a layer on top of JPLyzer that does interpretation in a potentially very lightweight and easy way that other people can engage with. So you either need to write the standards and think about building the declarative layer, or have some data you can use that you can then use declarative methods on top of. Right, I hope that helps a little more. Thank you.
Any more?
Hi, Ross. So have you thought about implementing this with things like Demystify or some of the other applications that you maintain and have created, and how you could incorporate that?
Have I thought about eating my own dog food? Is a phrase from, I guess, the UK. Yes, but only recently. I think in my day job as well, we have there's some things that I'm thinking like might be better off if the abstraction was like higher, so that more people could engage with it. Have I implemented it yet? No, and I do think it would be a challenge. I think, you're like doing second order thinking as a developer to like write the imperative stuff and like a way of people engaging with it. But there's an interesting language called Python Behave, which does feature testing and behavioral-driven development. But if you look at that language, that actually does like satisfy some like really nice properties of the declarative language that you might be able to put on something like your other Python code and like get this kind of output. Anyway, might be interesting.
Any more lingering questions in the room?
Thank you once again, everyone. I appreciate it.
Thank you, Ross. Right, coming up next, we have the future of memory. Please give us a little bit of a few, maybe seconds or minutes while we set up the Zoom. This will be a mixed media presentation.
All right, Ashley, Jimmy, camera's on. I'm going to put you on screen. Can you test your mics?
Test.
I hear Jimmy.
Test.
Thank you very much. Welcome everyone to the Future of Memory. I'm going to start by introducing the roundtable panelists and my co-author and myself, then Jimmy will take over. So this is a combined roundtable discussion and a book presentation. We'll have 20 minutes of discussion with our participants, and then we'll open up the floor to questions. So I'm going to start by introducing Ashley. Ashley Bluer is an archivist, educator, software engineer. She's an expert in building video analysis tools and pipelines. She specializes in video and audio formats, digital preservation, systems and workflows, and community support and solutions, and also teaching of technical concepts at all levels. She is the author of the Illustrated Guide to Video Formats, which came out in 2022. And Ashley is also a member of the Cellar Standardizing Initiative, which is standardizing FFP1, a video compression codec, and Matroshka, the container. Sitting next to me is Marion Jax. Marion is a digital archivist at the Österreichische Mediathek. That's the Austrian National Sound and Video Archive in Vienna. Before she moved on to the field of digital preservation, Marion specialized in the preservation of the digitization of analog video at the Mediathek for more than a decade. And her background includes an MA in history from the University of Vienna, and she also has qualifications in library and information studies at the Austrian National Library. Steve Lum works on the VLC media player, ubiquitous, known to all of us. He's a developer, and among his contributions to open source technology is the development of the container format Matroshka, which is one of the four main protagonists of our book. My esteemed co-author, Jimmy Jones, is an archivist at the Center for Innovation in Teaching and Learning and an adjunct instructor at the School of Information Sciences, both at the University of Illinois at Urbana-Champaign. My name is Marek Jankovic. I'm a media historian at the Vrije Universiteit Amsterdam. I'm obsessed with the history of video formats, with the idea of formats, and also with the history of film and video as a physical thing. So thanks everyone for being here. Just a note on the title of the panel. So the future of memory is a phrase that appears somewhere in the promotional documents for Performa, which was this large format standardization initiative that was happening about a decade ago. I think No Time to Wait is also taken from one of the Performa workshops. And we thought the future of memory sounds so pompous and overbearing that we just had to borrow that as the title of our book. So with that, I hand over to Jimmy, who can tell you more about the project.
Thank you, Marek. Thanks for the introductions. I'm glad you did the introductions because I would have completely butchered the name of your institution, Marek. I would not have pronounced it well. So Marek and I are here in support of an upcoming book called The Future of Memory. The book is going to be published and released by the University of Illinois Press as part of their history of media and communications. I do have a brief elevator pitch about the book to read for you.
A tiny bit.
So, drawing on numerous, I'm not sure what I can do. Let me see if I can move the microphone closer. Tell me, just feel free to interrupt if I'm breaking up.
Yep.
Drawing on numerous interviews with preservation experts and standards developers, this book reveals the complex social dynamics of creating and implementing archival format standards. This is a history of a pivotal decade in audiovisual preservation, a field undergoing a tremendous transition. It chronicles how archivists navigate digital technology's promises and constraints amid industry-driven standardizations and emerging open source alternatives. It shows the audiovisual archive as a messy, dynamic space where people frequently disagree, where machines often fail, but where different communities also collaboratively develop resourceful solutions to unexpected problems. One of the things that we focus on is the Cellar Working Group. A lot of people from Cellar are undoubtedly here today, that has developed FFV1 and Matroshka into formalized standards. For many years, we have been following and documenting how these wild formats became accepted by such august institutions as the Library of Congress. This is a watershed moment for archives which have never had much influence on the development of the formats that enter their collections until now. This book began as a merging of two dissertations, both mine and Marek's. For me, it represents about a decade of work. The idea for the work on my part started while I was working at the Library of Congress about a dozen years ago. We had a FADGI meeting. We were talking about MXF and JPEG 2000 and the standardization of it we were doing. And Dave Rice opined briefly, hey, why aren't we using Matroshka? Why aren't you considering Matroshka for this work? And that just kind of got a little, just kind of dug in a little bit in my brain and left a little worm there. And I had to explore that later. Why aren't we using Matroshka? Marek comes to this work from a more of a media theory perspective, and I'm coming from more of a library science perspective. And we found, I think, a really nice merging of the two to explore this interesting time. We conducted many interviews, like I said, for the book. I think a lot of our interviewees are here today, so I wanted to say thank you again for your participation in the work. And with that, I think we can dive into the questions for the panel, of which I think I have the first one. So we kind of thought about topics for this discussion, and the first one was the changing landscape of formats. One of the big themes of the book is the proliferation of open source standards like FFV1 and Matroska in European and American archives over the past decade. And I wonder if the panel can reflect a little on this significant change compared to the use of industry-developed standards like MXF and JPEG 2000 in the past.
Ashley.
Who's gonna talk?
Yeah, I know.
Something that has been coming to mind when I was looking over these questions was mostly around how this is a format, obviously it's sort of designed by the people for Steve Loam's purposes only, and expanded out to have great use. And then the efforts by archivists to champion this format, I think also aligns really well with government funding, because the Performa project funded by the European Commission is what allowed us to kick off and start this work for several years. And then recently last year, I was also working on a contract for the Library of Congress to investigate sustainability of around 40 different formats and how those may be assessed. And so lately I've been thinking about the role that like public funding has played in this versus private capitalist funding, which does not align with the future of memory. I had to stop there.
Hello. It's actually Matroska didn't start with me. It started with another guy who made a format before me, and I jumped on his project. So there was already some interest. As we discussed yesterday, there was also Og Vorbis, which is a really internet age format, which was designed by people on the internet, but mostly for streaming audio. But our idea was that OGG was not good enough for video, which proved right. And basically, so we started working together and gathering more people. It was just basically one web page with the design of a new format. And then the guy went to the army. I continued the work. He came back, we disagreed. So basically, it was just a collective effort from the very beginning. It's not just me. I just put some ideas, and actually the effort of bringing the project together and continuing until it's actually real. So yeah, from my background, I had absolutely no background in media storage, whatever. I studied mostly audio and video compression, but nothing about formats. So for me, it was very new. I would have never imagined it would be used in archives in the future. That was it was one of the features, like streaming, editing, and long-term archival, which in our idea, I think we wrote that in the original website, was it's designed to last for 10 years, which at the time were every 6 months there was a new format and everything. It was changing so fast. For us, 10 years was like forever. And it proved also that we did the design correctly so that it lasts, and every new generation of codec, mostly video, but even audio or HDR and video, etc., we were ready to use it. So yeah, for me, I can't tell you how much difference it makes, but from before, because I wasn't there before, and this is not even my world, but it was part of the design anyway.
I can bring you back to the year 2010 when the Austrian Mediathek adopted FFV1. I would say what changed definitely for us with the standardization is that we don't have to be afraid mentioning that we archive in FFV1. So when we adopted FFV1 at the year 2010, it was groundbreaking. It was controversial. It was terrifying because we got attacked on so many sides. And I think when I look back at these times now, then Hermann Lewetz was the head of the technical department, who was brave to take this decision. Peter Bobestinger was our programmer who consulted us and who actually had the idea to use FFV1. When it comes to Matroska, we didn't dare to use it because it was so controversial to use FFV1 then that we wanted to play it safe and not be torn apart, and we used FFV1. I say we were very close to be torn apart by the community. It was such a hard time because we did something else and we were loud about it. Peter and Hermann went to many conferences and talked about the decision. And I think some parts of it were naivete, like being naive and presenting a solution and actually thinking that the community would be, oh great, you have a solution for us. And the community was very cruel to us, to be honest, most of them. So yeah, I think it's great how it came out. I think it shaped our archiving experience very much. And I think it's a story of what happens if you dare not to adhere to a standard and to go rogue and do something else. So, yeah.
I'd like to add on the naivety, yeah. Naive. Yeah, that's also our whole state of mind from the beginning, like we're just some people working together, creating a format, like we had no idea if people would use it. And it kept growing step by step. There was no master plan. We just did our thing, and I mean, with no goal, or I mean, just basically it was for us to have something good that we considered good for us. And yeah, so basically the whole idea was that anybody can use it, but without knowing how, and people would just come to us. We never knew when or why, and I mean, that was the whole spirit.
I just wanted to mention, clarify something, because I said out of desperation. So I would clarify that our initial plan was to do JPEG 2000 in MXF, which we could not replay on our machines, and we didn't dare to do that. So it was a state of desperation, and we had some money to digitize 2,000 videos, and we had a time frame of 2 years. So what to do now? And FFV1 was the solution then.
A large part of the book documents precisely this project or this process of how and why formats that were 10 or 15 years ago associated mostly with piracy, in the case of the container Matroska, or were completely unknown as encoders in the case of FFV1, were also very strongly attacked. There was a lot of suspicion surrounding these two technologies. How do those types of technologies over time become accepted, right? What are the factors for, making them acceptable and eventually also recommended, right? Such as in the last year's Library of Congress recommendation, where FFV1 and Matroska as a combination finally ended up being recommended for moving image preservation. So it's a very interesting social process. It sounds like it's a largely technological question, but it actually involves a lot of politics, a lot of ethical decisions as well. And the Austrian Mediathek has plays a large role. Actually, our introduction starts with the first public presentation by the Austrian Mediathek, in which FFV1 was presented as a potential archival format. Jimmy, I think you have a few more questions.
I do, yeah. I want to ask about the place of compression in the archives. One of the themes of the book is losslessness, lossless compression, and the place for like notions of losslessness in the archives. Do you think, this is to anyone on the panel, will compression remain important to archives as computer processors get more powerful and storage space becomes cheaper and more plentiful?
Should I take it? I would say yes, because the storage space we need is ever growing, even if it's get cheaper or stock is expanding. And I think compression depends on what you're talking about. Like today I talked about our Born digital collection, who is compressed, and about preserving it the way they are, which makes sense. But when we produce our files and we digitize our analog material, FFV1 is the one thing to go. I wouldn't think of using anything else or going to uncompressed.
Ashley, would you like to add?
Yeah, I think that's a really difficult, complicated question. I think because formats are so difficult and complicated, we're constantly changing. We think about like social media, integration of those kinds of formats, other web formats, the complexity and largeness of different kinds of formats that we've all talked about over the past 8 years at No Time to Wait. I think it's no. And then the creation of access copies is always going to require something that's lighter, easier, lower latency, better for streaming. And so I think that we do have to be equipped to understand all of these different types of formats, and that is another panel and book and conference as well.
Thank you. Steve, you probably also have a lot of insight from a different perspective as, someone who works on VLC.
Actually, from the Matroska person, I designed the format, well, not just me, but the format is designed so that it's codec agnostic. So no matter the codec, it was the same. And all the tools, Matroska tools that have been designed are in that, designed that way so that you don't need to know which codec is inside. It doesn't matter. But on the container, it's opaque. So from the container, it doesn't matter if it's compressed or not. All we need, actually, some of the work that's been done because of the archival and, for example, uncompressed, was making sure all the fields that are usually inside usual codecs, like the colorimetry and things like that, that were not in Matroska, were added back, or the number of bits for if it's RGB, YUV, etc. They were not originally in Matroska because people were not using uncompressed. They were using a codec that have all the information. So we had to have the information in the container for codecs that don't have it, but that's pretty much the separation. Otherwise, the codec doesn't really matter. And that's one of the difference actually with OGG, which OGG is designed to be really tied to each codec. So every time you add the codec, you would have to know how to map things. If you have something that understands OGG, you cannot read any codec. You have to exactly know how it works. So that, and knowing that at the time, that's how we make sure that the separation is absolute between the two.
I have one topic that I would like to ask about, and that's the question of gender and standardization. So the Internet Engineering Task Force is praised and respected for its openness, for the openness of its standardization process. But in recent academic literature, there's also increasingly critical voices about its institutional culture, which can be abrasive and hostile to women. And even though our interviews were not particularly designed to elicit responses about gender, this is actually also something that occasionally popped up in the interviews. So I would like to ask, well, Marion and Ashley in particular, if you can touch upon the role that gender plays in standards making, but also in archival technology more broadly. Marion, would you like to start?
I cannot talk about standards making or the IETF, so I can generally talk about my experience working in the archiving field as a woman and always in tech from the start on. One conclusion is that it gets much, much easier when you get older. So this helps a lot, and being known in a community, this helps also a lot, and standing for something and having opinions. But I still experience that it's, how to say it, it's often with external people that they do not expect a woman to be the person with technical knowledge and to be the person to talk to. So I still get that sometimes, and I have my strategies to do that. So you have to say some clever words and make sure, talk to me, and it's not my male colleague who's working for press or public relations that you should talk to. Yeah, but I think it's slowly changing. I think there is a generational gap. Most experience I had are with older technicians from the RADA production field. Yeah, but I love to see that there's more and more women coming in the field, and to always see great, strong women talking at conferences like that.
Thank you. Ashley.
Yeah, I am a software developer by trade. I also identify and present as a woman, femme presenting person. And so obviously I've experienced tons of discrimination across the board. I'd say that I think some of the obstacles with the standards development in general is, well, one, it is like, I think a generational difference a little bit. I think that maybe we will be seeing some changes in the future, but we've also been saying that for like 100 years at this point. But I do think a lot of the people that are allowed to work on standards are people that have already reached a high tenure within a private organization and then have been like sort of allowed to do that work. So you think about like the pipeline or the funnel getting more and more narrow, and then only when you're at a more staff or senior level you're able to spend time dedicated to doing that. And we don't, I think, have enough of anything to allow diversity there in any capacity, gender or any other sort of layers of diversity. And so, I mean, I'm not coming here with solutions. I can only come here with complaints. But it is something I've noticed, but it's something I've noticed in all aspects of my life. And then even at the first No Time to Wait, someone came up to me and said he wanted to speak to the developers. And what he meant was he wanted to speak to Dave, who, as at the time, and I'm sure now, I think also does not identify as somebody who is a developer or a programmer, identifies as an archivist or a technologist. And I'm someone that was and is actively working as a developer. And so he just sort of saw me as like the admin girl rather than someone to take seriously. And so it happens constantly. It's a big problem. And I think that I don't know what I think.
Okay.
Ashley, I'm afraid we lost
I don't know
you.
what I think.
That was
Sorry.
I can tell.
Ashley, we lost you for a moment. Would you mind repeating the last couple of sentences? I think the connection might be unstable. Oh no.
Oh no. Okay.
Sorry, everyone on the panel. If you can hear me, we've just lost you for a second, and we need to beam you up on the screen again.
Or she can repeat while they are working.
Ashley, we didn't hear the last couple of sentences.
Yeah.
Oh yeah, and I just sort of rambled out, so you didn't miss anything after that point. I said I don't have any like deep knowledge or solutions on this, but it is still a problem.
Right, so what I'm hearing both of you say is there have been small incremental improvements, but overall barriers to women and the way women are seen in archival technology as well as in standardization are still very much there.
Might I add something? I think that there's in archives, often there's this strong tradition that men take care of the technical stuff and women describe it in the metadata. And I think that institutions change slowly, and this bias is like what you still see everywhere. I don't have a solution, but I have a request, and this is especially meant to other colleagues, just to be mindful. I'm thinking about male colleagues who could say, "I'm not the person you should talk to. She's the expert on my side." Or what I often feel is like it's so nice to be the center of attention, that it's hard for people to say, to help a woman on the side to enter the conversation and make it clear. So I think it's a request to be mindful and look at these things, because it's often I feel of a lack of thought.
Thank you. Ashley, is there anything else you'd like to add?
No, I agree with everything Marian said.
Thank you. There is one more issue that I want to touch upon, and this is not something that we can really address in this particular panel, but it's also something that popped up throughout the research for our book. We spoke to a small handful of archivists in African countries as well, Malawi, Ghana, Nigeria. Not many, but a few. And for many of them, the common recommendations of the FIAF of IASA are just technologically and infrastructurally completely out of reach. Some of them, in fact, explicitly view archival standards as extensions of colonial relationships. So I wrote down a few questions on my paper, but I realize that these are rhetorical questions because it's not something that we can answer here, but I want to put it out there anyway. You know, how do we make video preservation standardization inclusive, but also realistic and sustainable in terms of technical specifications, so resolutions, bit depths, but also in terms of personnel, technological and infrastructural requirements? And also, how do we reach communities that don't have the technical or knowledge resources to adopt particular standards or to participate in the standardization process itself? Again, if any of you have ideas, please feel free to voice them, but I'm not asking you to come up with solutions here on the spot.
Why are you looking at us?
Marion?
Just a few thoughts. I think it's coming from an archive who started off with video not adhering to a standard. Yes, this can be a lot of pressure, but I think it's a lot about it's okay to be diverse and it's okay to give to assume that an archive does the best in its circumstances and not condemning others. I think it can be a lot of pressure if you cannot afford to adhere to a standard or to have a large storage space to store those things. So I think it's about being open, and we all do our best, and it often means doing our best in the circumstances and with the resources that we have.
I do have one idea or point, is that we always try to make Matroska completely free. Nobody has ever paid for Matroska. And the fact that it's on IETF, which is available completely for free compared to ISO or whatever format, that even like the C language is an ISO. So every programmer in C in the world who doesn't have a company can buy ISO documents, is using a draft, and basically the draft has become the de facto standard because nobody can afford the real document. So maybe there was some changes between that draft and the real standard, but most people don't know. So yeah, for us, it's really important that all the specifications are free. Maybe there could be also a language barrier because everything is done in English. For most programmers, it's not such a problem because it's all programming language, modern ones are in English, but like reading specifications in English can also be a barrier. But I don't know if the IETF has some initiative for that to translate the documents when they're settled. I don't think so.
Thank you. Jimmy, do you have any points?
Not off the top of my head. This was a really interesting kind of revelation through the course of our research. My research was so American focused, perhaps understandably. Merrick, I think you're coming more from a European perspective. And I think one of the things we point out in the book is this is definitely an avenue for more exploration. This notion of potentially standards as colonizing technologies. I think there's work to be done there, both scholarly work and then also like repairing that kind of relationship going forward in the future. Steve's point is really well taken. The openness of standards means that the potential openness of standards, particularly the seller standards, means that in theory anyone can decode them. That again is another kind of vein through the work, which is the hand-me-down standards that we have worked with from broadcast in the past have been very closed off, black boxed, and perhaps the openness of the seller standards will help to ameliorate this problem a bit of standards as colonizing technologies. That's our hope anyway. But I strongly think there's more work to be done in that scholarship, just like the earlier conversation about gender and standards development, adoption and archives. Definitely more work should be done there.
With that, I would like to, sorry, apologies. Ashley, please.
I was saying that, so I think what everyone is sort of speaking about here is I think that Stellar has done so much work in opening up flexibility around standards. Like Marion was discussing earlier, how it was very controversial to do this adoption 14 years ago. And I think along with adopting these kinds of formats, just allowing for the existence of other formats to be deemed a standard, along with the increase of community archives or like pirate archives, I think allows sort of archiving to be seen in a more flexible and nuanced way. And I think archivists sometimes bristle at that because they want the best quality, et cetera, or you're not doing it right. But I think we've also seen a lot more growth and flexibility around that, and hopefully we continue to. And I think by having it be like there's not just one way to do media preservation that can allow for more voices to be doing this work, involved in this work, and like documenting this work and coming up with their own ideas and empowering other people to do so, rather than it has to only come from one organization or company.
Thank you, Ashley. With that, I would like to invite everyone in the audience to, join the discussion, reflect on the last decade of standardization, but also maybe think about this question whether open source standardization can be a model for future formats or encodings or other technologies that are needed by archivists and preservation professionals. Peter, you had a question.
Hi, Peter Westinger. May I, for the thing how we could decolonize things, I think what we've seen here is that open software, open hardware, open licenses, and so we have all these tools and solutions being paid for, and then everyone can use them. And my experience is that if I use, for example, a Linux operating system, I can use hardware that is way older, like 15 years plus. So I also used to work in countries with people where there really was, I don't know if I may say third world or whatever, but the thing is that they say, thank you very much, because now we can use your tools. And we're not stealing them and want to borrow them, it's not freeware. We actually have the real thing, and we can now collaborate on the same eye level, and we can use the hardware that we have access to. And this does not only apply to standards, but I see a real benefit there. And also with the art community, and these days, Arduino, Raspberry Pi, so I think there's a pattern there. And I think it has really great potential also for us in the Western world, because I don't want to have to use a Mac. I'd rather use a Linux machine to ingest video. It's also cheaper and more stable for us. Yeah. Thank you.
I would bring a point that was discussed just before about standards, and I would give an additional perspective about the recommendation that, for instance, bodies like FIAF give, and they are so high that only a few people can accept that. And it's very important to lower these expectations too, because the 99% of the archives worldwide cannot afford other things than a scanner with a Bayer sensor. And they cannot continue to say that the Bayer sensor gives a bad result. They cannot continue to say that you need 4K for 35 millimeter. And it goes exactly to the discussion you had before, that the expectation has to be lowered to a realistic level that can be applied in the long term and on all levels, not only on standards.
But isn't it finally the idea of a standard to describe some kind of an ideal? And then it is kind of, okay, more or less clear that nobody will ever reach that ideal to the fullest. And it's not only archives in Africa who cannot, as Jureto just said, really implement these standards. Everybody makes some compromises. That's a global thing. I think that's not something limited to developing countries also.
I completely see that point, but I also think that perhaps energy consumption and environmental responsibility are ideals too that could be embedded in standards making. That's just my input. I'm wondering, at the Austrian Mediathek, do you grapple with this idea of, when is enough? How far do we go with resolutions, with bit depths? Are we going to keep increasing them? Is that something that pops up in your work?
I would say not to that point. But I think where this gets important to be realistic is in the pressures of digitizing our analog collection. So we know that time is passing by, and it's already very hard to get good recorders and replacements, and to find companies that still repairs your recorder. So I think what I often said is that I prefer that instead of doing a tape for the 6th time, I prefer to do another one and preserving another one, which might not be the absolute best copy, but I managed to preserve another item of our collection. And this is in a race where we all definitely know that we are going to be able to save everything that we have in our collection. So I think we really have to think about the whole collection and trying to get as much as possible to the digital world. So that's why I think we have to do compromises.
Ashley, I'm wondering if you have any thoughts on this. Sorry, no, not just, good enough preservation rather than best practices?
Yeah, I mean, I 100% believe in good enough preservation. I think I wrote like sort of good enough practices and not just expecting that everything has to be done in this perfect way. So I hope that, and I've seen a lot of changes across different institutions just in America around accepting formats that are not perfect. And I think that I've seen a lot of reduction in bullying around this at archival conferences, but I don't know if that is bias on my part because I am older and not maybe roped into talking to people that are going to do that kind of bullying to me about like, oh my God, you're not using blah, blah, blah and using XYZ. Like they kind of know better for me personally, but I also hope that that is the case for people that are younger generations coming in and that they are a little more radical and coming from the approach of a more community-centered form of archiving. I've seen that change. I just hope that change is true. I can only see that through my own lens, biased lens.
Thank you. We have more input from the audience.
Question from the live stream. Sum it up. Is a standard if it's not a global standard? Like, is there a point to push for like regulation?
Is this a question to anyone in particular?
No.
Is there anyone who would like to take this one?
I think it was at the first No Time to Wait that it was said that a standard is only something that people agree on. It doesn't have to be, say, standard on a document to become a standard. And basically, Matroska, I mean, we cleaned up the document to make an actual standard in the IETF sense. But it's already a standard because people use it the way it's supposed to be. So it's already a de facto standard, and as we discussed earlier, it's being adopted in a lot more programs. Even like yesterday, we talked about DaVinci, about Apple supporting WebM, things like that. Like even if it's not an ISO or whatever standard, or the IETF document is not finalized, I would consider it's already a standard because people agree together to just use it.
I think we're actually seeing a lot of international institutions adopting to a new reality, and that's a multi-standard reality. I think the era where the entire world could rely on the ISO or the MPEG to dictate what's going to happen is over. Partly that has to do with political developments, with a shift to a sort of nationalist technopolitics. But yeah, institutions like the EBU are also adjusting to the fact that there are regions of the world and specific countries that are just going to insist on developing their own standards, or that large tech companies don't like standardization anymore. They're just going to do what they want to do because they are large enough and their user base is enormous. But also there's communities of practice like archivists who are not served by those standards, and they are going to start developing their standards too, like we see with Cellar. I mean, that's the perfect example of that. So I think this multi-standard world is increasingly becoming a reality. That's just my view on that. I think that might be almost all of the time we have. Are there any other questions or comments? Anything you'd like to add? Yes, Peter.
Before you were asking, like, what was the tipping point for acceptance of FFV1 in the community? And Marion said it was really ugly, and it was really ugly and hurtful at the beginning. It was money. From my point of view, I was like rappelling at trees, I was begging, I was crying, I don't know. And they were like, we're not going to touch it. The other archivists were like, we're not going to touch it. And then Indiana University, no one ever contacted us at the Mediathek, no one asked me anything, but they threw in money. And from that point on, it was, and then they were like, ooh, someone believes in this with money. And then the people who ridiculed us 2 years before, yeah, go play with the other kids. Industry knows what they're doing. They're like, we always knew it. It really was, that was a major tipping point. And the Performer project, but the Performer project alone was not it, but that was about at the same time.
Thank you.
And then the rest is, oh, now they're using it, and waterfall effect, and thank you.
You're so right. And I just wanted to add something. Money, also from another perspective, that FFV1, I think got a lot of drive when it entered the film community with the promise of the reduction of storage costs. So I think money also played a part in that.
Thank you, everyone. Ashley, Jimmy, Marion, Steve, thanks so much for joining the discussion.
Thank you all.
Thank you. Please let us know where to find this book, because it's definitely a must-read. Coming up next, we have Crystal Sanchez with testing OpenAI's Whisper to make captions for audio recordings.
Crystal, can you test your audio?
Hi.
Hey, hi, Crystal.
Hi.
Hi. Share sound, optimize for video share. Hi, everybody.
Go ahead.
Oh, look.
Yeah, Crystal, the Zoom link's a bit stuttery. I'm going to close and reopen it, so just jump right back in.
Sure.
Actually, that's not going to help because somebody else.
Sounds about right.
No, I think let's start to proceed. I'm going to turn off the other camera for now. Yeah, you can just close it. All right,
What do you
Crystal,
think
start
about
whenever you like.
this?
It's a little stuttery. I don't know if it's on our side or your side, though. Okay.
Does that work? Can you see my note?
Oh, yeah, we do see your notes.
Oh, that's not good. Let me turn my video off. How do I stop sharing? Sick. Okay. Got it. Stop sharing, stop video. Okay, let's see if this works better.
Oh, we hear you good right now. Just waiting for your share.
Okay. Working on it.
No worries. Take your time. How are you?
I'm okay. How about
We see your desktop.
the wrong one? Yeah. Great. That works.
Right now I'm just seeing your Zoom icon. I think you're still hiding self-view. This looks great. Yay!
Okay, and you can hear me?
So far so good, go ahead.
Okay, I'll keep my video off, but hi everybody. Thanks for having me. I am here to talk to you about our project at the Smithsonian Institution, testing OpenAI's Whisper to make captions for audio recordings, and I'll give you a little background. I am Crystal. I work at the Smithsonian Institution. I am a white woman in a green shirt right now in my house, a mile from the Capitol in Washington, D.C. This is a picture from a Dr. Seuss book that is adorable. Next. Okay, yeah, that's me. I was hiking the Teton Crest Trail and then I broke my ankle, not hiking the trail, but at a music festival. So I'm very sorry not to be there. I had planned to come, so I appreciate remote participation in all forms. So thank you very much. I work on a digital asset management system where we have 35 million files to take care of, about 200,000 of which are AV files. So a smaller collection, still large, and part of my role is to advocate for and work to build tools to take care of these files and to make them accessible. So this is how this project started, as sometimes they do. My office mate, Mike Trisna, is a data scientist in our research computing lab. And he sits next to me, and in 2023, I was like, hey, remember when everyone was using ChatGPT all of a sudden? Maybe we could try out some of these tools to make captions for our audio files. And so we embarked on this project. I'm an AV archivist, he's a data scientist, so we kind of pooled our resources and really thought about a machine learning project and the fact that it is iterative and it involves all these steps. I really like this slide that highlights this sort of process that we went through. And this is not just my project, it is many, many people at the Smithsonian. This super group has been meeting monthly for a year to do this work on top of their jobs. So people from the Folklife Center and Archives of American Art and Smithsonian Libraries, in addition to our Transcription Center and our Access Smithsonian Office and digital platforms. So, of course, as a federal agency, we are mandated to apply with accessibility requirements. We had 17,000 public audio recordings at that time, and I asked for $1 million to make captions for them from vendors, which is what we were doing. And I got laughed at, but it really set the scope of this. Our goal was to see if we could make publishable captions for this pile of files that were already public. Of course, making captions and transcripts also makes them more findable. This is the curb effect. And it is a very good thing to do, and it is good to do it well. I learned a lot about inclusive design. Oops, I'm sorry. And of course, we don't just have published clean recordings. We have variable recordings that I'm sure a lot of you encounter from transfers, things that can have multiple speakers and multiple languages, and lots of noise, lots of variables that we wanted to test. So this is really where we put a lot of our effort and a lot of our advocacy, that this is we could test with a set of files that are clean and, I keep saying clean, but are published recordings, high production recordings, which we did, but we also really needed to test with other type of variables. Here's an example.
Talk the Quechua. Quechua is a native language from Peru.
Oh, you can speak Quechua.
I can speak Quechua.
Now, we have to hear you say something in Quechua here.
Sure. And I say, Imainaya Kachkanki. Repeat with me. Imainaya.
But wait, what are you?
So it's an example of different types of recordings, and we built a media player last year, which we called MADS. It's based on the open source Able player that comes out of Washington State University. I'm happy to talk to anybody about this if they want. But basically, we input VTT captions and audio descriptions to the player in this workflow that we can scale up inside the Smithsonian. So we're really looking for VTT files. Here is an example of that player in action. I didn't give you the sound, but you could go to Institutionally Dead website and listen to Jerry Garcia talking. This is an audio file with captions in the player with a timed transcript. So, of course, VTT is time to text with timestamps. So what Whisper does is it takes the audio and makes text and turns it into these VTT files that we can play along with the audio or video files. We looked at some tools, and of course we chose Whisper. It's the open source automated speech recognition tool. Released 5 sizes of model weights. This just means like different sizes mean different compute power requirements, different time, and different outputs. So we did choose the largest size because we were able to use our high performance cluster, usually available to scientists in our data center through the research computing lab, and we wanted to test the largest model weight. And of course, we came up with a set of metrics. If anybody wants this, it's a Word document for how to score the AI, score Whisper, both quantitative and qualitative tests that we did. Are the timestamps and spacing accurate? Does it stop in the middle of a sentence? Does it do speaker identification? Of course, are the words accurate? Does it output nonverbal captions like applause? We looked at these variables and noise, accents, crosstalk, multiple languages in a recording, and musical performances.
Mention those over 40. Why is that? Is it?
This is an example where in the very beginning we compared Whisper against our Smithsonian Transcription Center volunteers making captions and vendor output. And it's pretty illuminating to look at differences in style, not just words, of course, word accuracy rates, but in style. And so I just play a little bit of this for you. This is Smithsonian Archives recording about polio vaccine, which is also relevant.
Mention those over 40. Why is that? Is it? Are they less susceptible?
98% of paralysis occurs in people 40 and under years of age. And for public health reasons, one has to cut off. And the cutoff has been at 40.
So just to show you, there's lots of different ways to do this work. And inclusive design is also an important component. So some findings here. Our sample set was quite small, and we only, just because we're all stretched, but we had 80 recordings of high quality production level, and we did about 15 recordings of different variables. So we're still very much testing this out, but we saw some very consistent themes across them. Whisper performed very well in the speech to text being really accurate. Word accuracy rate is very high. especially with those standard production recordings, but also with speakers talking over each other with some minimal crosstalk. The presence of external noise, it performed very well, output accurately. Speakers with accents, it was able to also be quite accurate. And so we have a lot of high scientific terms in our educational recordings, and it got them really accurate most of the time. I had to look up a bunch of them and check spellings and things like that. So we were pretty impressed with that. The spacing and the amount of text on screen was really good. You could set in Whisper how many lines you wanted to output. So we stayed inside the 2 to 3 line standard, and it did not stop or break in between sentences, so kept full sentences on screen most of the time. And our world language recordings are sometimes called non-English recordings, are output in the language that's spoken without translating. Whisper does allow you to choose if you want to translate or not translate. I think it does 10 languages. So at this time we only tested Spanish, but so we need to expand that, but it output in the language spoken. This is the larger list of those for output. Did not perform optimally. There are no speaker tags. You saw in that example, speaker 1, speaker 2. We set the recordings through a separate tool for diarization afterwards, which we would have to do. Speaker tags are very important for us. It is difficult, of course, for the tool to output the actual speaker names, but we think that that could be useful for us to fix later if we had speaker 1 or 2. Identifying speaker.
Crystal, we missed maybe the last 10 seconds of what you were saying. Yeah, after talking about speaker tags. I wonder if she's still here. Hey, Crystal, we don't hear you at all right now.
Am I still here?
Oh yeah, we hear you now. I just got to get you up on camera, but you can start talking. I think you left off on some details about speaker tags.
Yeah, and I put the slides in the link too, and good thing I put all the text on the slides. Let me put the slide up again and see if I can keep going so if that happens again.
Okay, your slides are on screen again. Feel free to continue.
Yay. Okay, speaker tags, tricky. We had to set it through a separate tool to diarize the output and get speaker 1, speaker 2 tags, which we could add in actual names later, but it wasn't even very consistent. Musical recordings not identified with musical notes, and for some reason, lyrics don't have any punctuation very consistently. Content that switches from one language to another in the recording does translate, so it does not output in the language spoken. So if you started in one language, it would continue output in that language. Hallucinations, which is the thing people like to talk about, exist a lot, actually. A lot of repetitive text, often in quiet spaces. And then if you have a recording, which we have a lot of with empty space, no sound at the end, when you're transferring a whole recording, it makes things up. It likes to help, it wants to help fill in the empty sound spaces. But they do output as 0 timestamps in the VTT, so we think we could identify them really, really quickly in a kind of more efficient processing workflow. The external sounds, the recordings like crowd noises or applause, which should be in brackets, are not, and not often output. And then it removes disfluencies when I'm saying and ah a lot. It removes those, and we don't always want to do that for research purposes. So a lot of did not perform optimally conditions that we discovered. Of course, the Smithsonian and the community very clear about talking about a loop and a workflow that includes curation and approvals and review by humans, which is a lot of work. So trying to think of ways in which we can optimize and make that efficient. So we did learn after this process, these are not publishable results that are okay for our curators and our archivists. So we would need significant staff time to review and approve, and tools to do that, and they do not yet exist. We did look at some tools. The American Archive of Public Broadcasting has this tool called Fixit, and it's very cool. You should go look at it, but it's not going to work for us. It's built on Ruby, and it just wouldn't be sustainable for us. But we learned a lot about it. We have a transcription center that does sound with volunteers. It's called TC Sound. You can also go transcription center, some audio recordings. And but it uses volunteers to add timestamps and type in, and then do levels of review and approvals. It could be a really cool platform for us to use internally for our staff. We did build on the left side here, we built this kind of mock-up of what we'd like to see, where the error counts are, output from Whisper, so you could go to certain places and fix the text and output new VTTs. So some of the things that we've learned about where the errors might lie could help us build a tool. We're revising our goals. We could use the Whisper output to just make our content more searchable, even internally, instead of publishable captions. We have a lot of PDF transcripts that need to be turned into VTTs, and we could use this process of already approved PDF transcription content. And then we're digging into our the Whisper output's confidence ratings per word, and we're trying to test it to see if it's the confidence ratings are trustable. Can we trust them? To then use that to go find places in the recording to fix. This is an example. Whisper outputs a JSON and a VTT, which we turned into this CSV. And you can see this probability, D, the D column, I just faceted by anything under 50% confidence rating. The right side is hallucinations, you. It's 25% accuracy rating. So I think if we could build thresholds for what we could trust and then go to those places to fix things, that would really help us out, that we're thinking about doing. Oh, 2 minutes, okay. Communities that we're tapping into, I just built this slide, I need more on it. So if anybody knows of work being done, or anybody wants to share their work with us, that would be awesome. So I know some of these things happening. AMIA had some presentations. There's this AI and oral history symposium that happened. They had a roundtable on this, and the AI for LAM group. That is all I have. Thanks for having me. Did it work?
Yeah, we heard you pretty well, except for that one interruption. But yay, and you're back on camera, on screen.
We have time for maybe 1 or 2 quick questions, if anybody has them, or comments, feedback. Sorry, I didn't see you.
Hi, Crystal. I just wanted to share that I think it was 4 years ago, maybe, the EBU started up a benchmarking project that's open source for speech to text recognition. And they have some they have a GitHub, they have some published markers that they're, working with, and they differed a little bit from yours. And I'm not sure if it's been very active because it started, I think, 21 or 22. And then I just wanted to ask if you're aware of, are there any working arrangements with Whisper to give them new data sets of knowledge of languages that they don't have currently represented in their list of languages? Because I work for an organization, we have a lot of really high quality broadcast recordings, but there's basically no speech to text recognition for many of them, like Dari, Pashto, Uzbek, Kyrgyz, etc. So we have a lot of underrepresented languages, and we're interested in doing something with Whisper, but just don't know what the possibilities are. Thanks.
Yeah, that's great. The first comment was EBU group. Yeah. Is that right? Okay, I'll look that up. That's great. Thank you for that. And I don't know. I just read the Whisper news. I don't really have a relationship with them, but that's a really good comment about, I learned that I can't remember the 10 languages, but they've published them that they trained their recordings on. I forgot, but that's, as they grow, I think it's a 2022 they came out with this product, so it's still pretty new in terms of tech world. So as they grow, we'll keep an eye on that and see. That would be great for our community.
I'm tempted to allow for one more question, maybe.
Just a quick one. So Whisper is basically a Facebook product. It runs on your machine, but do you know if there's any telemetry that's sent to Facebook? And if so, what's the privacy cost of what you're injecting in Whisper?
That is a great question. We have some rules around what tech we can use at the Smithsonian, being quasi-government, and we have to use tools that are able to be run on-prem right now. So they say open source, but they haven't revealed their data sets entirely. So what does that mean? So Whisper is an open AI tool. They're not connected with Facebook directly that I know of. I'm sure they use Facebook data, right, in their data sets. But we are able to run it without sending our data to them. So you can actually build your own instance on-prem and run it without sharing your data. So that was why we also decided to use it. So that's what we did. There's the availability to not feed your data into the data set. Even though I also think there's a wonderful discussion here about cultural heritage models, fed models, where we could all put our data into a model and output a data set for cultural heritage communities.
Maybe a topic for next year's No Time to Wait conference. Thanks so much, Crystal. This was really fascinating.
Thank you all so much.
Oh, yes, yes. Up next, we have Reto Kromer with Deep Machine Learning applied to moving image restoration.
What did we decide? There you go.
So, good afternoon. Sadly, my colleague Michal Kochen could not present here in person, and she could not do the talk that was planned because of the availability of flights from and to Israel and currently rare situation and very high costs of them. Therefore, I will take up myself this burden, and I will give a similar talk of what I have given at the Siapaba conference 3 months ago in Solo in Indonesia. I will start with my personal journey from the mathematics and computer science to the restoration of moving images. Then I will try to explain that AI is neither artificial nor intelligent. On the contrary, I will show you that there is a big need to correctly train the machine in order to get out of it good results. And finally, I will spend some time on our findings. Let's start with how I went from the mathematics and computer science to moving image restoration. In summer 1975, that's almost half a century ago, as an adolescent I started programming in COBOL on the mainframe in my father's office. In spring 1979, a friend of mine started building a computer, and I programmed in assembly and later in C the software for it. And in October 1983, that's more than 40 years ago, as a student in mathematics at the EPFL, the Swiss Federal Institute of Technology in Lausanne, I started exploring machine learning. I coded in Prolog how a chessboard looks like, how the pieces move, and what was the goal of the game, but not how to play chess. And I started the program on a Friday afternoon, and on the following Monday morning, the program was able to open correctly and to do the 2 first moves in an intelligent way. This has been my first experience of machine learning using backtracking, and the result is called an expert system. 15 years later happened many events that have changed definitively my personal interest as well as my professional work. It opened for me totally new horizons to explore in order to improve the conservation and restoration of the audiovisual heritage. In 1998 was published Anil Kokaram's fundamental book on motion picture restoration that describes many digital algorithms for artifact suppression in degraded motion picture films and videos. The same years, I also had the chance to start working with Chris Kodosiewski in the Digital Film Lab in Copenhagen. In 2001 was released Diamant, the first piece of software for moving image restoration, and the same year also took place the Preserved and Show conference, again in Copenhagen, where I could meet many people that were fundamental for my future professional evolution. In 2004, that's 20 years ago, I founded my own company after having been head of preservation at the Cinémathèque Suisse, the Swiss National Film Archive, in charge of cataloging, conservation and restoration of the film collections. From the beginning, we worked both photochemically and digitally, trying to benefit from the good sides of both worlds and trying to avoid the bad sides of both worlds. 10 years later, we organized our 5th and last one-week school, which was devoted to additive color systems and working beyond the classic RGB color space. And finally, since 7 years, we are using deep machine learning for digital restoration of moving images. This working method has not replaced the other ones, but has complemented them. We publicly presented many times our results, both successes and failures, last time in March during 2 of our free and public reports of the field sessions, and in June at the I will now give you a short introduction on some of the basics of what is reunited under the umbrella of AI. Artificial intelligence was founded as an academic discipline in 1956, and since then, that's almost since 70 years, the field went through multiple cycles of great optimism and deep pessimism. The term intelligence is difficult to define, and what should be an artificial intelligence is even more complicated. I let others with that. In my personal opinion, the term is inappropriate because it's neither intelligent nor artificial. But here are a few considerations about the requirements. The ability to learn is a key requirement for an AI system, and this must be planned and integrated from the beginning on, because it cannot be implemented later on in an efficient way. A second main criterion is the ability of an AI system to deal with uncertainties and probabilities, including probabilistic information. Last but not least, we as humans must always keep control over the machine. In the slide background, you see the two layers of a fully connected neutral network and its expression as a Tensor-Kronecker product. In some situations, working with multispectral moving images has not only the advantage to give us a better representation of the source material that survived, but also to allow us to apply new restoration techniques. We work usually with 15 bands. That means that the scanner generates 5 times the data volume of a regular RGB imaging, and we had to find ways to process such a big volume of data. However, this was not my unique inspiration. The idea to find new ways to process digital restoration more efficiently came many years ago while listening to a presentation at the RealSync conference, technical conference in Hollywood. A person presented a restoration and explained that because the founding was limited, they restored better the parts of the image where the spectator is focusing on. That's, of course, a very fascist idea. Why the hell should I, as a restorer, decide where the spectator has to look at? But the idea to work only on some parts of the image was intriguing indeed. We tested supervised, semi-supervised and unsupervised deep learning techniques. We ended up by using only supervised training of artificial neural networks, or more generally a deep machine learning method. This opened totally new horizons of film and video restoration. In practice, we choose the most damaged part of the most damaged color band, and then we restore them manually, usually using the proprietary software Diamant. The data truth generated is processed by the AI system, which orders it in multidimensional arrays. These are the training data for a specific project, and the new data enrich the existing ones of the AI system. These structured data are then processed by mathematical formulae, and we do this in a supervised mode in order to detect as early as possible the errors. The calculation requires an enormous computing power that today, de facto, can only be provided by graphic cards. Then we tell the computer to apply the same rules in Diamant, firstly to the whole band, and secondly to all the other bands. We always check the result. If we are not happy with the solution provided by the machine, then we force the machine to follow our will. This way, project after project, the system becomes more and more reliable. As said, I have used Diamant since a beta was released, and from the beginning, this proprietary software has offered the ability to write your own plugins and to extend its built-in capabilities. And of course, I used this possibility. For example, back in 2001, Diamant could only process black and white images. And I programmed a plugin for the 3 color channel management representing both the additive RGB color model and the so-called subtractive cyan magenta yellow. Diamant supports OpenFX, an open standard for creating visual effect plugins, which is widely used. Therefore, integrating custom software is a quite simple task. In the slide background is the structure of an artificial neuron with its components from the left to the right: input, weight, transfer function, request, activation and threshold, and activation. I will conclude my today's presentation with a few positive and negative experiences we made in the field of machine learning, specifically applied to restoration of moving images. We could never have realized some of our projects without an intensive use of these new tools. If the technology is used intelligently, then the machine is really at the service of the humans and not the contrary. We as humans can focus on the parts that are intellectually more challenging and therefore more interesting, and let the machine do the boring stuff. I wish to be absolutely clear with you. This is expensive. There are not open source tools available yet which allow to work efficiently in moving image restoration using machine learning and database decision making. We tried TensorFlow and Torch, but ended up working with the property Wolfram Mathematik in the beginning and designing and training our own system later on. We still work with OpenMP, Open Multiprocessing, for the parallelization. I was lucky enough to be able to hire a woman who is not only a proven programmer, but has also a good knowledge of both historic and contemporary film and television technology. A blessing. And this woman is Michal Cohen, who could sadly not travel to Karlsruhe for this No Time to Wait conference. Do not forget that many of our projects could progress from a dream to the reality only through mastering this technology. It was certainly a lot of work, pain and sometimes frustration, but it was also a very exciting adventure. And indeed, we will continue this path, that's for sure. And this concludes my today's presentation. As usual, the slides are available on our website. And thank you very much for your attention, and back to you, Caroline.
Thanks so much, Reto. We have a scheduled break, but I think we can allow ourselves quick questions if they arise, if anybody has any burning.
Otherwise, you can ask me outside.
Or we can take it to the coffee break room and talk over coffee. There is one, yes.
Thank you for your interesting talk. I just wanted to, I didn't understand whether you made the software from scratch or whether you used an existing software that you trained differently.
We worked with Diamant as the main software.
Is that
a proprietary software that you can buy.
Okay.
But this software has an interface, and with this interface we could add our artificial intelligence.
Okay, yeah,
And
thank you.
this artificial intelligence at the beginning was made with Wolfram Mathematik, that's a proprietary software, but later on we started building our own and programming our own to have the full control. We tried to do that dimension, especially Torch. We worked a lot with Torch, but it couldn't not do exactly what we wish at the moment. But I think it's just a matter of 1 or 2 years, and then we will switch to probably Torch, which is open source.
no more. Sorry, can we, unfortunately, we have to end it here. I'm so sorry. Maybe we can continue the conversation over the coffee, and then we'll return. Let's say 16 hours, 40 minutes. Thank you. Hello, welcome back. Thank you for coming back and your patience. We had a little change in the program. So unfortunately, the first presentation of this block will not happen. So we'll move on to Jacobo Castellanos and Yvonne Ng, presenting on protecting the real and identifying the fake, a human rights-centered approach to generative AI. Welcome, Yvonne. Welcome, Jacobo.
Thank you so much, Caroline. Is Jacobo up on this computer right now? Okay. Will I be able to? Oh, I see. Okay. Okay, just a second. So yeah, thank you so much, everyone, for sticking around for the last session. Thank you so much to the organizers of No Time to Wait for another fabulous year. I think this is my 7th No Time to Wait so far, and this is like definitely one of my favorite conferences I go to every year. So for those of you who don't know me, my name is Yvonne Ng. I'm the Senior Program Manager of an organization called Witness. Witness is a global nonprofit human rights organization, and our mission is to help people use video to protect and defend human rights. And so my role at Witness is I oversee the archives program, where I support our partners on aspects of projects that include like collecting and preserving and managing their video collections, and I create learning resources. But another key part of our work that my colleague Jacobo works on is centered around deepfakes, synthetic media, and generative AI. And Jacobo will have links at the end of his presentation, but if you're interested in checking out some of our work in this area, we have a microsite. It's gen-ai.witness.org. We actually just released a new research report last week on audiovisual generative AI and conflict resolution trends, threats, and mitigation strategies. It's a report on how synthetic media is being used in situations of armed conflict and situations of widespread violence, and the implications of synthetic media for conflict resolution and peace processes. So what's going to happen in this session is I'm going to introduce my colleague Jacobo, who is joining us all the way from Mexico. It's very early in the morning for him, so I'm really grateful to him for joining us. And he actually has a presentation right after this as well, so really grateful for his time. So he's going to be telling us more about our work around generative AI, emerging approaches to, as Caroline said, protecting the real and identifying fakes. And then after his presentation, we're going to bring it back into the room, try to bring it back to, this community here whose concern is about digital preservation, and, hopefully just have a bit of a conversation about what your interests and concerns are around generative AI. So without any further ado, let me introduce Jacobo. So Jacobo Castellanos is our coordinator of our Technology Threats and Opportunities program at Witness. He leads our consultative work with communities globally to explore the threats and opportunities that deepfakes, generative AI, and synthetic media bring to the work of audiovisual witnessing. He co-chairs the Threats and Harms Task Force of the C2PA, which is the Coalition for Content Provenance and Authenticity, which is a coalition that's building standards for verifying the source and origin of digital media. And so I'm going to turn it to Jacobo. I don't know, has he been able to hear us this whole time? Oh, and then. Okay, so now he can. Okay, so now he can hear us. Jacobo, sorry, I just introduced you. I don't know if you heard any of that introduction, but we're ready for you to go on. Hi.
Hi, I'm not here, so I don't know.
You missed the whole preamble, but we're ready. We're ready to hear your presentation.
Okay. Hi, everyone. It's actually good to see you. Usually when it's online, I don't get to see the folks in the room, so it's good to see you. Thank you, Ron, for the introduction. I'll just say again, my name is Jacobo. I presume I don't have to introduce Witness anymore, because I think you might have done that. So I'll jump straight to my slides. So the presentation, the name of the presentation that we had for you is called Protecting the Real and Identifying the Fake, a human rights-centered approach to generative AI. And so what I will say very quickly is that I'm part of a program within Witness that's called Technology Threats and Opportunities. And for the past 6 years, we've been working on synthetic media. We look at emerging technologies and how these emerging technologies are digital technologies affect human rights. And so 6 years ago, 7, that has evolved. We now focus on synthetic media, and I'm going to run a little bit through these slides because I do want to focus on the last ones. But I'll say very quickly that when we talk about synthetic media, we're referring to generative AI technologies that are focused on audiovisual creation. So images, video, and audio, and any combination of those three. Again, so the scope of possibilities and sophistication of these technologies are very broad. From technologies that are super simple, where you just upload a picture, like the one on your left, I believe, this one right here, where you just upload a picture and it makes it move within an application. But you can go all the way to the other side of the spectrum, where you combine with VFX, for example, with an actor, and you can use synthetic media to create extremely realistic, sophisticated content. I won't put those examples again because I do want to focus on the last slides, and I presume a lot of you already know a lot of this information. In terms of what's possible, I've put some examples here. We can remove objects and subjects. This we can do with our phone already, but in video we can do it through applications like Runway. It may not be too clear in this video, but there's a soldier that is being removed just by highlighting that soldier. We can add context in images throughout painting, for example. This is through a tool called DALL-E from OpenAI that is no longer available. But before, you could add context around an image that was real. You could just put a prompt and add context around it. We can edit features. This is from Adobe Photoshop and is fairly old. This is from 2021, where we can change the size of the eyes, the age of the person, the hair, again, just with a couple of clicks with your cursor. We can do content animation. Again, these are fairly older examples, just to show, again, how long this has been with us and the evolution. I'll get to the evolution of this in the next couple of slides. But here, what's happening is that we have a source video on the top left, a person that's moving. The tool captures this movement, and then you can superpose different persons, different things that you want over that pose that is being detected. We can style live feed in near real time. And this is actually interesting because real time styling is not yet that easy or possible. Here we're using a tool called Laura, and we have a former colleague of ours, Raquel, who is in the top left corner of that video. And in almost real time, she is changing or styling her video. This is interesting as we combine it with different technologies like 5G, the styling in near time, or making deep fakes in real time may be more and more possible or easier to do. And we can essentially just generate anything, right? Here I put just an example of creating maps and satellite images of a city that does not exist, but we can also create fake people, fake animals, fake rooms. We can do an endless amount of things with synthetic media tools. But beyond what we can do, as I mentioned, I'm not going to cover the scope of the possibilities. I do want to highlight the evolution, the speed of these, of how these technologies evolved. And here I have an example from Midjourney. This is one of the more popular image generators that we have. This is it's a paid tool in this case, and what we're seeing here is the evolution from March 2022 to February 2024. So that is in less than 2 years. 6 versions of Midjourney came out. Here we can imagine the prompt being something along the lines of a small girl smelling a flower, right? And we can see the first version, the image, the quality, the idea is not that clear. And then again, it it just evolved real quick. And a year, 11 months later, we got this image right here, which is extremely good in quality, very sophisticated, very clear, very relevant to the prompt that is being proposed. And the same applies to video, for example, and audio. Here we have an example of a video. The one on the left, I will put play here, is from a tool called Fenaki from Google. And they put this prompt right here. And let me play this for you real quick.
Here's one where the side view of an astronaut who is walking through a puddle on Mars. The astronaut is dancing on Mars. The astronaut walks his dog on Mars. The astronaut and his dog watch fireworks. So all of that happens here in a way that...
There you go. So, you know, the prompt reflects what we see in the video, but it's always very weird. It feels like, you know, it's very clear that it's obviously not captured original, that it's not an original footage or not synthetic footage. But, you know, the sense of it is already captured in this video. But then just 2 years later with Sora, and this is from OpenAI, Sora is a video generator that is not yet publicly available. They put this prompt right here, and this is a GIF, so you can already see how it looks. It looks extremely realistic. And here, what's worth highlighting is not just that the quality improved in 2 years significantly, but also the outputs could be longer. You could create videos that are up to a minute long. Before you could make videos of 3-4 seconds. And also the context window refers to what information you provide the tool to use as a reference to create the output, has also increased significantly. So the possibilities are broader and broader. And with audio, I'll just say something real quick about audio. Audio, we are at a point where we really cannot detect what is real and what is not even with computational technology. So, you know, it's just interesting that we may be crossing that threshold where synthetic and organic may be completely blurred, unless, you know, we come up with non-perceptual mechanisms to understand the content that we're consuming. In terms of the trends in the development of audiovisual, generative AI, synthetic media technologies, there's a couple of elements that we've highlighted because of how they shape the ecosystem, and also because they help prepare and they help us understand what's happening, but also how we can prepare to mitigate harm, but also to leverage these for different purposes. In our case, we're thinking about human rights protection, of course. So a couple of elements that I'll highlight: commercialization, commoditization, that one's hard for me to pronounce, and accessibility. So, you know, the fact that it's so, this combines with the second point, ease of use. The fact that these tools are so easy to use. In many cases, you just have a bar, like in Google search, and so you go through, you have web access in many cases, and so it is very, very simple to use. That has implications on how the technology is used and how it is diffused as well. The speed of creation is very important. You can create in very short amount of time a lot of content, which leads to the point number 4 on volume and variation. And the 4 combined, I think, and actually with the 5th one as well, multimodality, I think all of these elements combine to create one characteristic that I think is particularly interesting and relevant, is that we can create synthetic histories and synthetic realities. This is a concept that is being used more and more now, I think. The idea that we could almost rewrite history, so to speak, rewrite the past and rewrite the present as well, because we can create so much content. We can create videos and audios and text and images and combine all of those to create something that a synthetic reality, which I think is one of the things that worries me, but it's also extremely interesting to consider. Openness is one factor that we consider a lot. You know, I've worked before in the open source movement, and the idea of free culture. In AI, it has certain implications that, you know, leaves me wondering to what extent or how we manage openness in AI. I'm not going to get too deep into that. I'm just mentioning a couple of elements that may be relevant. Live interaction and personalization, this is happening more and more, as you saw with the example of my colleague, and that near real-time stylization of the video. So we can imagine, again, as we think of, for example, internet and broader bandwidth, we can have video conferences where a deepfake is happening in real time, and not just in audio, but also in what we're seeing. and agentic AI. This is one of the big buzzwords right now, I think, in Silicon Valley, the idea that generative AI can do much more than just an output that we ask it to do based on a prompt, that it can do a whole task based on an idea that we give, right? So it's not just making one task, it's making a combination of tasks to carry out like a project. This, as far as I know, is not something that we're close to yet, but it's something that is definitely being considered and already commercialized, at least as an idea. And it's part of this hype that is also around these technologies. All right, so the reason why we're interested in this, so synthetic media affects the landscape in which we operate for many reasons. Sexual and gender-based violence has been the most clear way in which these technologies affect and create harm. But I want to focus on these two areas right now, on disinformation and erosion of trust, because I think that we could combine them, and it also reflects an area that we have been working a lot on at Witness in general. They fortify the truth. So I think Yvonne at the start of this presentation talked a little bit about how Witness and what we do. Of the sense that we need to fortify the truth, because in rights violation.
Jacobo,
we want a
you dropped out right after.
video.
Can you hear me? You're frozen. Okay, 1 second. Hi, Jacobo, are you there? Yeah, we lost you right after you started. You had talked. You said you introduced the disinformation and erosion of trust, and you were starting to talk about fortifying the truth and like that. Yeah.
Okay. Yeah. So we're thinking about, for example, if a video that is captured proving a human rights violation, we want that video or that image to be useful either for legal processes or for social. The court of public opinion, so to speak, and so we need to be able to determine that this is true, right? And so in the context of disinformation, in the broader context of disinformation, this was already complicated. Now with synthetic media and generative AI in the mix, it gets a little bit more complicated. And so in terms of what's happening with disinformation, I'll just share a couple of brief examples about what it's being used or in what ways it is being used to spread this information. Over the past year at Witness, we've focused in elections. We've used the example of elections to understand how synthetic media is being used for this information. And here I'm just pointing out to 4 very specific general categories about how it's being used. So it's being used to deceive, right? The top, that example we have, it's one from the Taiwan election, where the presidential candidate was an audio deepfake, synthetic audio was created of him supporting the opposition candidates, right? To give the sense that he was actually supporting them and have his supporters support the other candidate. It's being used for impersonation. This example that we see here is from Venezuela. They used a tool called Synthesia to create avatars of journalists that don't exist. And so in this case, it was a US journalist, a supposedly US journalist, talking about the good things that are happening in Venezuela. And so what the local news outlet in Venezuela did said, they put this video and said, hey, look what people in the US are saying about us, right? To give a sense that things are going well in Venezuela. And it's just an avatar, it's an AI avatar. The news does not exist. This person does not exist. To shape narratives and to shape frames, we saw a lot of this to create, this connects to what I said before about synthetic realities. In a way, here in the context of the US elections, we saw a lot of synthetic media being used to push further the narrative that Joe Biden was too old to be running for president. And again, as I mentioned before, gendered disinformation and sexual gender-based violence, it's been by far the biggest harm. Witness organizes consultations in different parts of the globe, and always sexual and gender-based violence comes at the top of the ways that this is being harmful. But to connect it to disinformation, the example that we have here, right here, is of Pakistani and Bangladeshi politicians. They edited the pictures with synthetic media to make them be wearing swimming suits, because in their context, that was considered to make them look bad and could affect the way that voters perceive them, and so to not vote against them, right? So here I'm covering just disinformation, but the other aspect of this is erosion of trust, and it connects to the fortifying the truth. We're also at a point where this idea that we're past post-truth because synthetic media is so good is being spread more and more, and there's a lot of hyperbolic discourse about what synthetic media can do and what it's actually doing. In the context of elections, for example, there were many people that were talking about generative AI being the basis to destroy democracy because people would no longer know what is true. And so there's a lot of hyperbolic discourse. Some of it reflects actual what's actually possible. A lot of it is just hype. But yeah, what has been happening is that we have this discourse that we can no longer believe our eyes and ears, right? And so what this means is that not only is trust eroded, no longer do we not know what's true or not, but it also gives actors plausible believability and deniability. The idea that you can claim that something is true when it's actually false, or that something is false is true. And we've seen examples of this. Here I put one example that we worked on directly of a politician in India that was caught on audio saying things that did not help his candidacy. And he came out and said, hey, this is completely fake. You don't believe this audio. You know, look what they did with Drake. There was a deep fake of the singer Drake at the time. And then Witness was part of a process there that analyzed with computational tools the audio. And what we concluded was that this audio was most probably real, right? And so this is just one example of how trust is eroded, and why at Witness we have this framework of, okay, well, how do we fortify the truth in this context? And so when we think about how we fortify the truth, at the moment we have 4 major areas of work in terms of socio-technical solutions. These are content credentials, watermarking, fingerprinting, and detection. Before I get to those, the analogy that we have is that we think that if the way that we consume digital content online is similar to eating food where we have access to the recipe, what ingredients were used, how it was made, where it was made, then we would be able to consume content online in a way that gives us more certainty about what we can or cannot believe. And then I put a little asterisk there with the UX, because obviously UX is a huge important factor in this, in the sense that we know from previous examples in Europe, for example, the GDPR was a great example of how, you know, giving users more information is not necessarily the solution. But what we have been working on is the sense that we need to capture this information anyway, and then have ways by which we could share in different levels of interaction the information that users need, right? And so the first one I'll mention real quick is content credentials. Content credentials is the commercial name for the standardized way of capturing verifiable metadata. So I know that in your archival work, I presume you work a lot with metadata. You may know that this metadata is not always verifiable. It doesn't always give you a lot of certainty because you can change it, you can edit it, you can delete it. So what these content credentials do is create a mechanism to capture this in a way that if you change it, there's a trace of the change you make. And so that way you could have, in theory, if this is captured well, you could have information, metadata that goes across the workflow of an image, video, audio file that you're seeing, right? It will tell you, hey, you created this image with OpenAI, or you took this picture with this camera, and then it was edited in Adobe Suite, and then it was published on this site. And so the user, in theory, would have access to that metadata to be able to determine whether or not this is something that they can believe in or not. I'll talk a little bit more about this in the next slides. Watermarking, by watermarking, we mean visible watermarking or invisible watermarking. So visible watermarking is anything that you see here, like in this slide, I put generated with ChatGPT. That is a visible watermark. Lots of questions around it, especially how reliable or resilient it is. Invisible watermarking is when you add, when you embed to the image certain aspects that can help you later through a tool, pick out that watermark, invisible watermark, and tell you, hey, this came from this tool, or this came from this source, right? Fingerprinting, again, just you have perceptual and cryptographic fingerprinting, where one, let's say, if we use perceptual fingerprinting as an example, we have an image, you do a perceptual analysis of that image, and that gives you a code, a hash, and that hash is stored so that if anything changes to this image, then that hash is not going to connect with the code that you created previously. It's going to break. It's going to tell you, hey, something changed here. And detection. Detection, we mean two things with detection. Post hoc detection, in the sense that there are tools, very general tools, that can help you look at a content and help you identify if this content is synthetic or not. And then there's also detection that comes from classifiers. So when a tool embeds a watermark, you need a detection tool to help you identify a watermark. These are just 4 areas that we have been looking into, and I'll talk briefly in the next slides about content credentials and detection, just to talk about what they offer, but also their limitations. But I do also want to just highlight here and do a small parenthesis and say that these are technical solutions that need to be part of broader social technical responses that look at media literacy, for example. We need to understand, if these tools are used, then how this is going to be part of media literacy programs. We need to think about how this is embedded into legislation, into standards, and we need to determine who has what responsibility, right? A lot of these tools only work if there's a pipeline responsibility. By pipeline responsibility, we mean that the different actors across the workflow have a responsibility that needs to be carried out for the next step in the workflow to be able to do their part. Being mindful not to put too much responsibility over the end user, right? We need to know what responsibility do large language model developers have, what responsibility do tool developers have, what responsibility do news media and social media platforms have, for example. So with that said, I'll say a couple more things about content credentials. This is one area that I work in the most. So as I was saying, this is coming out of a standard that is being developed by an organization, a coalition called Coalition for Content Provenance and Authenticity, the C2PA. And so the way that it works is that this metadata that is captured is cryptographically hashed to the image, video, audio file, and that is cryptographically hashed as well to a signer. So it needs to have someone that vouches for that information. In the latest version of the specifications of the standard, the signer can only operate at a hardware or software firmware level. It cannot be just one person, which means that a lot of the responsibility about what's signed there is going to rely on developers of tools, of hardware, of cameras, for example, which to a certain degree offers some possibilities in terms of certainty, right? But it also means that not everyone may have access to this. If you're a smaller tool developer, you may not as easily have access to these content credentials. Just for you to get a sense of what's already happening in this space, you can already, if you make an image with OpenAI, that image is already, or whatever content you make, it's already going to have a content credential that you can analyze through a tool that gives you analysis of that metadata. The same is happening with Adobe. Adobe is already doing this. This is a Leica camera that also already allows you to capture this information. And there are some social media tools that are already allowing you to present these verifiable credentials. In LinkedIn, you may have seen this icon at the top left. It's a CR. That means that it has verifiable metadata, but it's been gaining a lot of traction. A lot of social media, all of the major big tech companies are now part of the steering committee, and they're incorporating it. And we believe that it may offer some solutions in terms of fortifying the truth, because it gives you this verifiable metadata, but it also comes with a lot of cons, right? And so I'm hoping I can share these slides with you later, but I'm not going to go over them. But there's two main areas that we're concerned about. One is privacy, one is accessibility. In terms of accessibility, as I said, because the signing of the content happens at a hardware level, that means that we need to make sure that everyone that needs to be able to create these verifiable metadata needs to be able to access these content credentials, and they need to be able to be part of this trust list, which is not necessarily going to be an easy process. And then there's also issues around privacy, right? We want to capture enough metadata so that people can believe in the content that they're seeing, but not so much that their privacy may be compromised, because the information that is captured could put them in danger. And so we also have to think about how a user can retain control of their information. In terms of detection, and I'm going to finish with this, I hope I'm still on time. Detection is a great way to identify if content is organic or not. The issue with detection tools, and I mean generic detection tools that don't look at watermark but just analyze any image or video or audio, is that there's a lot of technical limitations. And I put this image of a cat and mouse because it's kind of a cat and mouse game. The detection tools improve, but the image generators, the video generators also improve. And then the detectors improve, and then the generators improve. And so it's always kind of like a catch game where the detection tools are not ever going to fully catch the generators, but they might give you a sense of if you use several tools and if you combine it with other tools, they might give you a sense of its origin. And here on the video, we downloaded it from YouTube and we ran it through this tool. The tool said, hey, this is a deep fake. So that's great. It worked. But then, however, we just compressed the video. We just literally compressed it and then ran it again through the software, and it told us, no, hey, this is a real video, right? And so it just gives you a sense of why these tools fail. A lot of the times these tools are designed to work in best case scenarios, but not in real scenarios that may be relevant for journalists, for example. For many other workflows, it's often that we don't have the best video, the best image, or the original one. So we have to work with whatever we have. And the example on the bottom, it's the same. So the original image is the one that you see on the first image. It's just the one on the bottom right. And then we added context throughout painting. Just put add smoke for a detector. The detector said, hey, this is real. It couldn't identify that what was real. The only part of that image that was real was the bottom right. Everything else was fake. And so these tools fail. But even if fail, there's another, and so at Witness we talk a lot about detection equity. What we mean is that these detection tools need to be available for those that need them most. We're not so worried if the New York Times doesn't have access to them, because they'll find ways, they have the resources, but it's not the same for local journalists in a smaller country. And so Witness has this program that's called the Deepfake Rapid Response Force. And what we do is that on the one hand, this is led by my colleague Shireen. She's gathered computational experts and forensic experts. And then on the other hand, we've made some partnerships with local journalists. And so the way that this task force works is that we receive content from local journalists who tell us, hey, we don't know if this is real or not. we running it through these publicly accessible tools is not enough. We need to have a deeper computational analysis. So they send it to us, we work with the media forensics, and we offer an analysis based on the detection tools. And we say, hey, this may be real, this may be synthetic, this may be partly synthetic, partly real. And this has been a pilot project. It's no longer a pilot project that we run, but essentially what's behind this is the idea that we need to make detection more accessible to those that need it the most. And so with that said, I want to finish with this last sentence. I feel like this last slide, I'll try to summarize. So synthetic media is changing the information ecosystem. We no longer know with a lot of ease what's real and what's not. And we have these technical solutions. None of these technical solutions are silver bullets. And so as of now, the approach that we've had is, okay, maybe each one of those will not be the silver bullet, but in combination, they can give us a clearer sense of what's happening in the content that we're seeing and in the information ecosystem more broadly. And so we have a toolbox approach. Let's think about how we include content credentials in our work or the role that they have. Let's consider watermarking. Let's consider fingerprinting. Let's work on detection. And with that, I finish. Thank you very much. I've left here a couple of resources and further reading that I hope to share with you later.
Thank you so much, Kobo. Yeah, so amazing presentation, a little bit scary. So we have some time for some questions and comments, but so we will have time to sort of talk about maybe have your comments about how this might be relevant to sort of this digital preservation community. But while we have Jacobo, I would just want to start to open up for any questions specifically for Jacobo about his presentation or about the work that he's doing. So we'll do that first. Are there any questions? And maybe, Jacobo, if you want to stop sharing your screen and we'll pin your picture. There you go.
Thank you so much, Jacobo. This was really excellent. I was curious to C2PA. Do you know if there's also use cases considered with archival collections? For instance, are there digital asset management vendors also part of this consortium? Thank you.
You're muted.
Yeah, thanks. So we have another colleague at Witness who works with Yvonne in archiving, whom I've had a couple of conversations about the potential of C2PA for archiving. And so she's worked a lot with Tainaka, and Yvonne, interrupt me here if not making sense. But we've talked about, okay, well, how easy is it to incorporate C2PA into Tainakan, for example, which is a content management system, I think is the way to describe it. As of now, there are no active, I'm sorry, the Society Library from the New York, I think, is part of this, but I don't think anybody has implemented for archiving purposes specifically. I think the use case is very clear, especially when we connect to this notion of synthetic realities and synthetic histories. I think it would be very valuable, but I don't know of any implementation as of yet. I'd be interested to explore that.
Yeah, thanks, Jan. Any other questions for Jacobo?
Yeah, really great presentation. Could you just talk a bit more about the media literacy part and how these tools fit into a larger social understanding of people's just general desire for some sense of truth?
Yeah. Okay, so there's the media literacy, the traditional media literacy, in the sense that, look at the source, find alternative sources. That level of media literacy, I think, has a huge role in tackling disinformation from synthetic media and erosion of trust. I think even in the future, as these technologies continue to evolve, there will be many cases in which just looking at alternative sources will be enough to identify if some content is synthetic or not. So I think we should never push that aside. It should be an essential part of it. media literacy in the sense that we could identify content with our eyes and ears. That is definitely something that we've been pushing back against. You know, before they used to point at the hands, the generators would make 6-7 fingers, and they tell you, hey, look, if you want to know what's synthetic, look at the hands. That lasted for like 2 months, and then they made perfect hands. And so that's not a good idea. And then the third aspect of media literacy is how we include these technical responses that I talked about into media literacy. And it's actually very complicated, and it's very nascent. How do we incorporate content credentials, C2PA, into media literacy? You know, the tool is still being developed, and so UX is constantly part of those conversations. But I think we're just at an exploration stage. At the same time, that synthetic media is already being more and more pervasive. So it's you know, we're trying to come up with a solution at the same time that the issue is already out there, but it still should be part of media literacy. I hope that responded a little bit.
And we have another question, David.
Yeah, I was asking myself, I guess these generated images still are sourced from the internet, where the artificial intelligence kind of uses as a base for their knowledge. Wouldn't it be possible to, on the other hand, create an AI which then traces the sources, the images back to the original images where parts were taken to combine the fake image? Or am I being too naive?
Did you get that, Jacobo?
I did not capture that.
Yeah, I think the question was like, if is there a way to trace, like the source of these images are, you know, coming from like the internet and stuff. That's what the models are being trained on. Is there a way to train a AI model to figure out where and how an image was constructed? Is that the question? Like where like all the pieces that went into making an image? I think that was the question. Like a reverse, like reverse image search for deepfake or something.
I don't know if that goes into explainability and the black box that AI models are. If that worked, then we would have a response to that, but I know that that's not currently possible. There's a lot of push to try to have some explainability behind these tools, but we're not there. I know that we're not there.
Yeah, I mean, I don't understand how these models work exactly, like these diffusion models that are used to create these realistic images, but like the way that they're generated, I don't know if there's a way to go backwards. Is my understanding.
Yeah. There's an interesting example that I came across not too long ago about the fact that we cannot explain it gives us some limitations about where it's used. So I came across an example of this being used in healthcare. This is beyond my area of expertise, but doctors were not inclined to use it because there was no explainability. And so, you know, if we had some explainability, I think that the use cases would be a little bit more safeguarded, but we're not there. Yeah.
Yeah. Any other questions for Jacobo? Peter?
Might this spark a black market for non-fingerprint material and like LLMs that have been trained without watermarks?
Could you repeat that question?
Does this create a black market for LMs that will create deepfakes that are not watermarked? Yeah.
Yeah, and this is the issue with open source AI. You know, and this is the big debate that's happening. You know, and so OpenAI, the company, will tell you, hey, we're keeping it close because we're protecting from misuse and abuse. And then others will tell you, no, but we need open source AI because it's more accessible, more people control. But the fact is that I think it's a little bit more complicated than that. I think you could have democratic control of a tool that is not necessarily openly available. But the fact is that, for example, if sexual gender-based violence is the biggest harm coming from these tools, with open source AI, we have more control over that. All of the tools that I mentioned, content, credentials, fingerprinting, watermarking, will not work with open source AI. And so, I'm not, this is not to say that open source AI is not good, but it's just a reality. Like the tools that we're thinking about right now won't work with open source AI.
Yeah. Any other questions for Jacobo? Okay, so Jacobo, one more? One more.
A social one, actually. If this is a race that we can't really win, technically, wouldn't it actually be an incentive for humankind to maybe just be nicer to each other? It may be like it's not as stupid, because if we really completely lose control over things, we might have another incentive.
Did you get that, Jacobo?
So if we can't solve it technically, what if we solve it socially?
That would be amazing. I mean, that's from the optimist side. I tend to fall on the more pessimist side. I was like, no, we need proper laws and regulation, and social media platforms need to be held accountable. But if socially we can do something about it, then that's great.
Yeah, let's hope. Okay, so Jacobo, I know you have another presentation to do, and I don't know how much time we have left just for our discussion about how this impacts this community, but you don't need to stick around for that. You're welcome to, of course, but I know you have to prepare for your next thing. So we can let you go and we can give you a little round of applause and thank you.
Thank you, everyone. I hope I see you guys after. Thank you. Have a good day. Bye-bye.
Bye-bye. Okay, so I hope that was interesting and informative for you. I know we're kind of talking from like the human rights perspective a little bit, so it's a little bit outside of context of here. And that, we're very much focused on the threats and harms that this kind of technology represents, but, there is also like a lot of creative, productive potential for this kind of stuff as well when we're thinking about it in terms of its use, let's say in media art or like in the digital preservation realm. So how much time do we have?
Maybe 10 more.
10 minutes? Okay. So, I mean, maybe first just to start this conversation, just maybe a show of hands, a little poll. So I'm curious, people in the room, whether you see generative AI as an immediate interest or concern or relevance to your work, or whether it's something more distant. So those who see it as immediately relevant concern that they're thinking about now. Okay, some, but not the majority. And what about more distant? Not something you're... Okay, so the people who didn't put up your hands, what are you thinking? Okay, so we're kind of evenly divided between like very, very immediately concerned and maybe more distant. Actually, one reflection I had just on the idea that it being more distant, for me, it was actually very interesting over the past 2 days to hear presentations from some of the museums, like ZKM, talking about how they're approaching like regenerative curation and like restaging of media artworks, and seeing a lot of parallels with generative AI in terms of how the museum is trying to create this front-facing experience that reproduces the real work while relying on the behind the scenes on more modern technologies. And also sort of seeing parallels in the discussions we were having yesterday about early internet art and representing that to audiences, and how we do the documentation around that, how we make that process transparent to like the museum goer, and how that is kind of parallel to like the kind of the disclosure and transparency mechanisms that Jacobo was talking about in terms of like the fingerprinting and the watermarking and all of that kind of thing. But anyway, so for those of you who kind of see this as like a very pressing, immediate concern that is relevant to your work, I'm just wondering, what are you most concerned about, or what are you most? How do you see it relevant to this, like to the digital preservation realm? Did anyone who wanted to put up their hands want to share? Okay, Peter, or was there somebody else? Karen first.
It's probably just something as basic as like trust with your the people who use your services, like just as something, like, all it takes is one article to come out where you receive what should be a trustworthy, authentic record, and it's there's like a gotcha moment. This was completely generated and it was a fraud. And that could be very difficult to come back from when you're saying, you know, or going towards trustworthy digital repository status, and that's a pretty bad black mark against your name. And I know it's kind of a different context here, but I just think that's something that I know I would care about.
Yeah, definitely. That's a concern of her, like in terms of like AI, generative AI materials seeping into your collections like unknowingly, and being misidentified. Yeah, Peter.
I was actually going in a similar direction of like, it's not something that you figure out right now, but it's like piling up things like these, the 10 most something clips on YouTube, which are very often like algorithm generated, not generated by AI, but you're shaping stories. And by watching these stories, and if they just pile up for edutainment or whatever, you basically create realities subconsciously. And at some point, it's like, blah, 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 says who. And that's what we archives are for, as like the keepers of what we think is like a reference. And then we don't know. And it just got like, we didn't realize it already has been forged.
Yeah. Yeah, what other concerns do people have? So, yeah, in the back there.
Kind of similar thread in terms of bringing in new collections. So I work at the State Library of New South Wales in Sydney, and we actively acquire digital photographs. And it's been a journey to train acquisition staff on how to identify whether those photographs meet our technical specifications. So I'm just thinking, well, do we now need to think about checking if it's AI generated or not? So it's kind of another level of technical skill that we'll need to develop and then potentially train our acquisition staff in.
Yeah. Yeah, so like just like introducing any new format or any new type of medium, like developing all of those new protocols, all of that stuff all over again to deal with this new form of media, how we describe it. You know, how, I mean, do people have concerns about, you know, their collections being used to train these models? Is that a concern? Or on the flip side, is it important for you to make sure that archival collections are incorporated into these learning models to make sure that these models are a bit more accurate and a bit more representative? Do people have thoughts on that?
That's where my head was kind of headed there, thinking about collections being used to train models, as you were saying. And there's such a push within collecting institutions to put more and more of their content online. And how do you kind of grapple with that push to do that, and also to make things available under some sort of open license, and having your collections being used potentially in a harmful way?
Yeah. Yep.
Something else that I've heard people concerned about is sometimes maybe the archive has a different perspective of how they want to think about accessibility to AI or how they want to use it, but then maybe their donors are concerned about it, and there might be disagreements there, or maybe the donor, for clarity, wants there to be like clear policy or clear procedures that address that, and archives might not have that yet, or still be kind of formulating that. I think that's another concern that's interesting to reflect on.
Yeah, so thinking about like the access and use of like donor material content that's from in your collections, and like do you care once it leaves your archive how your users are making use of the materials that they're accessing, you know, whether they're using it for, you know, generative AI purposes or malicious purposes. What about like in terms of media literacy that Jacobo talked about? Do you think, you know, as museums or archives, maybe some people work in libraries, like is there a responsibility of this community to play a part in that media literacy work? Like you're saying, you're nodding yes. Oh, do you want to talk into the mic so that people can?
At Smithsonian, it's one of our like pillars of to be a trusted resource. It's like the secretary made it one of our main initiatives of the next,
Oh,
I don't know, century or whatever.
specific to generative AI?
No,
Oh.
just I don't think that was maybe, I'm sure that was on their mind, but that is just like something that is a requirement of, being in, because it's like a museum /
Right.
educational place, so.
Yeah.
But yeah, I think it's a huge importance. I mean, if it's kind of like, if not here, then where?
Yeah, yeah.
So there is this, we've been talking a lot about how AI can be helpful for cultural institutions, for annotation such, but this sort of taps into what the cultural community can do for AI. So to make it, to open the doors to discuss and make audiences more AI literate, but obviously they can do more. They can participate in making sure that there's open source alternatives to closed models, or make sure that in the, using the right imagery when we talk about AI. So there's this initiative, Better Images of AI, that I think is super helpful. And I think cultural organizations should be also, working on many levels for culture for AI.
Yeah, thanks. I mean, one thing you mentioned in the beginning was like the use of AI within archival institutions. And so another concern that I've heard raised is like the impact on archival labor, right? So like when there's like tools that can do description or, like how does that impact our jobs? I don't know if that is, has anyone been thinking about it in terms of that? I mean, does anybody have any thoughts in terms of like creative or like positive potential uses? And okay, Sarah.
Sorry, Yvonne, I raised my hand before you said positive.
Yeah.
That's great. Not positive. I want to bring everyone down now. The reason why I am loath to use these generative tools is the compute power and the impact on the environment.
Right,
And
yeah.
I do a lot of digital storage, but I care about those materials, and I don't care about the horrible Willy Wonka generative AI memes, and I don't want those. So when I think about the kind of archival description that could happen, I mean, a well-written finding aid is a thing of beauty. So, it may happen. It could be maybe at like the item level that we'll never get to because of MPLP. But, I guess I'm just thinking, I do worry about in the rush to try these tools, we're normalizing using something that's not great for the planet. And we all need this planet.
Yeah. We'll take one more before we have to close. Or one or two more? I don't know. Caroline, you're the
time. I think unfortunately.
We're out of time. Sorry.
But this is great, a great push maybe to continue the conversation after we have our closing remarks. Thank you, Yvonne.
So sorry, no time to wait. It's just about done. We just have a couple announcements. We're going to hear from a few of our hosts, past, current, and future. I think first we will hear from our current host, ZKM. Yep, you're welcome.
I wanted to take the chance. I want to take a chance to point you to an ongoing open call for expertise or call for participation. We're having a workshop on new media art archiving next year in February, and we are looking for participants, archivists, programmers, interests, whoever, to work together with us on the connection between new media art archives, between the connection between people, but also between data. So I'm going to send the link to the proposal, to the participation call in the WhatsApp group or via the email list or whatever existing, and invite you all to take part, join us in the task to bringing us together on a archival level.
Sorry, what were the dates you mentioned again?
It's in February 5th to 8th, so 3 days. We have a network of new media art archives, SIGGRAPH archive, the IC archive, the Ars Electronica archive and so on, a file archive from Brazil also. And we're working since 2018 on a network. We're meeting regularly on the ICER. It's a summit on new media archiving, and this time we're joining for a practical approach on a workshop on new media archiving to really get hands-on, coming together, not only talking but doing the connection. So join us, please.
Morgan, Annika, you want to share some words?
I took notes. I didn't know what you were expecting from me. Should I say just thank you? Thank you all for coming. We all say that we are all considered niche communities, and we are like 100 with a waiting list. Look, I mean, no, it was really nice to have all of you here. I found most of you all super brave, and there's something about courage that we heard today, like with the FFV one. And it was more like, I was thinking when Dave also talked about the DAT, and I'm thinking about all my SciQuest collection, because at one point ZKM decided the standard for backup was SciQuest. And so maybe we are brave enough to have SciQuest, because we know, like, if we got it wrong, we have a whole community that will undo and make Blue SCSI exist. And so, yeah, so I was thinking maybe we are brave because we are all together in this standard fight. So thank you all for coming, and it was really nice to be part of the committee this year, and I'm looking forward for next year. Do you want to say something?
It was just really nice to have you all here and to be the host, and yeah, good one for the next year.
And now we have a word from our last No Time to Wait host.
This is rather unexpected, but we wanted to show you a work that we did in the archive. So there is also a book that is mapping the moving image. This is basically about mapping the Czech video art scene, which hasn't been done in such a extensive way before. And so the book is one thing. I can put a link I think in our collaborative note maybe, so if you're interested to really having the book, you can order it. But we also have a catalog online, and you can see the actual works. So we wanted to show this just very briefly. I'm also gonna put the link to the catalog on the collaborative note, and yeah, that's just an inspiration what can be done with it within a small team and 2 years of work.
Oh,
Good to see that.
Yeah,
always same as Czech, okay.
yeah. And there is also an English mutation of the web page, and yeah, if you just indulge into scrolling, there is plenty of the Czech works since the I guess 80s until nowadays. We were so lucky that after the end of the project, we still had to keep some people who were working on the project so we can collect more video artworks in the archive, and this is kind of like
yeah, just an example, you know.
yeah, let's see something.
want to finish it, I mean, we can, but
Yeah.
we don't have to you are interested.
The book is here for you to still view. It's been here for like the whole endurance of this conference. 2 copies are staying at ZKM, so if you really want to like come back and see for yourself. Yeah, that's it. Thank you very much.
And now we're going to talk a bit about next year's season 9 of No Time to Wait, which will occur in 2025. To do that, I'm going to introduce the person who will introduce the host institution for No Time to Wait 9. This next speaker, personally, I find to be completely wonderful, kind and encouraging from every interaction. And I'd say that seeing their name pop up on any listserv discussion or Rowdy forum is often a great source of comfort. And I don't know, I always just find like this real ideal balance of like both vision and encouragement from this person. They were involved in the very first No Time to Wait, even when it was called the quote, yet to be named Matroska FFE1 DigiPres event. And they will be key in the next one. So please welcome Kieran O'Leary.
Hey folks, so as Dave said, I've been kind of kicking around since No Time to Wait 1. And I realized today I've been asked the same question every year, usually by Rita Cromer, who also asked the question today, when is No Time to Wait going to come to Ireland? And the answer is next year. So and I'm really sorry, Rita, that I said it was going to be coming very soon. So it should be, let's say, late 2025 direction. I just want to call attention as well to our web archivist, Maria Ryan, our head of digital collections, Owen O'Carrigan. I'm the digital repository services manager. It's a new job title. I still haven't learned it off. So here's some images of the front of the library. But the thing about us is, like, we're as much an archive as a library. We were founded in 1877. With a mission to collect, protect, and make available the recorded memory of Ireland, which is now obviously increasingly digital. So we have published archival special collections, but an increasing amount of digital material, whether that's our web archiving program, our Born Digital Archives, that's like literary archives, Born Digital photographs, data sets, you name it, it's increasing all the time. And of course, our digitization program. Some kind of DigiPres related stuff. We just formed a brand new digital preservation and repository services team, which I'm proud to be the team lead of. We published our first digital preservation policy last year. We're going to be refreshing all of our collection management systems, library management system, archive management system, and a brand new digital repository system over the next 12 to 24 months. So like, it's perfect timing. We're really engaged with the community as well, and we want to be even more so. We put on an annual kind of like sectoral event, getting Irish folks together every year. We're actually doing it the 25th of September this year as well. And next year's event will be No Time to Wait. So it's going to be amazing that we're kind of going to roll it out to a more global community. So here are some images of potential. This is the art room, very pretty. This is a potential workshop location. Here is the main reading room, which is particularly beautiful, I think. If you're into Ulysses or James Joyce, it's worth seeing this anyway. Part of Ulysses is set in the National Library. And I suppose I just want to say as well, like, I'm so proud not only that it's going to be in the National Library, but that it's going to be just in Ireland. Back when I came to No Time to Wait 1, I didn't have any qualifications in this field. And it was a place for me to get some legitimacy, like, you know, the idea of transcoding DPX film sequences to FFE1, that was kind of a scary thing. Myself and Rito presented on it. I was very insecure about it and was saying, like, this is just an experiment, you know, like, don't freak out, you know, like, DPX and tarring is the way to go. But, like, this was the safe space and it was the place to do that kind of thing, to talk about using scripts to perform audiovisual workflows and that kind of thing. I can't think of any other place that would have taken someone like where I was at that level. And I think, I hope that all of you here will come to Dublin. People who might be online, who have never attended one, please come. And not only come and sit, but like speak, do a lightning talk, do something. If there's any aspect of your work where you feel like you haven't seen someone blog about it, If you saw something today where you're like, you know what, I've actually been doing something kind of similar to that, please come to No Time to Wait, speak. It's a safe space, it's a beautiful community, and we are so looking forward to seeing you. And I'm just going to say thank you, and see you soon, or as Gaeilge, go raibh míle maith agat agus slán go fóill. Cheerio.
Thank you for accommodating the Gaelic for me, Kieran. That was my request. Appreciate it. Okay, thank you so much, everybody. These have been truly inspiring 3 days. It's so great to see you all, new faces, old faces. I would like to thank the organizing committee of No Time to Wait. We do all of this online, and we just see each other once a year. So I want to thank Dave, Jerome, and Valeria. There she is. I want to thank our hosts, ZKM, especially Annika and Morgan. I want to thank all the speakers, all the volunteers, and everybody online. So I want to obviously thank our sponsors. If you think that your institution or your vendor or somebody you know would be interested in sponsoring No Time to Wait, please reach out, talk to us. We need your input, not only on content, but also in dollar and euro signs, potentially. Thank you so much. What else? And then before we all leave, I would like to ask you to come to the stairs into the foyer. We do a group picture. Also, you stayed, so you get one special treat, which is Dave's birthday cake, because it's Dave's birthday today. And I believe the cake is hiding under a chair. So... with a deadly knife. Anyway, we'll have a piece of cake at the foyer after the photograph. So thank you so much for coming. I don't know, we usually, I mean, it's late, I think we all want to go home. But if there's one question for the organizing committee that you may have, or something you want to get out, happy to. No, brilliant. You know where to find us. And then we have to say goodnight to the live stream, or wherever you are live stream. Buona notte, good night, gute Nacht. And yeah, that's it. Thank you so much, and see you next year. Please return your badge. Like, either return it or hold on to it until next year, whatever you're most comfortable with.